Now consider variables concept. So always remember, variable is just like a container which can hold a value inside it. So it can be an integer variable which can hold an integer value. Okay, it can be a string which is capable of holding group of characters. So I'll show you different types of values that you can store inside the variable in Python. So first let us consider an integer value. A is equal to 10. This is an integer value stored inside a variable A. Now consider B is equal to 12.75. Okay. So this is a floating point value that is stored inside variable. Now consider C is equal to hello. This is a string stored inside variable C. Now I'll consider D is equal to, so this time I'll store a boolean value like true. Okay. Now let us print each of these values like print A. Okay. Similarly, I'll print value of B here. Then you can print value of C, and then you can print value of D. So let's run this code and see the result. You can see each of these values are clearly displayed in the output with the help of print statement. And in Python, you can actually perform concept of swapping very easily. Okay, I'll show you how swapping can be done. I'll consider an example for swapping here. So let us consider A is equal to 10 and also consider B is equal to 25. Now we can perform swapping here. So but before swapping, I'll display value of A and B. So just like before swapping, okay, I'll display A value and also B value. So here A is equal to A comma and then B is equal to B value. And similarly you can write A comma B is equal to B comma A. Okay. Now again using these statements we can display A B values. This is going to be after swapping A value and its corresponding B value. Okay. So let's run this code and see the result. You can see before swapping value of A is 10 and value of B is 25. And after swapping value of A is 25 and B value is 10. Okay. Clearly swapping has happened here. Okay. And another way is simply using a temporary variable. Okay. You can store A value first and then you can store B value inside A. Now you can take the temp value back to B. Okay. So now also you can run and get the same result, which is before swapping A value is 10, B value is 25. And after swapping A value is 25 and B value is 10. Okay. So these are all using simple assignment operations. And also remember, you can perform multiple variables corresponding assignment in a single line by writing A comma B is equal to 10 comma 25. So let's run this code and see the result. You can see it will take 10 into variable A and 25 is taken into variable B, and later it will display before swapping A B values and it will perform swapping in these three lines and then it will display after swapping A B values here. Okay. So this is how we can make use of variables. So next one is conditional statements and if statement. Okay. So whenever you write a condition, you will be using some of the relational operators. So it can be greater than symbol, or it can be less than symbol, or it can be greater than or equal to, less than or equal to, not equal to. So these are all comparison operators or relational operators which are used while writing the conditional expression. So now let's see this if statement. The general syntax of the if statement is if followed by conditional expression. And if this conditional expression is evaluated to true, in that case, the block of statements will be executed. That is, body of the if statement will be executed. Okay. Suppose if this condition is evaluated to false, then it will not execute block of statements, but it will directly go out of this block. Now let us consider this example. X is equal to int of input of what's x. So first you are taking value of x and then you are taking value of y. Now you are checking the conditional expression x less than y. If this conditional expression is evaluated to true, in that case the associated block of statements will be executed, and in this block it will print x is less than y. Okay. So let me give you an example to understand this much better. So first x is equal to, okay, and in the output screen you will see what's x, and you will enter value of x. So let us suppose value of x as 10, and later it will print what's y, and let us suppose you are entering value of y as 20. Now x value is currently 10 and y value is considered as 20. Now if you look at this conditional expression x less than y, which is a 10 less than 20, condition is true, associated statement will be executed, which means it will print x is less than y. It will print x is less than y. Next, consider this program where you will see multiple conditions. Okay. So let us understand this code. First value of x is taken and then value of y is taken, and later it will check x is less than y or not. If suppose x is less than y and this condition is true, then it will print this statement, which means x is less than y will be printed. And later it will again check this conditional expression x greater than y. So whenever this is true, then this will be false, and also this will be false, isn't it? Any one of this condition will be evaluated to true, isn't it? So let's see here different values of xy combination. So let us suppose x is equal to 10 and y is equal to 20. So in this case 10 is less than 20, condition true, and it will print x is less than y. Okay. Suppose if you are considering x is equal to 20 and y is equal to 10. In this case 20 less than 10 condition will become false and 20 greater than 10 condition becomes true, and it will print x is greater than y. Suppose consider x is equal to 5 and y is equal to 5. In this case you can observe x less than y will be false and even x greater than y will be false, but x double equal to y, that is 5 double equal to 5 condition will be true, and associated statement will be executed, which is x is equal to y will be displayed. Okay. So this is how it will work. Clear? Yes, sir. In this video, we'll write a sample program related to if statement. Okay. So let me explain the problem statement. Generally, whenever a student gives a test, the marks obtained by the student out of 100, it should be lying between 0 to 100, isn't it? So I can say marks are always lying in the range of 0 comma 100, isn't it? Inclusive of both 0 and 100. And the marks cannot be greater than 100 for a test out of 100 marks. Yes or no? If a particular test is conducted for 100 marks, the marks cannot be greater than 100 obtained by the student. And also it cannot be less than 0. So we'll test this particular condition. Okay. So I'll read marks of the student here. So int of input of, I'll prompt the user to enter marks obtained in a test. Okay. And this test is conducted for 100 marks. Okay. Now we have to check whether the user entered marks is valid or not. Okay. Or it just needs to display a message saying that invalid marks whenever the marks is not lying in the range of 0 to 100. So for that I will write a condition here. So if marks are less than 0 or marks are greater than 100, in that case you can just print a message saying that invalid marks. Okay, invalid marks. So let us run this one. Okay, enter marks obtained in a test. So let us suppose user has entered marks as 90. Okay, so just marks is entered as 90. In that case it has to produce nothing because 90 is valid. Okay, now let us suppose user is entering marks as -5. In such case it will produce invalid marks. So let us run this one more time, and this time user is trying to enter marks as 126, which is again invalid. So this if condition is very useful in order to judge the marks are invalid. Okay, whenever the marks entered by the user is either less than 0 or greater than 100, in such case it has to display invalid marks. Okay, so this is how you can write if statement in Python. So next one is if else statement. In case of if else statement, this is the general syntax of if else statement. Okay, so first it will check the conditional expression. If this conditional expression is evaluated to true, then this block of statements will be executed. Suppose if this condition is evaluated to false, then it will go to the else block and it will execute block of statements which are inside this else block. Okay, so let's see an example here for if else statement. Now in the output screen it will display what's x, because we are writing inside this input function to prompt this particular message. And the moment you enter value of x, let us suppose you have entered value of x as 7. Now this 7 will be taken into x and it will check this conditional expression, that is 7 mod 2 double equal to 0. Condition true or false? Condition will become false. Now it will go to the else block and it will print odd. Okay, in this case it will print odd. Now let us consider another scenario where you are considering x value as 6. Okay, so in this case again it will check this conditional expression 6 mod 2 double equal to 0. condition will become true. So the associated statement will be executed, which is even will be displayed as part of the output in this case. Okay. In this video, we'll implement a program which checks whether two given values are same or not with the help of if-else statement. So first, take two values as input. Consider A is the variable. For taking the first value, int of input of enter value 1. Okay. Similarly, B is equal to int of input of enter value 2. Okay. So after entering A, B values, now you need to check whether these two values are same or not. This can be done with the help of if-else statement. You can write A double equal to B. If suppose A value and B value are equal, in that case, you can display a statement saying that given values are same. Okay. If suppose two given values are different, in that case you can display the same inside the else block saying that given values are not same. Okay. So let's run this code and see the result. Enter value 1. I'm entering value 1 as 5 and value 2 as 9. You can see 5 and 9 are different, so it will display given values are not same. So now let us run this code one more time and enter value 1 as 4 and value 2 also as 4. So this time this will show you given values are same. Okay. So next one is elif statement. Whenever you want to write multiple conditions, we can go for elif statement. And this is considered as multi-way selection statement. Out of multiple blocks, one block will be executed. So let's see the syntax of this if elif else statement. So look at this syntax. First condition 1 or conditional expression 1 will be executed. If this is evaluated to true, then this code block will be executed. That is, code block 1 will be executed. Suppose if this condition 1 is evaluated to false, then it will check condition 2. If suppose this is also evaluated to true, okay, then code block 2 will be executed. So what happens when conditional expression 1 is evaluated to false and also conditional expression 2 is evaluated to false? In that case, it will directly enter into the else block and it will execute this code block 3. Okay. So you can observe only one block out of these 3 blocks will be executed. And whenever you want to write more and more conditions, then you can write similarly with the help of elif. Okay. So we can say this particular part can be repeated. Okay. Now let's see this example of considering x and y values. So in the output, first it will display what's x. Let us suppose you have entered value of x as 5 and also value of y you are entering as 5. Now it will check this condition 1, which is 5 less than 5. Condition becomes true or false. So condition will be evaluated to false. Okay. Suppose if this condition is evaluated to false, then it will go for this condition x greater than y. 5 is greater than 5. Condition becomes again false. Now it will go to the else block and it will print x is equal to y. Okay. So this is the output in that case, isn't it? Now consider another case where you will take different values of x and y. Okay. So consider in this case I'm taking x is equal to 3 and y is equal to 9. Okay. Now you see this condition 1 or conditional expression 1. 3 less than 9. Condition becomes true. and it will print x is less than y. Okay, so let us suppose we are considering different values of x and y. Okay, x value I am considering as 13 and y value as 9. So now first condition, 13 less than 9, condition will become false. So it will go to this block and it will check 13 greater than 9, condition becomes true, and it will print this statement, x is greater than y. Okay, it will print x is greater than y, like this.
Hi, in this lecture we will talk about optical flow, which is one of the most important techniques that we should know before moving to learn how to convert our video into animation. Firstly, what is optical flow? Optical flow shows the movements of the pixels between two frames. For example, let's say that we have these two frames. This is the first one and the second one. The optical flow for these two frames is this one. This optical flow will tell us which pixel in the first frame moved in the next frame, and the direction of movement and the amount of movement. So as you can see here, all the pixels that represent this card, they moved in a specific direction in the next frame. So each one of them has its own vector that represents the direction of movement and the amount of movement. We will call all these vectors that represent the movement of each pixel by optical flow. In 2015, they started using deep learning to solve optical flow tasks. They tried to train a U network to find the optical flow from two images or two frames. The structure of the U network that they used, it is this one here. We will pass the first frame of our video through this branch here. There are many convolutional layers in this branch. We will pass this image through them, through all these layers, all these convolution layers. And we will do the same thing for the next frame of our video. We will pass it through this branch, all these convolution layers. And here we will do a special thing. We will find the correlation between these feature maps. So how can we do that? To understand the idea behind this correlation layer, we should understand this formula here. Firstly, here we want to find the correlation between two patches. One of these patches is available in F1 feature map, and the other patch is available in F2 feature map. The center of the first patch, it is x1, which in this case it is this location here. The index of this location is 1, 1, and the center of the other batch is x2, which is this location here. The index of this location, it is 2, 3, because as you know in Python we start with index 0. So the row of this center, it is equal to 2, and the column of this center, it is equal to 3. Now what we will do actually, we will do dot product. This symbol here for dot products. Okay. This formula here will multiply this patch with this patch element wise, and after that it will add the results to get just one single value, which is something similar to the convolution operation that we talked about previously. Here, this patch in F1 feature map, it is like a kernel that we will multiply with this patch in F2 feature map. So this operation is something similar to convolution operation. Now after applying this formula, we will get just one single value. This value will represent the relationship between this batch and this batch. So now we are doing matching a process, which is something very important in optical flow. When the correlation between these two patches is very high, it means these patches, they are very similar to each other. And by doing this, we will be able to know that X1 batch, it is just moved and created X2 batch in feature map 2. Our neural network will try to learn these correlations. And by using these correlations, we will be able to match between batches. Here we took just one single example about how to compute the correlation. But actually, we will find the correlation of this batch with all possible batches in this feature map too. And we will go to another batch here and we will find the correlation between this batch and all possible batches in F2. And when we want to find the correlation between, for example, the first batch in F1 feature map and all batches in F2 feature map, we will get new feature map. And when we want to find the correlation between the second batch in F1 feature map and all batches in F2 feature map, we will get another feature map in the output. Okay, so we will get very large number of feature maps. So now the depth dimension of the output will be large, which is equal to the possible patches inside of one feature map or possible patches inside F2 feature map. As you can see here, these two feature maps, F1 and F2, they have the same size. So now we have very large number of feature maps in the output. Our output is very large and that's not good. We did a lot of computations to get this output. This thing will take time, and if our output is very large, so it will take a lot of our memory also. All these things, they are not good. So what we will do here, we will reduce the spatial dimensions of the output. How can we do that? The idea is super easy. Here we will not compare this batch with all possible patches in F2, but with the nearest batches in F2. So here what we will do, we will restrict the search space. For example, here we have our batch, which is X1, in this case, this one here. Here we will not find the correlation between X1 and all X2 patches, but we will find the correlation between X1 with the nearest X2 patches to our X1 batch. In other words, here is our X1 batch and here is the center of this batch. Let's say that the displacement, the maximum displacement, equal to 1. By doing this, we will restrict the search space. Now we will find the correlation between this X1 with this batch here that has the same center of X1 batch. Okay? And this batch here, which moved just one step from the center of X1. So now we have two batches, and this batch here also we have 3 batches, and this batch here, so we have 4 batches. So in other words, we will just find the correlation between this batch with the patches that are near to the center of our X1 patch, but in F2 feature map. So here we didn't take all patches in F2 feature map, but just a few of them. So here we reduced the computations, because here we will not use this formula a lot. And we will take another patch in F1 feature map, and we will find the nearest patches in F2 feature map for this patch in F1 feature map, and we will do computations to find the correlation, and we will do this process again and again until reaching the last patch in F1 feature map. By doing this, we will reduce the size of the output from our correlation layer, and we will speed up our network because we will reduce the computations. But the problem here, you will not be able to match any patch in F1 feature map with very far patch in F2 feature map. So for example, if you have very fast object in your video, if you use this correlation layer, you will not be able to match the batches that are related with this object in the first frame and the next frame. So you will not be able to get the correct optical flow for this object. And we will pass the output from this correlation layer through many layers, and we will pass the output through this refinement part of our network. This refinement part will increase the spatial dimensions of our optical flow by using up convolution layers. And here's the output optical flow feature map. You can see the resolution of this optical flow. It is not similar to the resolution of the input frames. And they found that adding another convolution layers will not be helpful. It will increase the spatial dimensions of the optical flow, but it will be something similar to any other simple resizing methods. So for this reason, they use the variational refinement to make the resolution of the optical flow similar to the resolution of the input frames. In the next lecture, we will talk about GM flow method to find optical flow. Thanks for watching.
Next one is we'll write a program in order to find the relation among two given numbers. Okay. So the relation between two numbers can be like both the given values can be same, or the first value is greater than the second value, or it can be second value greater than first value. So let us implement here. First we'll check A value and B value. A is greater than B, and here we can print A is biggest. Okay. And we can write one more condition here, elif A double equal to B. Okay. So whenever A, B values are same, in that case we can display both the given values are same. Okay. Suppose if this condition is also evaluated to false, then finally we have a else block which can display B is biggest, because A is not greater than B and also A is not equal to B. In that case we can say clearly B is greater than A, so it can print B is biggest. Okay. So let's run this code and see the result. Enter value 1. I am entering value 1 as 19 and value 2 as 28. And you can see this is printing 28 is biggest. And enter value of 1. Okay, that is first value you have to enter. This time I will enter value as 9. And even value 2 is 9. In that case it will display both the values are same. So in the next case, consider A value as 9 and B value as 4. So this will display 9 is biggest. Okay. So all the three different cases we have covered, and this is how this program works with the help of elif statement. Next one is nested if statement. In this nested if statement, we write if statement inside another if statement, which is known as nested if. Okay. If within another if statement is considered as nested if statement, and if you look at the syntax of this nested if statement, if conditional expression 1, if suppose this conditional expression 1 is evaluated to true, then associated block of statements will be executed, that is statement block 1 will be executed, and later it will check the conditional expression 2. If suppose this is also evaluated to true, then statement block 2 will be executed. Okay. So what happens when this conditional expression 2 is evaluated to false, then it will not execute this statement block. And what happens when this conditional expression 1 is evaluated to false? This condition 1 is evaluated to false, then it will not enter inside this block. Okay. So let's see an example quickly for nested if statement. You can see this is the example. First, we are prompted to enter any value. Let us suppose you are entering value as 7. Okay. Now, number value is currently 7, and this will check this conditional expression. 7 greater than or equal to 0. Condition becomes true. So, the associated block of statements will be executed. And inside this block, you can see number double equal to 0. It will check this condition also. 7 double equal to 0. Condition will become false. Now it will go to the else block and it will print number is positive. In this case, you will see number is positive, which is printed as output. Okay. Now let us consider another case. Okay. Consider number value is -4. Now -4 greater than or equal to 0. Condition will become false. So it will go directly to the else block and it will print number is negative. Okay. So in this case, it will directly print output as number is negative. Okay. Now consider another case where number is 0. Okay. So let us consider number is 0. In that case, first it will check this condition. 0 greater than or equal to 0. Condition will become true. Okay. Now it will check this condition. Number double equal to 0. 0 double equal to 0. Condition becomes true. Okay. Associated statement will be executed, which is number is 0. In the output, it will display number is 0. Okay. So this is how nested if statement will work. In this example, we'll see how to write a nested if statement. So for this purpose, we'll implement code in order to find biggest among two given numbers. Biggest among two given numbers using nested if statement. Okay. So very simple. Here I'll keep on adding cases, like there can be a couple of cases where A is greater than B, the other case is B is greater than A, and there is one more case where A and B are same. Okay. So let us first read value of A and value of B. Okay. So enter value 1. Okay. Now similarly, I'll also read B value here. So which is enter value 2. Okay. Now we'll first check like this. If A is not equal to B, so then only we are going to check whether A is greater than B or not. If suppose A is greater than B, in that case I'll print A is biggest. Suppose A is not equal to B and also A is not greater than B. In that case we can say clearly B is biggest. B is biggest in that case. And also we can write one more case which is an else block here. Whenever A is not equal to B, in that case you can have a print statement saying that both A and B values are same. Okay, both values are same. Okay, so just like this. And one more thing is suppose you want to print exact value, in that case you can write A here. Okay, and similarly here also I want to print the exact value, then I'll write B here. Okay, so let's run this code and see the result. Enter value 1. So I'm entering value 1 as 15 and value 2 as 46, and you can see the result is 46 is biggest. So now let us enter value as 12 and another value is 7. Okay, and you can see the result 12 is biggest. Okay, now in this case I'll give equal values, that is same value. Consider 10 is the value 1 and value 2 is also 10, and you can see the result both values are same, that is going to be displayed here. Okay, so this is how you can write a nested if statement. This is considered as the outer if statement and this is considered as an inner if statement. Okay, so control enters inside this inner if and only if outer if condition is evaluated to true. Okay, if suppose the outer if condition itself is evaluated to false, then it will directly enter into the else block and execute this statement. Okay, in this video we'll discuss about while loop in Python. So first, this is the syntax of the while loop. While followed by conditional expression. If suppose this conditional expression is evaluated to true, in that case these statements will be executed repeatedly until this conditional expression is evaluated to false. Okay, so I'll show you here clearly how this syntax can be expanded. So whenever we write any loop, generally we write initialization statement, then conditional expression, and also update statement. So for this construct, you can see initialization. This is going to be an initialization of the loop variable, and after that we will write while conditional expression, and when this condition is evaluated to true, then block of statements will be executed. And we have this block of statements. One of the statement will be update statement. So this will update the loop variable so that it will move to the next iteration. So let's see the corresponding flow chart for this. Okay. So if you consider the corresponding flow chart here, for while loop, first consider initialization. Okay, initialization will be done. After initialization, it will check the conditional expression. Suppose if this conditional expression is evaluated to true, in that case block of statements will be executed. Okay, so this is block of statements will be executed, and one of the statement will be the update statement. So after executing this update statement, control is transferred back to execute this conditional expression. And the moment the conditional expression is evaluated to false, it will go out of the loop. So let us suppose statement X is lying outside the loop, then it will execute statement X. So this is the flow of execution for the while loop. Okay. Now let's see an example for the while loop. So consider this example, and you can see in this example clearly value of I is considered as 0. First it will execute the conditional expression. So 0 less than 3 is executed, condition true or false, condition true, and associated block of statements will be executed. So which means in the output it will display hello, and after displaying hello I value will be incremented by 1. So value of I will become 1. Now 1 less than 3, condition true. When this condition is true, associated block of statements will be executed. Again hello will be displayed. In the next iteration I equal to I plus 1, value of I will become 2. 2 less than 3, condition becomes true. Again block of statements will be executed. Hello will be displayed. And after that again I equal to I plus 1. So this will be 3 less than 3. This time conditional expression is evaluated to false. So the block of statements will not be executed. So overall this will be the output. Okay. So consider the next one. Now we can also use else block along with this while loop. Okay. So let's go through this program. First I is equal to 0. Initially value of I is 0. And look at the conditional expression I less than 4. 0 is less than 4. Condition becomes true. And it will modify I value. So you can see I is equal to I plus 1. 0 plus 1 value will become 1. And then it will print value of I. So in the output this will display value of I as 1. In the next iteration value of I is currently 1. 1 less than 4, condition becomes true. I equal to I plus 1. You can see 1 plus 1 value will be 2. So now it will print 2 also. In the next iteration I value will be currently 2. 2 less than 4, condition becomes true. I is equal to I plus 1. 2 plus 1 value will become 3. Now value of 3 will be displayed. And in the next iteration again you can see here since value of I is 3, 3 less than 4, condition becomes true. Okay. Now I is equal to I plus 1. This will be 3 plus 1 is equal to 4. And it will print 4 also. Okay. So after printing 4, now it will check again conditional expression. This time it will be 4 less than 4. Condition will become false. So it will go to the else block and it will print this statement. It means no break will be displayed. No break will be displayed here. Okay. So this is how it will work along with the else block. Yes, next one is we need to write a program in order to display the count of digits in the given number. So if you consider the given number like 158, how many digits are there in this number? This is one digit, this is second one, this is third one. So total there are 3 digits in the number, right? So finally you have to display the output as count of digits is 3. Okay. So let's solve this one. So first of all you need to read the input. Okay. So consider n is the variable which is used to store that value. Okay, so int of input of enter any number. So that is what shown in the input. Okay, now once the user enters the number, we have to count how many digits are there. So for that purpose, I'm taking a variable called count and its value is 0 initially. Okay, so let's write a while loop here. Okay, so while this n value is greater than 0, so we can actually extract the data. Okay, so digit by digit we need to extract here. So first consider d is equal to n mod 10. Okay, so we are going to extract the last digit and then immediately we are counting it. Okay, so we don't even need to extract the last digit, just simply perform counting. So write count equal to count plus 1 here. Okay, now remove the last digit, that is enough. N is equal to n double slash 10. Okay, so we are removing the last digit. In the next iteration we are counting the second digit also and we are removing that digit. Okay, and so on like this. So finally the count is actually available inside a variable called count. Now we can print. Okay, so in the output you can see count of digits. So this is what given. So the same thing I'll write here. And the count is represented with the help of variable called count itself. Okay, so let's run this code and see the result. Enter any number. So I'm entering a number as 158 and you can see the result, that is count of digits is 3. Suppose if I run for another number like 12,456, so you can see count of digits is 5. There are 5 digits in this particular number, isn't it? Like this. Next one is we need to write a program in order to display the multiplication table for the given integer. So consider this input here, 15 is given as input. Now the expected output is you have to display the multiplication table for 15. Okay, so 15 into 1 equal to 15, 15 into 2 equal to 30 and so on up to 15 into 10 is equal to 150. Okay, so let's implement this program using while loop. Okay, so first the idea is to read the number, right? So this is what expected. Okay, so just copy this content. Now read the number. Okay, number is equal to, take this input and use the same statement. Okay, so after taking the number, now the idea is to display this output similar to this exactly. Okay, so let's try this. Starting from, you can see value of 15 is constant here. Okay, but varying value is 1, 2, 3 up to 10. That we have to consider in a variable, that is 1. Okay, is taken into loop variable I. So this loop must be iterated up to 10, I less than or equal to 10. Okay, now whenever this condition is true, we have to display this. Okay, so 15 into I, basically value of I will be iterated from 1 to 10 and corresponding result. Now while printing, let us print like this. Okay, so the first value must be number. Okay, so you have to display like this, number. and into number into I, okay, is equal to result is what? Number into I. And after this we have to increment value of I, so which is I is equal to I plus 1, isn't it? Okay, so let's run this code and see the result. Enter the number table to be calculated. I'm entering value as 15. Now see the result. So this is the result that is expected, okay, in the problem statement, isn't it? Okay, so we got the exact result. This is how we can actually print the entire table for the given number. Okay, now in this video we'll discuss about concept of for loop. Okay, so let's see here. In Python we write for loop using this particular syntax. So for followed by variable in iteratable, so it can be a list or it can be a tuple, or you can generate a list of elements also. Okay, and you can in fact use range function. Okay, and these statements are considered as part of this for loop. So whenever this condition is met, immediately this block of statements will be executed. Okay, so let's see this example clearly how this is going to work. So this comes under range function. Using range function, whenever you write a range function with a single parameter like value, then this range function is going to iterate or generate values starting from 0 up to less than this value. I can say up to value minus 1 it will generate. Okay, so from this for loop you can see this loop variable is going to generate numbers starting from 0 up to value minus 1, which is 10 minus 1, it is 9. So in every iteration it has to print value of I, which means in the output this is going to display value of I value, which is 0, and then 1, then 2, and so on up to 9 it will display. Okay, so next consider this example. So in this example you can observe total equal to 0 initially, and this is the for loop and the range function with two parameters. So there is another syntax for the range function with two parameters where you have to mention first parameter as a start and the second parameter is end. Okay, now this is going to iterate from the starting up to end minus 1. Okay, so which means here this is going to generate range of values starting from 1 up to 5 minus 1, which is 4. Okay, so this actually considers I is equal to 1 in the first iteration, and it will add this I value to total. This will be 0 plus 1, which is 1. In the next iteration I value will become 2, and this will add this I value, which is 1 plus 2, value will be 3. In the next iteration it will consider I value as 3, and this will add like this, total equal to total plus I, which is 3 plus 3 is equal to 6. In the next iteration I value will be 4, so this time total is equal to total plus I, which is 6 plus 4, value will be 10. Okay, so in the next iteration I value will become 5, and 5 is basically outside this range. Okay, and finally this will display value of total in the output. So in the output you will see total value as 10. Okay, just like this. Now consider this example of using for loop with else block. Okay, so let's see here how this is going to work clearly. Now I'll consider this for loop starting from I value from 1 to up to less than 4. So this will work up to less than 4, which means whatever values that will generate will be 1, 2, 3. Okay, these are the values generated for variable I. Okay, so in the very first iteration I is equal to 1. So this is going to display I value which is 1 as the output. It means in the output this will display 1 as value. In the next iteration I value will become 2. Again that is in the range, so that will also print 2. In the next iteration I value will become 3. So that will print 3 also. In the next iteration I value will become 4, and 4 is out of this range. So this will go to the else block now and it will print no break. Okay, this is going to print no break. Clear? So this is the corresponding output for this program. Now we can also make use of this for loop in order to access the list of elements. First understand how you can write list of elements. So consider students is equal to, I have written list of elements like John, Harry, Ron, like this. Now I'm going to print this students of 0, which means this is the index for this particular item inside the list, and this is the index, and now this is the index for this item inside the list. Now the moment I print students of 0, then in the output this is going to display the first student, which is John. Okay, and later it is printing students of 1, which means Harry will be displayed, and later students of 2, now it will display Ron. Okay, this is how it will display list of elements. Next, how can I access these list of elements with the help of for loop? So simple, you can also write this list of elements and start accessing with the help of for loop. So for student in students list, so this actually considers this list exactly and iterates over this list of items. So in the very first iteration, it will consider the very first item inside the list and it will display. So the output is similar to the previous program, but in this case, we are accessing with the help of a for loop in order to display all these items inside the list. So after printing the first student name, then second student name, and then third student name, like this. Okay. So this is how you can make use of for loop in order to access the list. Okay. Yes, sir. In this video, we need to write a program in order to display the numbers from 1 to n. So for this input, enter value of n. Let us suppose value of n is entered as 10. In that case, the output must be displayed starting from 1 up to 10, because 10 is representing the n value. And you can see this program is to display the numbers from 1 to n. Okay. So let us implement this program using for loop. So first you have to read value of n. Okay. So using input method, you can read by prompting the user to enter value of n. Okay. So once the user enters value of n, using for loop, you can iterate and display numbers up to n. Okay. So for I in range of, okay. So starting from 1 up to n, which means the stop value must be n plus 1, so that it will iterate up to less than n plus 1, that is starting from 1 up to n, it will iterate. In every iteration I am going to display value of I. Okay, and I'll give some tab space. Okay, not exactly tab space, a single space. Okay, suppose if you want to give any tab space, then you have to write /t, but right now I want only a single space. Okay, so let's run this code and see the result. Enter value of n. Okay, I'm entering value of n as 10, and you can see the result. This is going to display starting from 1 up to 10. Okay. Yes, in this video we'll discuss about working of break statement and continuous statement. So first, consider a sample loop and display list of values by iterating using that loop. So let us consider the for loop for I in range of okay. So 1 comma 10. I want to display these numbers one by one. Okay. So let's run this code and see the result. You can see the range is from 1 comma 10. So it will start displaying numbers starting from 1 up to 10 minus 1, which is 9. So this is the corresponding output. Now, if I start writing the break statement, okay. So let us suppose here I am writing the break statement. If I value is equal to 5, in that case I am going to break this particular loop. Okay. Now let's run this code and see the result. In this case you will see the result as 1, 2, 3, 4. Why? Because whenever I value becomes 5, its corresponding condition is true, and obviously the statement, that is break statement, will be executed. It means control will be transferred outside the for loop. Okay. Now let us consider an example for continuous statement. Let us suppose I am replacing this break statement with continuous statement, and let's run this code and see the result. So the moment I value is matching with 5, it executes continuous statement, which means it will skip the current iteration and proceed to the next iteration. So that is why you are not able to see value of 5 in the list of values. Why? Because for all the other values, this condition is going to be false. So it will print value directly. But for I equal to 5, this condition becomes true. An associated continuous statement will be executed, which will skip the current iteration and proceed to the next iteration. Okay. So that's why you are not able to see I value as 5 in the output. Clear? Like this. So in this video, we'll write a program in order to find the sum of first 10 natural numbers. Okay. So let's start making use of while loop and solve this problem. Okay. So first, what is the initial value? I'll consider I is equal to 1 because this is sum of first 10 natural numbers. So the last value should be 10. So I'm going to write I less than or equal to 10. Now when this condition is true, we have to perform sum of those numbers. For that purpose, I'll take another variable like total, and its value is initialized to 0. Okay. So in every iteration, I'm going to add this value to total. So this will be total equal to total plus I. To proceed to the next iteration, I'll increment value of I by 1. Okay. And finally, once we obtain this total, we are going to print the result. Okay. So I can write here sum of first 10 natural numbers is, so the entire sum is basically maintained inside a variable called total. Okay. So we can write the same variable total here. Okay. So let's run this code and see the result. You can see sum of the first 10 natural numbers is 55. you can also start adding these values and see the same result. 1 plus 2 plus 3 plus up to so on plus 10. Okay, so that will give you the result as 55, isn't it? Now write a program in order to display the sum of digits in the given number. So this is the given number 125. Now sum of digits is 1 plus 2 plus 5, which is equal to 8. So the output must be displayed as sum of digits equal to 8. Okay. So let's solve this problem. First you need to read the number. So consider reading using input function. Enter any number. Okay. Now consider a number. First extract digit by digit from the number. Okay. So after extracting each digit from the number, so add that number to this sum. Okay. So for this purpose, I am taking a variable like total equal to 0 initially. So using while loop, we can write n is greater than 0. Okay. So first extract the last digit. From the last digit, you start extracting digit by digit. So d is equal to n mod 10. So after extracting the last digit, now add that digit to the total. So this is total equal to total plus d. Okay. Now we need to remove that last digit because we have already added that digit to total. Now consider n is equal to n double slash 10. So this is used to remove the last digit from the number, and this is used to extract the last digit from the number. So I am extracting the last digit and then adding the last digit to the total, and later removing the last digit because that is already added to the total. Okay. And this is repeated until n value becomes 0. Okay. Now I will display the sum of digits. So you can see in the output, this is the format. I'll use the same format here. Sum of digits. Okay. And the result I'll show here in total. Okay. So let's run this code and see the result. Enter any number. I'm entering the number as 125, and you can see the result, that is sum of digits is 8. Okay. So in the same way, let's run one more time. Enter any number. So the number is 143. Okay. And you can see sum of digits is 8. So let's run a bigger number like 12,763. Okay. And you will get result as 19. It has added each and every digit in this number, and the sum of digits is 19. So like this. Let us discuss about arrays. So we can consider array as a container which can hold fixed number of items. Okay. And all these items must be of same data type. For example, the array can hold all integers or all floating point values, or it can hold all characters. Okay. So the array concept mainly relies on storing elements at various d indices. Okay. So which we call it as a index. For example, this is a sample array containing a total of 4 elements. 1, 2, 3, 4. The elements are like this: 10, 20, 30 and 40. And these elements are stored at various indices. So this is index number 0, this is index 1, it is index 2, and it is index 3. Okay, just like this. Now, what are different types of arrays? Basically, we can classify them into one-dimensional array and multi-dimensional array. So 2D array is an example of a multidimensional array. Now let's see how we can create array in Python. So for example, if you're trying to create a one-dimensional array in Python, so all you need to import is from array. Okay. So you can specify the name of the array and use this array and then pass data type, what is the type of array that you are trying to create, and you are initializing the array here. Okay. Now consider how to create an array, that is one dimensional array in Python. So first you have to import from array, and now the first parameter is indicating I here. It represents integer data type, and the second parameter is a initializer list. So these are the list of elements that are going to be stored inside the array. So you can observe here the entire array contains these elements. Like the first element is 10, second element is 20, third element is 30, fourth element is 40, and the fifth element is 50. Okay. So this is clearly array 1. Okay. So inside this array 1, what are these indices? This is index 0, this is index 1, this is index 2, index 3, and this is index 4. Okay. Now we are going to iterate over this array 1 and display all the elements of array 1. So different elements of array 1 are 10, 20, 30, 40, 50. So if you try to display the output here, okay, the output will be like this: 10, 20, 30, 40, and then 50. Okay. So this is how the output is going to be displayed. Clear? Okay. Now let's see how to access array elements from 1D array. So here we are creating an integer array containing elements 10, 20, 30, 40, and 50. Okay. So this is going to create an integer array just like this, and the elements will be placed one after the other. So 10, 20, 30, 40, and 50. Okay. So name of the array is array 1, and it is index 0. This is index number 1, index number 2, index number 3, and index number 4. Okay. So we are trying to print array 1 of 0 here. Okay. So from this array 1, you have to access index number 0 corresponding element. So in the output, this is going to display 10. Okay. So after displaying 10, now we are trying to print array 1 of 2. That is index 2 corresponding element. Index 2 corresponding element is 30. Okay. So this is how you can also access the individual elements in 1D array.
Hi, in this lecture we will learn how to do style transfer with Python. Firstly, we will import cv2 and we will import transforms package from Torch Vision, and we will download the out of domain image that we will use as a style image. So firstly we will type x0 equal to image.open, and here we should pass the path of our style image, our out of domain image. But actually here we should import this image class. How can we do that? From pil import image class like this. Okay, now we have our out of domain image, our style image, which is our clear image. We will resize our image and we will make the height of this image equal to 256 and the width of this image equal to 256. Here we will specify the device that we will use in forward diffusion and reverse diffusion, which is our GPU. Now we will convert this x0 to numpy array like this. Here we should import numpy as np, and here we will type np.array and we will pass x0. So now we converted this x0 into numpy array. After that we will use transforms.toTensor to convert this numpy array into PyTorch tensor. After that we will add a new axis, and the length of this new axis is equal to 1, which is the batch dimension. Now we will send this image, this clear image, this style image to our device. So we will type x0.toDevice. Now we will make xt equal to x0. Now we are at time step 0. This is our clear image. So we will make xt at time step 0 equal to x0, which is our style image. Now we will import DDIM pipeline from diffusers. Here we will specify the ID of the model that we want to use. Here we will use this model, DDPM Church 256. This model will generate church images, and you can use other model here like this model, DDPM EMA Celebrity AHQ 256. Okay, but now we will use this model, DDPM Church model. We will specify the device that we want to use. Here we will type image pipe equal to DDIM pipeline.from pre-trained. Here we will pass the model ID, the ID of the model that we want to use, the ID of the diffusion model that we want to use, and here we will send this pipeline to our device. Now we have our image pipeline. This pipeline will make it easy to use our diffusion model to generate images. Here we will generate one image. We will call it image1, which is equal to image pipe, and here we will specify the number of entrance steps, and we will make it equal to 50. Okay, here we are using DDIM pipeline. In other words, we are using DDIM scheduler, so we can use very small number of time steps to generate the images. Dot images, and here we will open these brackets and put 0 between them. Now we have our image, image1. So now we generated one image using our church DDPM diffusion model. We talked previously about this function, get x capital using DDIM function. This function will do forward diffusion, and as we said previously, we will use this function to generate xt capital for the out of domain images or in domain images. Okay, now we said previously that we downloaded our style image, and now our style image, it is available in this variable xt variable. Now what we will do, we will call this get x capital using DDIM function. We will pass xt, our style image, the pipeline that we want to use, our image pipeline, and the device that we want to use, which is CODA, our GPU. Now we will get this XT capital. It is the noise that related with our style image. Here we will make XT capital style equal to XT capital. Our style image, it is this one here, okay, which is available here in this place. This is our style image, and XT capital for this style image, it is this noise here. This is XT capital for this X0, this style image. Now, as we said previously in the previous lecture, we can do reverse diffusion using DDIM sampling algorithm to generate our style image again from this XT capital. And now we have our style image. Okay, this is our style image. Now we know that we have XT capital for our style image, for our out of domain style image. Now we will import these packages: CV2, transforms, torch, numpy, and TQDM package. Now we will create our content image, which is in domain image. We will use our diffusion model, our DDPM church model, to generate this image. How can we do that? Firstly, we will take the time steps from image pipe.scheduler.timesteps. Now we have this PyTorch tensor. The first element in this tensor represents the first time step in reverse diffusion, and the last element in this tensor represents the last time step in reverse diffusion, which is time step 0. Now we will create a noise. We will take this noise from the Gaussian distribution, the standard Gaussian distribution. Here we will make XT capital content equal to this noise, because this noise we will use it to generate our content image. So it is XT capital for this content image. Now we have XT capital content, which is equal to this noise, and we will make XT content equal to noise, because as you know, T small here will be equal to T capital when we are at the first time step in reverse diffusion, which is time step T capital. So now XT small content equal to noise, which is this one here, or in other words, XT content equal to XT capital content. Now we will pass it through these time steps. Okay, we will get the number of the current iteration for this loop and the current time step. What we will do, we will take alpha bar t from image pipe.scheduler.alpha as cumulative, and here we will pass the current time step. Now we will check if the current time step it is not equal to 0, it is greater than 0. In this case, we will find alpha bar t minus delta t from image pipe.scheduler.alpha as cumulative. And here we should get the next time step, or time step t minus delta t in reverse diffusion. How can we find this t minus delta t time step? We will use this time steps tensor image pipe.scheduler.timesteps, and here we will pass the index of time step t minus delta t, which is I plus 1. Now we have our alpha bar t minus delta t. But if t it is equal to 0, we are at time step 0. At this case, we will make alpha bar t minus delta t equal to image pipe.scheduler.final alpha cumulative product, which is equal to 1. Now what we will do, we will use our model Firstly, we don't want to update the weights of our model, so we will put this context manager with torch.noGradient. So we will not compute the gradients for anything inside this context manager. We will prepare the input to our model. So a model input equal to image pipe.scheduler.scale model input. Here we will pass xt content and the current timestamp. Okay, here we will compute the predicted epsilon. So predicted epsilon at time step t, it is equal to image pipe.unit. Here we will use our diffusion model. Here we will pass our model input, the current time step, and we will get the predicted epsilon. Now we will compute predicted x0, which is equal to xt content minus the square root of 1 minus alpha bar t times the predicted epsilon divided by the square root of alpha bar t. Here we will use a clamp method to make the lowest possible value inside this predicted x0 tensor equal to -1 and the highest possible value in predicted x0 equal to 1. This image pipe.scheduler.configuration.clip sample range, it is equal to 1. Okay. Here we will compute xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times predicted epsilon. Here we will make xt minus delta t equal to xt content, because now t it is equal to t minus delta t. The current time step it is t minus delta t. And we will do this thing again and again until reaching time step 0. Now we created our content image. This is our content image. We used pil.image.fromArray method to display this image. When we reach time step 0, so now xt content it is x0 content. We will take this image from xt content tensor. As you know, it is a batch of samples. We will take just the first sample. As you know, this batch has just one sample. We will take this sample. We will rearrange the dimensions of this sample. We will put the height dimension firstly, after that the width dimension, and finally the channel dimension. Now we will type pil.image.fromArray. Here we will firstly take this x0, we will send it to our CPU because we can't display this image without sending this tensor into our CPU. After that, we will make the lowest possible value in our tensor equal to -1 and the highest possible value in our tensor equal to 1. We will multiply this tensor by 0.5 and we will add 0.5 to the resulted tensor. Finally, we will multiply this tensor with 255 to make the lowest possible value in our tensor equal to 0 and the highest possible value in our tensor equal to 255. We will convert the elements of this tensor to integers. We will convert this tensor into NumPy array, and we will convert the type of this array into unsigned integer 8. And now we have our content image, which is this image here. Now let's do style transfer. We will take the style of this style image and we will put it in this content image. How can we do that? Firstly, we will get timesteps tensor from image pipe.scheduler.timesteps. Here we will make xt style equal to xt capital style, and we will make xt content equal to xt capital content. As you know, here we will do reverse diffusion. The first time step in this reverse diffusion it is t capital, so t small here, At the first time step, it is equal to T capital. So xt style, it is equal to xt capital style that we created previously. And xt content, it is equal to xt capital content. This xt capital style, it is the noise that related with this style image. This xt capital content, it is the noise that related with this content image. Now we'll create this variable xt new, and we will make it equal to none firstly. We have this gamma variable, we will make it equal to 0.7. We said previously that the best value for gamma variable equal to 0.6, but when you are working with out of domain images as style images, it's better to try many different values for this gamma variable to get the best image. Here we will make editing steps equal to 400, which means that we will stop the content injection if the current time step it is smaller than or equal to 400. Now we will create this loop. We will pass it through our time steps. We will start with T capital and we will end with 0 time step. Firstly, we will take the value of alpha bar T, which is equal to image pipe.scheduler.alpha's cumulative product, and here we will pass the current time step. And we will make this condition. If the current time step it is not equal to 0, at this case, alpha bar T minus delta T will be equal to image pipe.scheduler.alpha's cumulative product, and here we will pass T minus delta T time step, which is image pipe.scheduler.time steps, and here we will pass I plus 1. But if the current time step is equal to 0, at this case we will make alpha bar T minus delta T equal to 1. Okay. Now we will make this condition. We will do content injection if the current time step is greater than edit steps greater than 400. Now what we will do in this content injection, firstly we will find h content. We will create this variable, gate variable, which is equal to content, and here we will prepare the input to our diffusion model. So model input will be equal to image pipe.scheduler.scale model input, and here we will pass xt content and the current time step. Here we will create this hook. This hook we will use it to get the content feature maps from the bottleneck of our diffusion model. So let's create this hook, h content hook. It will be equal to image pipe.unit, and here we will type down blocks, and we will take the final down block, which is down block 5, and inside this down block we have ResNet blocks. We will take ResNet block with index 1, and here we will specify the layer inside this ResNet block that we want to take the feature maps from, which is convolution layer 2. And here we will use register forward hook method to create our hook. We will pass a function. This function it will work on these feature maps that we will get from this conv2 layer. Let's go and see this get h content function. This is get h content function. Firstly, we will make h content equal to none, h style equal to none, gate variable equal to none. Here we will create get h content function. PyTorch package will give us 3 things: the module, the input to the module, and the output from the module. In the other words, the input to this convolution 2D layer and the output from this convolution 2D layer. Here we will take the output from this layer. Firstly, we'll make this edge content variable global variable, which means when you change this variable in this function, this variable will change in any other place, even outside this function. And when you change this variable in any other place outside this function, so this variable will change inside this function as well. And the same thing for this gate variable. We will make this gate variable global variable. So when we change the value of this variable outside this function, so the value of this variable inside this function will change also. We made the value of gate variable equal to content. Okay, so let's see that. Here we made gate variable equal to content, and as we said previously, gate variable, it is a global variable, so its value in this function will change also. And now the value of this gate variable, it is not none but content. So now this condition, it is true, so we will make each content equal to the output. The output feature maps from this layer, from this bottleneck of our U network. And after that, we should remove the hook. How can we remove the hook? We just need to type the name of the hook that we created, which is this one here, edge content hook. Okay, we should type the name of this hook, edge content hook dot remove. By doing this, we will remove this hook. We need to remove this hook to be able to create another hook. Okay, now let's go back to our loop. PyTorch will call this function automatically when we reach the bottleneck of our diffusion model. Now we created our hook that we will use to get the content feature maps from our unit. Now we will use our diffusion model. We will type this context manager inside this context manager. We will use our U network. Predicted epsilon, it will be equal to image pipe.unet. Here we will pass the model input and the current timestamp. So now we used our U network. We will move it through our U network, and when we reach the bottleneck of our U network, when we reach this layer, the convolution layer inside this ResNet block, inside ResNet block with index 1 and down block with index 5, when we reach this layer, PyTorch will call this getEdgeContent function. And here we made gate equal to content, so we will make EdgeContent equal to output. So we will make the output feature maps, the content feature maps in this EdgeContent. And we will remove this hook because we don't need it anymore in this time step, in this current time step. Now what we will do, we will find the predicted x0, which is equal to xt contents minus the square root of 1 minus alpha bar t times the predicted epsilon divided by the square root of alpha bar t. And here you should know that we should not use a clamp method. We should not restrict the predicted x0 when we do content injection, to make sure that we will get good result. Here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times predicted epsilon. Now we will make xt minus delta t equal to xt content. So now we have h content. Now let's take h style. How can we do that? Here we will create another hook that we will use to get the style feature maps from our U-network. How can we do that? We will type hstyle hook, which is equal to image pipe.unit.downblocks pipe.reasonets1.conf2. We will take hstyle tensor from the same layer that we used to take hcontent tensor. Okay, we should do that. And here we will use register forward hook method to create our hook, and we will pass the function that we will use to get the output and the input and the module. Let's go and see this get hstyle function. This is get hstyle function. We will get the module. PyTorch will give us the module itself, the input to the module, and the output from the module. Here we will make hstyle variable global variable, and we will make gate variable global variable. Why? Because we want to use this hstyle tensor in another function. So when we change the value of this hstyle in this function, so we will change this variable in any other place, even outside this function and inside another function. Now when we make gate variable equal to style, so we will make hstyle equal to the output from this layer, and here we will remove this hook. We will activate this function when we reach this layer. Okay, now we have our hook. And here we will check if we are at the first iteration of this loop. In other words, if we are at time step t capital, the first time step. So at this case, we will prepare the input to our model input equal to image pipe.scheduler.scale model input, and here we will use xt capital style, and we will pass the current time step. Okay, if we are at time step t capital, and here we will use our model, and when we reach this layer, so PyTorch will use this hook to get the output from this layer, and we will change hstyle variable based on the outputs from conf2 layer. Let's say that we aren't at time step t capital. At this case, model input will be equal to image pipe.scheduler.scale model input, and here we will use xt_new. Okay, and we will pass the current time step. And here we will use our U-network to extract the style feature maps, hstyle. We can call this tensor now hnew. Here we will combine the style and the contents, or in other words, we will do noise injection. Firstly, we will make gate equal to none. Okay, here we will use our model. If the current time step is time step t capital, or we are at the first iteration for this for loop, at this case, model input will be equal to image pipes.scheduler.scale model input, and here we will pass xt capital style and the current time step. Otherwise, model input will be equal to image pipe.scheduler.scale model input, and here we will pass xt_new and the current time step. And here we will use our model, our U-network, to find the predicted epsilon given ht. We will use this thing here when we want to compute d capital, which is equal to image pipe.unit, and here we will pass our model input and the current time step. Okay, now we have the predicted epsilon given ht. Now we will make gate equal to combine, and here we will create another hook, which is h hat hook, which is equal to image pipe.unit.downblocks, and here we will pass the index of this down block and the index of the reasonable block and the layer that we want to take the values from it. Dot register forward hook, and here we will pass the function combine style and content function that will take the module, the input, and the output. Now let's see this combine style and content function. This is combine style and content function. It will take module, input, and output. And here we have many variables. We have gamma variable, which is global variable, h style variable, which is a global variable, h content variable, which is a global variable, and gate variable, which is a global variable. Here, when we change a gamma variable from outside this function, so the value of this variable will change inside this function. H style also will change based on what we got previously from this getHStyle function, and h content variable will change also based on what we got from getHContent function. Here we will check if gate equal to combine. We changed the value of this gate to combine, so this is right. At this case we will remove this hook, so we will type h hat hook dot remove, and here this function, in this function we will not use the output. Okay, we will use h content and h style. So we will type return. This function will change the output from this convolution layer to make it this thing here. So we will type return 1 minus gamma times h style plus gamma times h content. Okay, that's it. Now we will check if we are at the first iteration or if we are at time step t capital. At this case we will use our diffusion model. We will type model input equal to image pipe.scheduler.scale model input, and here we will pass xt capital style and the current time step, and we will get a predicted epsilon given h hat, which is equal to image pipe.unit. Here we will pass the input, model input, and the current time step. Here we will find predicted x0, which is equal to xt style minus torch the square root of 1 minus alpha bar t times predicted epsilon given h hat divided by the square root of alpha bar t. And here, as we said previously, we will not use a clamp method because it will affect on style transfer during content injection. Here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times the predicted epsilon given ht. Here we will make xt new equal to xt minus delta t. Okay, this xt new firstly it is equal to none, but now in the next time step it is equal to xt minus delta t. Now let's say that we are not at time step t capital, so at this case model input will be equal to image pipe.scheduler.scale model input, and here we will pass xt new because now we have xt new and the current time step, and here we will get predicted epsilon given h hat, which is equal to image pipe.unit, and here we will pass model input and the current time step. Here we will compute predicted x0, which is equal to xt new. As you can see here, it is xt new, it is not xt capital style, minus the square root of 1 minus alpha bar t times the predicted epsilon given h hat divided by the square root of alpha bar t. We will not do clamp here also, and here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times predicted x0 plus the square root of alpha bar t minus delta t times the predicted epsilon given ht. Now let's say that the current time step is smaller than or equal to 400. So we will not do content injection. We will not do all these things here. Okay? We will just do regular denoising steps using DDIM sampling algorithm. How can we do that? Here we will prepare the input to our model. Model input will be equal to image pipe.scheduler.scale. Model input, here we will pass xt new and the current time step. Here we will get predicted epsilon, which is equal to image pipe.unit. Here we will pass the input and the current time step. Now we will compute predicted x0. Okay, we will type xt new minus the square root of alpha bar t times predicted epsilon divided by the square root of alpha bar t. Predicted x0, it will be equal to predicted x0.clamp, and here we use the clamp method because now we are not do content injection, so we can use this clamp method. Here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times predicted epsilon. And here we will make xt new, it is equal to xt minus delta t. We will do this thing again and again until reaching x0. Okay? Now, as we said previously, we have this content image and this style image. Let's see the result. This is the result that we will get after doing style transfer. It is something, it will have the content, which is this church here, and the style of this style image. Okay? And I used the same diff style block and the same procedure, style transfer procedure, and I tried many different style images and I got this results. As you can see here, this is the second result, and this one here also. These are good results, okay? And you can try to use another diffusion model like celebrity AHQ model to see the results. Let's use this model, celebrity BAHQ 256 model. Firstly, we should install diffusers package, datasets package, transformers package, FTFY package, pyro package. Okay. Now we will, let's say, take another style image. Let's use this style image, okay? And we will use this model. This model will generate face images. Okay, we will combine content image that we will generate from this model with this style image. Okay, firstly, we will take this style image 7. Now we will download this model. Now we will get xt capital for this style image using our get xt capital using DDIM function. We will pass xt image pipe device to our get xt capital DDIM to get xt capital for this style image. Here we should import torch. Okay. Now we have xt capital for this style image. We will make xt capital style equal to this xt capital because this noise, it is the noise for this style image. Now let's see this noise. Okay, this is the noise for this style image. Now let's try to remove the noise inside this style image by doing reverse diffusion using our diffusion model. And let's see if it will return the same image or not. As you can see here, here is our style image again. Now what we will do, we will run this, we will create our content image. Okay, let's run this cell. Now we have this image, and as you can see here, this face, it is the content of this image. Now let's do a style transfer. Here, as we said previously, if we are working with out-of-domain images as style images, you should try many different values for gamma to find which one the best. Let's start with gamma 0.3 and edit steps equal to 400. Let's run this, and here's the result as you can see here, and you can try many different values. Let's try another style image and see the results. We will use this style image. Okay, so we will take the path of this image and we will put it here in this place. We will run this cell and we will get XT capital for this style image like this. Now we have XT capital for this style image. Let's do reverse diffusion to make sure that we will get the same style image again from this XT capital. Yes, we have this style image. We got this style image from XT capital. Now we will use this style image to do a style transfer with this content image. Okay, let's do it. Let's run this cell. Let's start with 0.5 gamma and see the results. As you can see here, here's the result. It will combine between the person itself, this person here, and the style image, which is this one here. Okay, we can change gamma, we can increase it like this. Thanks for watching.
Now perform search operation in the one-dimensional array, and this search operation is done with the help of array name dot index of 40. So if you observe this particular array, what are the corresponding indices here? This is located at index 0, index 1, index 2, index 3, index 4. Now we are trying to access the index of element called 40. So this 40 is currently available at index number 3. In the output, this will display 3 because 3 is the corresponding index for 40. Okay. Now consider performing insertion operation in this 1D arrays. So again the array is same, which is an integer array containing elements 10, 20, 30, 40, 50 is created. So this is going to create an array like this, 10 here and 20 here. This is 30, then 40, and here it is 50. Okay. And name of the array is array 1. Their corresponding indices are like this: index 0, index 1, index 2, index 3, and index 4. Okay. Now we are trying to insert an element at index number 1, and the name of the element is 60. Okay. So which element you are trying to insert is 60 at index number 1. So currently at index number 1, 20 is available. Okay. So after insertion, what happens? After insertion, inside this array, as we are trying to insert one more element, the elements will be like this. 10 will be here and 60 gets inserted at this point, and then the remaining elements will be as it is, like 20, 30, 40 and 50. Okay. And you can observe these are the different indices as well. So this is representing index number 0, index number 1, this is index 2, index 3, index 4 and index 5. Okay. Now when you try to display array 1 content after performing this insertion operation, so the corresponding output will be like this. You can see first element will be 10, second element will be 60, third element displayed is 20, then 30, then 40 and finally 50 gets displayed. Okay, like this. Now let's consider deletion operation in the one dimensional array. So again in this 1D array, you can see these elements all are integer data type. So let us generate this particular array after creation. Okay, it will look like this. The very first element is 10, second element is 20, 30, third element, and 40 is the fourth element, and fifth element is 50, right? So if you look at their corresponding indices here, this is represented at index number 0 and the name of the array is termed as array 1. Okay. And this is at index 1, index 2, index 3 and index 4. Okay. So now we are trying to remove an element from the array. So the element is 40. So which means we are clearly removing this particular element from the 1D array. So after performing deletion operation, so what is the resultant 1D array? That element gets removed and there is no change in the remaining elements. So first element will be 10 itself, second element is 20, third element is 30 and now 40 is removed. So 40 won't be there and the next element is 50. So you can observe this is index 0, index 1, index 2 and index 3. So previously there are totally 5 elements. Now after deleting an element there are currently only 4 elements. Okay. So when you try to display the content of this array 1, so it will look like this and it will display the output as first 10 will be displayed, then 20 will be displayed and later 30 will be displayed and finally 50 will be displayed. Okay, just like this. Next one is update operation on the one dimensional array. So as you know, we are creating an integer array here and currently the elements of this integer array are totally 5 elements are there. So this is 10, this is 20, 30, 40 and 50, isn't it? So their corresponding indices are 0, 1, 2, 3 and 4. Okay. Now array 1 of 2 is equal to 80. So this is representing array 1. Okay. So we are trying to update or modify the content inside this array 1 by placing 80 at index number 2. So currently at index number 2, 30 is the element, but you are trying to modify the same element to 80. So this will be replaced with 80 here. Okay. And finally, when you display each and every element inside the array 1, the content of array 1 will be like this. First, the element 10 gets displayed and the next element is 20 and later it is 80, then 40 and finally 50. Okay. So this is how you can update the entire array content. Okay. we can also create two-dimensional arrays in Python. So let's see how you can create here. Simply write t is equal to, okay, so inside this list you can start giving all the row wise elements. Okay, so let's see how this can be done here. Okay, so first t equal to, so this is going to create a total of 4 rows. Okay, and the first row contains elements 11, 12, 5, 2, and the second row containing elements 15, 6, 10, and in the third row the elements will be 10, 8, 12, 5. Similarly, in the fourth row the elements will be 12, 15, 8, 6. Okay, so from this, if you are trying to print t of 0, okay, so if you look at their corresponding indices, this is going to be the 0th row, this is the first row, second row, and the third row. And the moment you are asking t of 0, it will display this particular row, okay, as part of the output. Clear? So which means this statement is going to display you 11, 12, 5, 2. Okay. Now consider printing t of 1, 2. So you have to access 1, that is row 1 here, and access the element 2. So within this particular row, you can observe the indices will be 0 here, this is going to be 1, and this is 2. So you are trying to access this particular element from the row 1. Okay. So which means this statement is going to produce the output as 10. Okay, like this. Now let's see how you can perform insertion operation into this two-dimensional array. So again, in this two-dimensional array you can see there are totally 4 rows. Consider the same. This is row number 0. So the elements are 11, 12, 5, 2. Similarly, this is row number 1. Elements are 15, 6, 10. So this is row number 2. Elements are 10, 8, 12, 5. And finally, row number 3. Elements are 12, 15, 8, and 6. Okay. Now, we are trying to perform an insertion operation into this two-dimensional array. And this insertion is done at index number 2. That is second row. This is going to be inserted as the second row. So which means the elements inside this row 2 are 0, 5, 11, 13, 6. Okay. So which means this insertion happens to be in this position, isn't it? So I'll show you here. After insertion, this will become row 2 and the elements are going to be 0, 5, 11, 13, 6. And this will modify the subsequent row numbers. Okay. So you can observe this is going to be row 3 and this is row 4. Okay. So this is how the entire 2D array or matrix gets updated. Okay. And now you are trying to display this content by using a loop variable r in entirety. So this is going to access the row numbers here. Now inner for loop has got C in R. It represents within one particular row there are several column elements. Okay, so you are trying to iterate through these column elements with the help of inner loop variable C, and finally you are displaying C. Okay, so this is a way to access all the column elements in each row by row. It will get displayed. Okay. And after displaying each row, it will move to the next line. That is why the print statement is written outside the inner for loop, okay, but inside the outer for loop. Okay. like this. Now consider performing deletion operation onto the two-dimensional array. So again, in this two-dimensional array, you can observe there are totally, okay, 4 rows, 0, 1, 2, 3. Okay. So what are the elements of the very first row? First row containing elements as 11, 12, 5, 2, and the second row containing elements 15, 6, 10, and the third row containing elements 10, 8, 12, 5, and fourth row containing elements 12, 15, 8, 6. Okay. Now we are trying to delete T of 3. So in this particular table, okay, T or two-dimensional array named as T. So we are trying to delete T of 3. When you perform deletion operation on T of 3, so this will remove this particular row. Okay, isn't it? Now you are trying to iterate over the rows, and also within each row you are iterating through column elements to display the content. So once this is removed, okay, you can access row by row, one after the other. Okay, like this. Now let's see update operation here. So again, represent this same table, okay, or 2D array here. So at index 0, this is index number 1, index number 2, and this is index number 3. Okay. And the elements in each row are like this: 11, 12, 5, 2. Okay. And similarly, in row 1, the elements are 15, 6, 10. Okay. And in the next row, the elements are 10, 8, 12, 5. And in the last row, the elements are 12, 15, 8, 6. Okay. So if this is a scenario, then T of 2 is equal to 11 comma 9. Okay. So we are trying to modify this T containing this second row, that is row number 2. So the entire thing must be updated, okay, to 11 comma 9. So when I modify this as 11 comma 9, so it will give you the new elements here. It will store 11 and 9 here in this position. Okay. And the next one is T of 0, 3 is equal to 7. Okay. In this 0th row, you are trying to modify the column element called index 3. Okay. So 0th row, third column element is currently 2. Now we are trying to modify it to 7. Okay. So this will get modified to 7, and after this we are trying to display the entire table row wise. We are accessing, and within each row we are accessing different column elements located inside each row. Okay, got it? Like this. In this video, I'll show you how to declare a sample list of elements and access those elements in different ways. So first understand how to write a sample list. Let us suppose I'm taking capital L as the list, and also we are considering different elements inside the list. Let us suppose 35, okay, and then 43, 56, and you can also consider smaller values like 4, 1, and then 7, 99, like this. Different values inside the list which are not actually in a sorted order, okay, in a random order I have written. So let us display element by element inside the list. So how can I display element by element? So one way to display is I'll consider all these are items of the list. Okay. So for item in list L, Okay, you need to print this item. Print item. Okay, so let's run this code and see the result. You can see all these items are clearly printed one by one, isn't it? And after writing item, let us suppose if I'm taking some space like this, n is equal to space, then you will see all the elements are printed one by one with separation of space. Okay. And another way of displaying the same content, list content, is through accessing the index. Okay. So first you need to identify the length of this particular list, then only you can access item by item inside the list with the help of the index. Okay. So for this I am considering n is equal to ln of l. Ln is the built-in function which will give you the length of the list. Okay. Now for I in range of, we are going to access the entire list. Okay, range of n. Now we can start displaying these elements. Okay, one by one with the help of L of I, because I is going to run from 0 to n minus 1, isn't it? So you can see all the elements are displayed one by one. Again, if I want to separate them with the help of spaces, then I can write like this. And if you want tab space, you can write /t and display all the elements which are separated by tab space. Okay. So these are the two different ways where you can access the elements of the list. Okay. Now let us write a program where you are going to search one particular element inside the list. Okay. So which is nothing but linear search related code we are going to implement here. So let us consider these are the elements of the list. Okay. And at runtime you are going to take what is the element to be searched inside the list. Okay. So I'll consider this as key element to be searched. So int of input of, I'm going to read that particular element. Enter number to be searched. Okay. So once you search this element, okay. So how you are going to search this particular element, key element inside the list? First of all, very simple. You have to search element by element. Let us suppose the key element is 7. Then you start from here. 7 equal to 23 or not. Condition false. So you move to the next element. Like this. Finally you will meet 7 here. Yes or no? So let us iterate through the entire list and check whether this key element is available inside the list or not. So using for loop, okay, I'm going to access item by item in the list L. If suppose this item is equal to the key item, okay, so then you can say the element is found. Print element is found. And also you can write break statement because there is no need to search further as the element is already found. If suppose this condition is false, okay, in that case it will go for the next element, okay, and it will check whether that element is equal to the key element or not, like this. Okay. So what if after searching the entire list, if the element is not found? In that case, you have to basically explicitly write a statement here. Okay. So what I'll do here is clearly, instead of writing element is found, so here I'll write found is equal to true. Okay, which is a boolean variable. and initially I'll consider found is equal to false. Okay, I'll initialize with found equal to false. Now outside we can check like this, whether found is currently true or false. If the found is modified to true, then it represents actually the item is available inside the list. Whatever item that you are searching, okay, is matching with the key element, right? Okay. So you can see here found double equal to true. In that case, you can print clearly element is found. Okay. Suppose if this condition is false, then you can write the else block in order to print element is not found. Okay, so let's run this code and see the result. Enter number to be searched. Let us suppose I am trying to search for an element called 4. Now it will display element is found because 4 is available inside the list of elements that we have taken. So let's run one more time and search this time an element which is not existing inside the list. Okay, so consider element 8. 8 is not available inside the list, so it has to display element is not found, isn't it? So this is how you can search whether one particular element is available inside the list or not. Okay, so now let us implement code to basically add all elements of the list. So how can you add all the elements of the list? So first access element by element and add all these elements. Okay, so initially I'm considering a variable like total equal to 0. Okay, now I'll access element by element inside the list for item in L. Okay, access the item, add it to total. So this is total equal to total plus L, that is item. Okay, and finally you will get the entire total, right? You can now display this total. Okay, total is, so that is actually available inside variable total. Okay, so let's run this code and see the result. Total is 268. You can see we are adding item by item from the list to the variable called total. Okay, and there is another way to basically perform the same action. Okay, so using a built-in method called sum. So directly I can write like this, sum of L. So this will bring you sum of all elements in the list L, corresponding result, and gets displayed. So you can see again the output is same, isn't it? Like this. Now we'll perform some operations on lists. So let us start with plus operator. Okay, so the operator is plus operator on list. So I'll consider sample list called L1 is equal to some list of elements like 1, 2, 3. Okay, and similarly we can consider another list like L2 is equal to 4, 5, 6. These are the two different lists. We can perform plus operation between these two lists, L1, L2. Okay, so this will act as concatenation. It will concatenate all the elements of list 2 with list 1 and get the result, so that you can store inside another list like L3 is equal to L1 plus L2. So now we can display list called L3 and you can see the result. Result is basically concatenated list called 3, which contains list 1 content as well as list 2 content. Okay, and there will be no change inside list L1 and list L2. They will be same. Okay, so if you want I can display here writing L3 is equal to, okay, clear? And similarly, we will display other lists also, like L1, okay, this is one list, and this is L2, another list, okay. So let's run this code and see the result. You can see there is no change in the list L1, list L2, but list L3 is obtained by performing this concatenation between list 1 and list 2 with the help of plus operator. Okay. Now let us see how we can perform multiplication operation on a list of elements. So let us consider the next one is a star operator. Okay. So in this case, I'll consider L1 multiplied with one particular value. Let us suppose I'll form a new list from the existing list called L1 by considering L1 star 10. Okay. So this must create a new list called L3. Now we can display that new list L3. So let's run this code and see the result. Okay. So how many times you are going to repeat this list of elements that is defined here. When you write star 10, these elements will be repeated 10 times. That is the meaning. It is not simply multiplying each element here. This is clearly repetition. The concept of repetition over the list of elements can be done with the help of a star operator here. Suppose if I modify this to only 4, then these elements will be repeated only for 4 times. If I modify this to 2, then these elements inside list 1 will be repeated twice. Okay, just like this. In this video, we'll discuss about list indexing and slicing. So I'll consider a sample list and I'll show you first how this indexing works in Python. So generally in Python, whenever you want to access the elements of a list, you go for concept of indexing. And remember, all these indices are going to start from 0. Okay. So the very first element gets stored inside index 0. So let me quickly give you an example here. I'm considering numbers as a list, and this list contains several elements like 1, 2, 3, 4, 5. Okay. Now we are considering first is equal to numbers of 0. Numbers of 0. And later we can print first. So what this actually denote is, so when I store these elements as part of list, so the entire list will be stored like this, and these are the different indices. You can observe this is index number 0, index number 1, index number 2, index number 3, and index number 4. Okay. And the elements that are stored inside this are 1, 2, 3, 4, 5. Okay. Now this is numbers of 0. So in this numbers list, 0th index contains element called 1. So overall this first contains 1. Okay. Now we are printing this first. So this will give you output as 1. Okay. Suppose what happens when you are considering the same list. Okay. So let me consider again numbers is equal to the list of elements like 1, 2, 3, 4, 5. Okay. Now let us consider last element. Okay. So where this last element is accessed. Also remember, there is negative indexing available inside lists. Okay, whenever you want to access the elements from the ending position, you can go for -1 because the last element can be denoted with the help of index -1. Okay, so see here, the same numbers, okay, which are stored inside the list. So these elements are like this: 1, 2, 3, 4, 5. And if you look at these indices 0, 1, 2, 3, 4. Okay. And this is numbers list. Okay. And if you try for negative indexing, you can see this last element is stored in -1 index. And this is stored in -2 index. This is at -3 index. And this is at -4 index. And this is at -5 index. Okay. So when I want to basically print the last element in this particular list, so I can write print of numbers of, okay, very last element you can access with the help of -1 index, or you can also write like this, print numbers of, again last element index is directly 4, you can access using 4 also. Okay, otherwise you can apply a formula here, that is k is equal to ln of list. What is the name of the list? Numbers is the name of the list. So we are identifying the length of this particular list. Okay, and you can start printing length of the list -1, that is print of numbers of k minus 1, k minus 1. So k is representing the length of the list 5 minus 1, which is representing 4. So the very last index this will access. Clear? Like this. And now let us quickly work on list corresponding slicing operation. Okay. So consider a list. Again, I'm considering the same list, that is numbers is equal to the list of numbers like 1, 2, 3, 4, 5. Now you can actually slice the entire list. Okay, so you can obtain some part of the list from this one. So let us consider sublist is representing the part of the list which I wanted to create now. So consider numbers list, and I'll go for 1 colon 3. So this actually represents all the elements that are part of this list starting from index 1 up to less than this one. Okay, so we can consider this as a start and this as end, and it will access up to less than end. Clear? So which means you can observe here the entire list of elements 1, 2, 3, 4, 5. Okay, and if you look at these indices 0, 1, 2, 3, 4, these are the indices. Okay, so starting from which index? You can see it will start from index 1 up to less than 3. So less than 3 means this particular chunk, isn't it? So this will give you this part of the entire list. Okay, so finally when you start printing this sublist, you will be able to see the result output as just a list containing 2, 3 as elements. Okay, so this is how you can slice the existing list. Suppose I want to access the elements in an alternative way. Okay, that is alternate elements only I want to access. For example, if you consider this particular list, the same list, and if I want to print the output as just 1 3 5, 1 is located at index 0, 3 is located at index 2, and 5 is located at index 4, right? So now you can access them by just writing list B is equal to, from the same numbers list, you access the elements in an alternative fashion, right? You can see colon colon 2. Okay, so this will increment by 2. So it will start from very first element, then it will increment by 2, it will go to this index 2, and then it will further increment by 2, it will go to this index. You will get elements as 1 3 5. Okay, so then you can just print in order to get the desired result. Okay, yes sir. In this lecture, we'll be working with functions on lists. So what are the different built-in methods that are available on lists? So I'll be using each of these built-in methods one by one. Okay. So by clearly explaining so what is the functionality of that method. So first we will start with append method. Okay. So what is this append method on lists? Basically, as the name indicates, we're just trying to append an element into the list. Okay, so this appends element to list, isn't it? Now let's take an example here. Okay, so I'll take list1 is equal to an empty list initially. Now let me perform this append operation, list1 dot append of. Okay, so I'm appending an element called 13. Okay, and then list1 dot append of 18, and another operation like list1 dot append of 25. Now if I display this particular list1, you will see the result like this: 13, 18 and 25. Okay, so these are the elements that are available inside the list1. Okay, so this is the functionality of append method on lists. Okay, so let's take another method. So the next method is clear method. So as the name indicates, whenever you want to remove all the elements from the list, that is whenever you want to make an empty list. Okay, so makes list empty. So consider there are some elements already existing inside the list and you want to make the list as empty. Okay, so for this purpose you can make use of clear method. So list1 is equal to, I'm considering different elements inside this list like 1 comma 2 comma 3 comma 4 comma 5. Okay, now when I print this list1, I'll get all these elements which are as part of the list. But now I'm going to apply this clear method on the list. So list1 dot clear method. Okay, so let's apply this, and after that we print again. So then you can observe the difference. You will get an empty list. Okay, so you can see here, this is the original list, and after performing list dot clear operation, all the elements inside this list are removed. Now we are able to see an empty list, isn't it? Okay, like this. So next we'll work with copy method on lists. Okay, so as the name indicates, this copy method is used to return a copy of the list. Okay, so, or I can say, if you have list 1 and you want to copy the entire content of list 1 into list 2, okay, you can make use of this copy method. So let's work on this. I'm considering a list 1 is equal to a list of elements like 1 comma 2 comma 3. Now let's perform this copy method on the list. Okay, that is list 1 dot copy, okay, into another list. Let us suppose that is list 2 is equal to list 1 dot copy. Now when I print content of list 2, you will see the result as 1 2 3. Okay, isn't it? So the same content of list 1 is copied into list 2, right? And the same thing is displayed. Now if you want to check the ID of list 1 and list 2, you can further print like this. Print ID of list 1, and also you can print ID of list 2. Okay, let's run this. And you can see here ID of list 1 is different from ID of list 2, but still they both are having same content. Okay, so this is what copy method does. Suppose if you are not using copy method, but still you can copy the content of list 1 into list 2 by writing list 2 is equal to list 1. Now when you run this program, you will see here the same ID for both list 1 and list 2. This represents, if you are not using copy method, then both list 1 and list 2 are referring to the same object, that is this content. Suppose if you are using list 1 dot copy method, okay, so this will consider two different copies where list 2 is considering elements 1 2 3, and again similarly list 1 is considering elements 1 2 3 in a list. Okay, but they both are at different locations. Okay, yes or no? You can see here both are different, 488 688 at the end, isn't it? So that is the difference and advantage of using this copy method. Okay, now let's move on to the next one, which is count method. So this is one of the important method that we frequently use, especially while we are working with operations like finding the frequency of a given element inside the list. Okay, for such type of operations, this count method is very helpful. Okay, so what does this count method is going to perform? It will start counting how many occurrences of the given element is inside the list. Okay, so let us suppose I am using a count of x. Okay, I'm taking a sample list. Okay, so list 1 dot count of x. So this will actually identify how many occurrences of element x in the list. Okay, so this will give you number of occurrences of element x in the list 1. Clear? So let us start working on this. Okay, I'll take a sample list like elements are 10 comma 15 comma 20 comma 25 comma, okay, again 5 comma 10 comma, okay, 15 comma 10. Okay, let us suppose this is my list. Okay, I want to count how many times element 10 is appearing inside the list. Okay, so if you consider x is equal to 10, so then this is going to give you how many times element x is available inside the list 1. Okay, so by applying this count function, right? So let's display this by applying list1 dot count of x. Okay, so let's run this and you will see the result. 3 is the result because 10 is appearing 3 times inside the list1, here, also here and here, right? So total 3 times 10 is appearing. Okay, for example, if I modify this x value to something like 15, then you will get result as 2. Why? Because 15 is appearing only 2 times inside this list. Okay, 15 is here and also here, isn't it? So next we'll move to the next function. Okay, so that is extend function that we can apply on the list. Okay, so whenever you want to add all the elements of another list to the existing list, you can apply this extend method. So I'll show you here how you can make use of this extend method. So list1 is equal to, you have already some elements inside the list1, that is 1 comma 2 comma 3 are available inside list1. Now I want to append all the elements of list2 just like elements in list1. Okay, so consider 4 comma 5 comma 6, these are the elements of list2. Okay, now you can extend the existing list called list1 by basically writing like this: list1 dot extend of, okay, make use of list2. Clear? So later you can print list1 content. Okay, so you can see list1 is extended by adding the elements of list2 inside it. Okay, and there won't be any change in the elements of list2. Okay, list2 content is not changed. So you can observe there is no change in list2 content, but list1 content got extended by appending all the elements like 4, 5, 6 into list1, isn't it? So this is how this extend function is going to work. And next, consider the next method, okay, which is index method. So whenever you want to return the position of the very first occurrence of an element, in that case you can apply this index method. So general syntax is list name dot index of x. So this will actually find the position of x, very first occurrence of position of x, and it will return that position. Okay, so let us consider an example for this. List1 is equal to, okay, I'll take this list as combination of some strings and also numbers. Okay, so I'll take Ram and then number, consider 99. Okay, and Hanuman, and I'll consider the number as 99. Okay, so now you can see here both the numbers are basically same. Okay, but there are how many occurrences? 2 occurrences of 99 available. Now I want to find index of this element called 99. Okay, list1 dot, so the method is index method, right? Okay, so the index method, and I want to find the very first occurrence, okay, of the index. So I'll take this into a variable, and now you can print that variable here. Okay, so let's run this code and see. So the very first occurrence of 99 is available, okay, at index number 1, at index number 1, isn't it? Suppose if I modify, let us suppose I'm modifying this as 100. Okay, but still you can apply this list1 dot index of 99, where you will get index number as 3, because right now this is modified, right? Okay, so this is index number 0, this is index number 1, this is index number 2, and this is index number 3. Okay, and the same index value is printed here. Okay, and also you can basically iterate from one specific position to another position. Okay, so let us suppose I can write here 99. Okay, I can add another name like Sita. Okay, and 99 here. Now I want to iterate in specific positions, like starting from 1 comma 3. So then you will see the result as 1, because it is available in the index 1. We started from index 1. Okay, suppose if I write here as 2, you will get result as 99 is not in the list, because this represents the starting index for searching 99. Okay, and this is representing the ending index. As you know, this will always search up to end minus 1. It means it is going to search in the index 2, where 99 is not available inside this index 2. Therefore, it is returning 99 is not in the list. Suppose if I extend or modify this as 4, then you will get index as 3, because it is available in the index 3. Okay, so this is very helpful whenever you are searching for an element in the entire list. Okay, so let's move to the next function. Okay, so that is insert function. Okay, so as the name indicates, whenever you want to insert an element at a position, you can apply this. Okay, so like list1 dot insert function. Okay, so whenever I want to insert element called x in a specific position I, you can apply this list1 dot insert of I comma x. X can be inserted at position I, index I. Okay, so let's work on it. First, I'm considering list1 is equal to some elements like 1 comma 2 comma 3 comma 4. Okay, now I want to insert a new element called x. Okay, suppose x is equal to 55, for example. Now I want to insert this 55 at a specific index I value. Okay, so let us suppose that index variable, I'm using it as something like 2, for example. Now let's apply this list1 dot insert. Okay, you can see here this is the insert, right? So insert of index comma object. So what is the object that you are trying to insert here? X is the object, right? Okay, clear. And then you can print this updated list1. Print this updated list1. So let's run this and see the result. Okay, so initially list1 contains elements 1, 2, 3, 4. Now I have inserted a new element called x. Okay, what is the value of x? 55 at index 2. So you can expect here the output is 1, 2, 55, 3, 4. Because at index 0 element 1 is available, at index 1 element 2 is available, at index 2 we are inserting a new element called 55. Okay, 55 is clearly inserted at index number 2. Okay, and after that you can see element 3 and element 4 here. Okay, so this is how insert function works. Okay, clear. Next, consider another function called pop function. Okay, or pop method. So you have to apply this on a list like list1 dot pop. This will actually return the last element of the list. Okay, so just like pop operation. Okay, so and this is going to remove that element. So the idea is to basically removes and also returns the final element or last element. Okay, last element from the list. Clear? So let's take this list 1 is equal to, okay, some list of elements like 1 comma 2 comma 3 comma 4 comma 5. Okay, now let's perform this pop operation on the list. Okay, so list 1 dot pop operation. Okay, and then you can display the list. Okay, first I'm using here original list. Okay, original list is, I'm printing the original list over here before performing pop operation. So after performing the pop operation, I am going to display the updated list. Okay, updated list is, okay, you can print that list 1 content. So let's run this code and see the result. Okay, you can observe the original list is 1 2 3 4 5 and the updated list is, because we are performing list 1 dot pop operation, it will remove the last element from the list. Okay, and the updated list will look like this. Suppose if I further perform this pop operation, okay, let us consider copy and paste here the same code. So you will see another element getting removed from the list. Okay, so the last element right now from here to here is element 4, so that will be removed. Now let us perform another pop operation here. Okay, so you will see another element, that is last element is right now 3, that will be removed. Now let's do one more pop operation. Okay, and then you see here last element 2 is also removed, and you can see there is only one element. If you perform one more pop operation, okay, then you will see the result as an empty list. Now if you try to perform pop operation on the empty list, okay, so in that case it is going to throw you an error saying that pop from empty list. Basically you cannot pop, that means you cannot remove an element from the empty list, right? That's why. Okay, so usually we don't copy paste like this. This is basically for quick solving. Okay, I have just copied and pasted, but usually we write a loop in order to perform these operations. Okay, so clear? If I perform only one pop operation, this is the result. Clear? Yes, sir. Let's move to the next function or method on the list. All these methods are very helpful for solving problems using Python. Okay, all array related problems you can easily solve using lists. Okay, so next one is remove function. Okay, so if you observe this remove function, okay, this will actually remove and return the very first occurrence of the element. Okay, so whatever that you are specifying in the braces here, let us suppose I am performing like list 1 dot remove of x. Okay, so this is going to remove element x. Okay, what if element x is available in multiple positions? Then this is going to remove the very first occurrence of element x in the list 1. Okay, so let's do this. List 1 is equal to, I'm taking some elements like 1 comma 2 comma 99 comma 4 comma 99 comma 5 comma 99 like this. Okay, now I want to remove element x and x value is 99 clearly. Okay, let us remove this element x from the list 1. Okay, so list 1 dot remove of x. Okay, so after performing this removal operation, now we will print the list, and also before we will print the list saying that original list is, okay, I'm printing the original list over here, that is list 1 content, okay, and later I'm displaying the updated list, okay, the content updated list is list 1, okay. So let's run this and you can see here clearly, okay, this is my original list 1 2 99 4 99 5 99, okay, and later we have removed element x which is 99 from the list. So 99 is available here, very first occurrence of 99 is between 2 and 4 and that got removed. You can see this element is clearly removed, okay. Suppose if you further perform the same operation again and again, okay, so you will see the updated list getting modified, okay, another occurrence of 99 gets removed from the list, okay. If you do the same operation again, so you will observe another 99 also getting removed from the list. So right now the updated list doesn't have any 99, okay. So if you apply the same operation again, this is going to display you x is not in the list because 99 is not available inside the list, okay. So this is how your list content gets updated when you are performing this removal operation, okay. Fine. So next we'll consider another function, okay. So consider the reverse function, consider the reverse function on the list, okay. So whenever you want to reverse the order of the elements in the list, you will be using this reverse function, okay. So let us consider list 1 is equal to elements like 1 comma 2 comma 3 comma 4. Now we can actually perform reverse operation on this list. You can take another list like list 2 is equal to list 1 dot reverse, okay, and then we can print list 2, okay. So let's run this and see, okay. So here let us suppose we'll do, for example, print of, okay, list 1 dot reverse, okay. So let's do here, I'm taking list 1 dot reverse, okay, yes. So now the elements will get automatically reordered in the list 1 itself. Now you can display the list 1 content here, okay. So you can observe here, so considering the same list and perform this reverse operation, okay, so that all the elements gets reversed, okay, and then you can print. So I'll do one thing here, I'll display the original list here, original list is, so the content of the original list you can display here, and now updated list is, okay, which is list 1, okay. So let's run this code and see the result. So original list is 1 2 3 4, updated list is 4 3 2 1, which is the reverse of the original list, isn't it, okay. Now consider the next method. So here we'll perform sort operation, okay. So like list 1 dot sort, okay. So in this list1 dot sort, this is going to sort the elements in the entire list in the ascending order. Okay. So I'll take, for example, list1 is equal to some elements like 20, okay, 5, 67, okay, 46, 32, okay, and 73, like this. Some random elements I've taken. Now, if I print original list, okay, so just like this, original list is, if I print original list corresponding content like this, and later we can perform this sorting of the list, like list1 dot sort, okay, and then you can print the updated list, okay, updated list is, okay. So let's print this updated list here, okay, and run this code. You can see this is the original list. 25, 67, 46, 32 and 73 are the elements in the original list. Now the updated list is basically a sorted list, because we are performing this after performing sorting operation, we are displaying the updated list. So the elements are 5, 20, 32, 46, 67 and 73. Okay. So let us suppose I want to perform the sorting in the descending order. Okay. Then you can write here reverse, okay, is equal to true. Clear? So let's run this code now, and you can see this will perform sorting in the reverse order, that is a descending order. So the descending order of the elements are 73, 67, 46, 32, 25. Okay, just like this. Clear? So these are different methods that we often use in the entire list. Okay, so this is very important. Okay, so just go through these functions so that you can easily apply while solving problems, that is programming problems or coding questions related to lists or arrays. Okay.
Hi, in this lecture we will learn how to do style transfer with Python. Firstly, we will import CV2 and we will import transforms package from Torch Vision, and we will download the out of domain image that we will use as a style image. So firstly we will type x0 equal to image.open, and here we should pass the path of our style image, our out of domain image. But actually here we should import this image class. How can we do that? From pil import image class, like this. Okay, now we have our out of domain image, our style image, which is our clear image. We will resize our image and we will make the height of this image equal to 256 and the width of this image equal to 256. Here we will specify the device that we will use in forward diffusion and reverse diffusion, which is our GPU. Now we will convert this x0 to numpy array like this. Here we should import numpy as np, and here we will type np.array and we will pass x0. So now we converted this x0 into numpy array. After that we will use transforms.toTensor to convert this numpy array into PyTorch tensor. After that we will add a new axis, and the length of this new axis is equal to 1, which is the batch dimension. Now we will send this image, this clear image, this style image to our device. So we will type x0.toDevice. Now we will make xt equal to x0. Now we are at time step 0. This is our clear image. So we will make xt at time step 0 equal to x0, which is our style image. Now we will import DDIM pipeline from diffusers. Here we will specify the ID of the model that we want to use. Here we will use this model DDPM Church 256. This model will generate church images, and you can use other model here like this model DDPM EMA Celebrity AHQ 256. Okay, but now we will use this model DDPM Church model. We will specify the device that we want to use. Here we will type image pipe equal to DDIM pipeline.from pre-trained. Here we will pass the model ID, the ID of the model that we want to use, the ID of the diffusion model that we want to use, and here we will send this pipeline to our device. Now we have our image pipeline. This pipeline will make it easy to use our diffusion model to generate images. Here we will generate one image. We will call it image 1, which is equal to image pipe, and here we will specify the number of entrance steps, and we will make it equal to 50. Okay, here we are using DDIM pipeline. In other words, we are using DDIM scheduler, so we can use very small number of time steps to generate the images. Dot images, and here we will open these brackets and put 0 between them. Now we have our image 1. So now we generated one image using our church DDPM diffusion model. We talked previously about this function, get x capital using DDIM function. This function will do forward diffusion, and as we said previously, we will use this function to generate xt capital for the out of domain images or in domain images. Okay, now we said previously that we downloaded our style image, and now our style image, it is available in this variable xt variable. Now what we will do, we will call this get x capital using DDIM function. We will pass xt, our style image, the pipeline that we want to use, our image pipeline, and the device that we want to use, which is CODA, our GPU. Now we will get this xt capital. It is the noise that related with our style image. Here we will make xt capital style equal to xt capital. Our style image, it is this one here, okay, which is available here in this place. This is our style image, and xt capital for this style image, it is this noise here. This is xt capital for this x0, this style image. Now, as we said previously in the previous lecture, we can do reverse diffusion using DDIM sampling algorithm to generate our style image again from this xt capital. And now we have our style image. Okay, this is our style image. Now we know that we have xt capital for our style image, for our out of domain style image. Now we will import these packages: CV2, transforms, torch, numpy, and tqdm package. Now we will create our content image, which is in domain image. We will use our diffusion model, our DDPM church model, to generate this image. How can we do that? Firstly, we will take the time steps from image pipe.scheduler.timesteps. Now we have this PyTorch tensor. The first element in this tensor represents the first time step in reverse diffusion, and the last element in this tensor represents the last time step in reverse diffusion, which is time step 0. Now we will create a noise. We will take this noise from the Gaussian distribution, the standard Gaussian distribution. Here we will make xt capital content equal to this noise, because this noise we will use it to generate our content image. So it is xt capital for this content image. Now we have xt capital content, which is equal to this noise, and we will make xt content equal to noise, because as you know, t small here will be equal to t capital when we are at the first time step in reverse diffusion, which is time step t capital. So now xt small content equal to noise, which is this one here, or in other words, xt content equal to xt capital content. Now we will pass it through these time steps. Okay, we will get the number of the current iteration for this loop and the current time step. What we will do, we will take alpha bar t from image pipe.scheduler.alpha as cumulative, and here we will pass the current time step. Now we will check if the current time step it is not equal to 0, it is greater than 0. In this case, we will find alpha bar t minus delta t from image pipe.scheduler.alpha as cumulative. And here we should get the next time step, or time step t minus delta t in reverse diffusion. How can we find this t minus delta t time step? We will use this time steps tensor image pipe.scheduler.timesteps, and here we will pass the index of time step t minus delta t, which is I plus 1. Now we have our alpha bar t minus delta t. But if t is equal to 0, we are at time step 0. At this case, we will make alpha bar t minus delta t equal to image pipe.scheduler.final alpha cumulative product, which is equal to 1. Now what we will do, we will use our model. Firstly, we don't want to update the weights of our model, so we will put this context manager with torch.noGradient. So we will not compute the gradients for anything inside this context manager. We will prepare the input to our model. So a model input equal to image pipe.scheduler.scale model input. Here we will pass xt content and the current time step. Okay, here we will compute the predicted epsilon. So predicted epsilon at time step t, it is equal to image pipe.unit. Here we will use our diffusion model. Here we will pass our model input, the current time step, and we will get the predicted epsilon. Now we will compute predicted x0, which is equal to xt content minus the square root of 1 minus alpha bar t times the predicted epsilon divided by the square root of alpha bar t. Here we will use a clamp method to make the lowest possible value inside this predicted x0 tensor equal to -1, and the highest possible value in predicted x0 equal to 1. This image pipe.scheduler.configuration.clip sample range, it is equal to 1. Okay. Here we will compute xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times predicted epsilon. Here we will make xt minus delta t equal to xt content, because now t is equal to t minus delta t. The current time step it is t minus delta t. And we will do this thing again and again until reaching time step 0. Now we created our content image. This is our content image. We used pil.image.fromArray method to display this image. When we reach time step 0, so now xt content it is x0 content. We will take this image from xt content tensor. As you know, it is a batch of samples. We will take just the first sample. As you know, this batch has just one sample. We will take this sample. We will rearrange the dimensions of this sample. We will put the height dimension firstly, after that the width dimension, and finally the channel dimension. Now we will type pil.image.fromArray. Here we will firstly take this x0, we will send it to our CPU because we can't display this image without sending this tensor into our CPU. After that, we will make the lowest possible value in our tensor equal to -1 and the highest possible value in our tensor equal to 1. We will multiply this tensor by 0.5 and we will add 0.5 to the resulted tensor. Finally, we will multiply this tensor with 255 to make the lowest possible value in our tensor equal to 0 and the highest possible value in our tensor equal to 255. We will convert the elements of this tensor to integers. We will convert this tensor into numpy array, and we will convert the type of this array into unsigned integer 8. And now we have our content image, which is this image here. Now let's do style transfer. We will take the style of this style image and we will put it in this content image. How can we do that? Firstly, we will get time steps tensor from image pipe.scheduler.timesteps. Here we will make xt style equal to xt capital style, and we will make xt content equal to xt capital content. As you know, here we will do reverse diffusion. The first time step in this reverse diffusion is t capital, so t small here at the first time step it is equal to t capital, so xt style it is equal to xt capital style that we created previously, and xt content is equal to xt capital content. This xt capital style is the noise that related with this style image. This xt capital content it is the noise that related with this content image. Now we'll create this variable xt new and we will make it equal to none. Firstly, we have this gamma variable. We will make it equal to 0.7. We said previously that the best value for gamma variable equal to 0.6, but when you are working with the out of domain images as a style images, it is better to try many different values for this gamma variable to get the best image. Here we will make editing steps equal to 400, which means that we will stop the content injection if the current time step it is smaller than or equal to 400. Now we will create this loop. We will pass it through our time steps. We will start with t capital and we will end with 0 time step. Firstly, we will take the value of alpha bar t, which is equal to image pipe.scheduler.alpha as cumulative product, and here we will pass the current time step. and we will make this condition. If the current time step is not equal to 0, at this case, alpha bar t minus delta t will be equal to image pipe.scheduler.alpha, cumulative product, and here we will pass t minus delta t time step, which is image pipe.scheduler.time steps, and here we will pass I plus 1. But if the current time step is equal to 0, at this case we will make alpha bar t minus delta t equal to 1. Okay, now we will make this condition. We will do content injection if the current time step is greater than edit steps greater than 400. Now what we will do in this content injection, firstly we will find h content. We will create this variable, gate variable, which is equal to content, and here we will prepare the input to our diffusion model. So model input will be equal to image pipe.scheduler.scale model input, and here we will pass xt content and the current time step. Here we will create this hook. This hook we will use it to get the content feature maps from the bottleneck of our diffusion model. So let's create this hook, h content hook. It will be equal to image pipe.unit, and here we will type down blocks, and we will take the final down block, which is down block 5, and inside this down block we have ResNet blocks. We will take ResNet block with index 1, and here we will specify the layer inside this ResNet block that we want to take the feature maps from, which is convolution layer 2. And here we will use register forward hook method to create our hook. We will pass a function. This function it will work on these feature maps that we will get from this conv2 layer. Let's go and see this get h content function. This is get h content function. Firstly, we will make h content equal to none, h style equal to none, gate variable equal to none. Here we will create get h content function. PyTorch package will give us three things: the module, the input to the module, and the output from the module. In the other words, the input to this convolution 2D layer and the output from this convolution 2D layer. Here we will take the output from this layer. Firstly, we will make this h content variable global variable, which means when you change this variable in this function, this variable will change in any other place, even outside this function. And when you change this variable in any other place outside this function, so this variable will change inside this function as well. And the same thing for this gate variable. We will make this gate variable global variable. So when we change the value of this variable outside this function, so the value of this variable inside this function will change also. We made the value of gate variable equal to content. Okay, so let's see that. Here we made gate variable equal to content, and as we said previously, gate variable, it is a global variable, so its value in this function will change also. And now the value of this gate variable, it is not none but content. So now this condition, it is true, so we will make H content equal to the output. The output feature maps from this layer, from this bottleneck of our U network. And after that, we should remove the hook. How can we remove the hook? We just need to type the name of the hook that we created, which is this one here, H content hook. Okay, we should type the name of this hook, H content hook dot remove. By doing this, we will remove this hook. We need to remove this hook to be able to create another hook. Okay, now let's go back to our loop. PyTorch will call this function automatically when we reach the bottleneck of our diffusion model. Now we created our hook that we will use to get the content feature maps from our unit. Now we will use our diffusion model. We will type this context manager. Inside this context manager, we will use our U network. Predicted epsilon, it will be equal to image pipe.unet. Here we will pass the model input and the current timestamp. So now we used our U network. We will move it through our U network, and when we reach the bottleneck of our U network, when we reach this layer, the convolution layer inside this ResNet block, inside ResNet block with index 1 and down block with index 5, when we reach this layer, PyTorch will call this getHContent function. And here we made gate equal to content, so we will make HContent equal to output. So we will make the output feature maps, the content feature maps in this HContent, and we will remove this hook because we don't need it anymore in this time step, in this current time step. Now what we will do, we will find the predicted x0, which is equal to xt contents minus the square root of 1 minus alpha bar t times the predicted epsilon divided by the square root of alpha bar t. And here you should know that we should not use a clamp method. We should not restrict the predicted x0 when we do content injection, to make sure that we will get good result. Here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times predicted epsilon. Now we will make xt minus delta t equal to xt content. So now we have H content. Now let's take H style. How can we do that? Here we will create another hook that we will use to get the style feature maps from our U network. How can we do that? We will type H style hook, which is equal to image pipe.unet.downblocks 5.resnets1.conv2. We will take HStyle tensor from the same layer that we used to take HContent tensor. Okay, we should do that. And here we will use register forward hook method to create our hook, and we will pass the function that we will use to get the output and the input and the module. Let's go and see this getHstyle function. This is getHstyle function. We will get the module. PyTorch will give us the module itself, the input to the module and the output from the module. Here we will make HStyle variable global variable, and we will make gate variable global variable. Why? Because we want to use this HStyle tensor in another function. So when we change the value of this HStyle in this function, so we will change this variable in any other place, even outside this function and inside another function. Now when we make get variable equal to style, so we will make each style equal to the output from this layer, and here we will remove this hook. We will activate this function when we reach this layer. Okay, now we have our hook. And here we will check if we are at the first iteration of this loop. In other words, if we are at time step T capital, the first time step. So at this case, we will prepare the input to our model input equal to image pipe.scheduler.scale model input, and here we will use xt capital style, and we will pass the current time step. Okay, if we are at time step T capital, and here we will use our model, and when we reach this layer, so PyTorch will use this hook to get the output from this layer, and we will change each style variable based on the outputs from conv2 layer. Let's say that we aren't at time step T capital. At this case, model input will be equal to image pipe.scheduler.scale model input, and here we will use xt_new. Okay, and we will pass the current time step. And here we will use our uNetwork to extract the style feature maps, hstyle. We can call this tensor now hnew. Here we will combine the style and the contents, or in other words, we will do noise injection. Firstly, we will make gate equal to none. Okay, here we will use our model. If the current time step is time step T capital, or we are at the first iteration for this for loop, at this case, model input will be equal to image pipes.scheduler.scale model input, and here we will pass xt capital style and the current time step. Otherwise, model input will be equal to image pipe.scheduler.scale model input, and here we will pass xt_new and the current time step. And here we will use our model, our uNetwork, to find the predicted epsilon given ht. We will use this thing here when we want to compute d capital, which is equal to image pipe.unit, and here we will pass our model input and the current time step. Okay, now we have the predicted epsilon given ht. Now we will make gate equal to combine, and here we will create another hook, which is h hat hook, which is equal to image pipe.unit.down blocks, and here we will pass the index of this down block and the index of the reasonable block and the layer that we want to take the values from it. .register forward hook, and here we will pass the function combine style and content function that will take the module, the input, and the output. Now let's see this combine style and content function. This is combine style and content function. It will take module, input, and output. And here we have many variables. We have gamma variable, which is global variable, hstyle variable, which is a global variable, hcontent variable, which is a global variable, and gate variable, which is a global variable. Here when we change a gamma variable from outside this function, so the value of this variable will change inside this function. Hstyle also will change based on what we got previously from this getHstyle function, and hcontent variable will change also based on what we got from getHcontent function. Here we will check if gate equal to combine. We changed the value of this gate to combine, so this is right. At this case, we will remove this hook, so we will type h hat hook dot remove, and here this function, in this function we will not use the output. Okay, we will use h content and h style. So we will type return. This function will change the output from this convolution layer to make it this thing here. So we will type return 1 minus gamma times h style plus gamma times h content. Okay, that's it. Now we will check if we are at the first iteration or if we are at time-step T capital. At this case, we will use our diffusion model. We will type model input equal to image pipe.scheduler.scale model input, and here we will pass xt capital style and the current time step. And we will get a predicted epsilon given h hat, which is equal to image pipe.unit. Here we will pass the input, model input, and the current time step. Here we will find predicted x0, which is equal to xt style minus torch the square root of 1 minus alpha bar t times predicted epsilon given h hat divided by the square root of alpha bar t. And here, as we said previously, we will not use a clamp method because it will affect on state transfer during content injection. Here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times the predicted epsilon given ht. Here we will make xt new equal to xt minus delta t. Okay? This xt new, firstly it is equal to none, but now in the next time step it is equal to xt minus delta t. Now let's say that we are not at time step t capital, so at this case model input will be equal to image pipe.scheduler.scale model input, and here we will pass xt new because now we have xt new and the current time step. And here we will get predicted epsilon given h hat, which is equal to image pipe.unit, and here we will pass model input and the current time step. Here we will compute predicted x0, which is equal to xt new. As you can see here, it is xt new, it is not xt capital style, minus the square root of 1 minus alpha bar t times the predicted epsilon given h hat divided by the square root of alpha bar t. We will not do clamp here also, and here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times predicted x0 plus the square root of alpha bar t minus delta t times the predicted epsilon given ht. Now let's say that the current time step is smaller than or equal to 400. So we will not do content injection. We will not do all these things here. Okay? We will just do regular denoising steps using DDIM sampling algorithm. How can we do that? Here we will prepare the input to our model. Model input will be equal to image pipe.scheduler.scale model input. Here we will pass xt new and the current time step. Here we will get predicted epsilon, which is equal to image pipe.unit. Here we will pass the input and the current time step. Now we will compute predicted x0. Okay, we will type xt new minus the square root of alpha bar t times predicted epsilon divided by the square root of alpha bar t. Predicted x0, it will be equal to predicted x0 dot clamp, and here we use the clamp method because now we are not do content injection, so we can use this clamp method. Here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times predicted epsilon. And here we will make xt nu it is equal to xt minus delta t. We will do this thing again and again until reaching x0. Okay? Now, as we said previously, we have this content image and this style image. Let's see the result. This is the result that we will get after doing style transfer. It is something, it will have the content, which is this church here, and the style of this style image. Okay? And I used the same div style block and the same procedure, style transfer procedure, and I tried many different style images and I got these results. As you can see here, this is the second result, and this one here also. These are good results, okay? And you can try to use another diffusion model like celebrity AHQ model to see the results. Let's use this model, celebrity BAHQ 256 model. Firstly, we should install diffusers package, datasets package, transformers package, FTFY package, pyro package. Okay. Now we will, let's say, take another style image. Let's use this style image, okay? And we will use this model. This model will generate face images. Okay, we will combine content image that we will generate from this model with this style image. Okay, firstly, we will take this style image 7. Now we will download this model. Now we will get xt capital for this style image using our get xt capital using DDIM function. We will pass xt image pipe device to our get xt capital DDIM to get xt capital for this style image. Here we should import torch. Okay. Now we have xt capital for this style image. We will make xt capital style equal to this xt capital because this noise is the noise for this style image. Now let's see this noise. Okay, this is the noise for this style image. Now let's try to remove the noise inside this style image by doing reverse diffusion using our diffusion model. And let's see if it will return the same image or not. As you can see here, here is our style image again. Now what we will do, we will run this, we will create our content image. Okay, let's run this cell. Now we have this image, and as you can see here, this face, it is the content of this image. Now let's do a style transfer. Here, as we said previously, if we are working with out of domain images as style images, you should try many different values for gamma to find which one the best. Let's start with gamma 0.3 and edit steps equal to 400. Let's run this, and here's the result as you can see here, and you can try many different values. Let's try another style image. and see the results. We will use this style image, okay? So we will take the path of this image and we will put it here in this place. We will run this cell and we will get XT capital for this style image like this. Now we have XT capital for this style image. Let's do reverse diffusion to make sure that we will get the same style image again from this XT capital. Yes, we have this style image. We got this style image from XT capital. Now we will use this style image to do style transfer with this content image. Okay, let's do it. Let's run this cell. Let's start with 0.5 gamma and see the results. As you can see here, here's the result. It will combine between the person itself, this person here, and the style image, which is this one here. Okay, we can change gamma, we can increase it like this. Thanks for watching.
Next one is list comprehension in Python. So in Python, we can actually create a list by using some conditions. Okay. So let's see here how we can create generally a list with the help of list comprehension. Using this sentence, you can see create a list of X for each Y and Z. So this is the general format that we write while creating the list. Now look at this example. Create a list of squares. Okay. And you can observe this is the formula used to create squares, and this is the loop variable that will run in the range of 10. Okay, so what happens exactly here, you can see the range is going to be from 0 1 2 up to 9. Okay, so initially it will consider x is equal to 0. 0 square represents how much? So the squares will be, you can see for 0 that will give you 0 square, which is 0 again, and then x is 1. 1 square represents 1, and then x becomes 2. 2 square represents 4. Similarly 3 square becomes 9. 4 square represents 16. 5 square represents 25. 6 square represents 36. 7 square represents 49. 8 square represents 64. 9 square represents 81. Okay, so this is the entire squares list. Now we are printing this squares list. Clear? Now consider this example of using if class in order to filter the items. So whenever you want to create a list of squares for only even numbers or only for odd numbers, then you can start writing some conditions. In this case, we are writing a condition to get only for even numbers, x mod 2 double equal to 0. Okay, so look at this. In this example, first it will generate x square in the list where x is in the range of 0 to less than 10. So the range is basically 0, 1, 2 up to 9, isn't it? And it will check whether the number is divisible by 2 or not. So it will generate only for even numbers. Okay. So what are the even numbers here? 0. Okay. 0 mod 2 double equal to 0 condition will become true. And then for 2, similarly for 4, 6 and 8. So only these numbers are considered as part of X, and it will start generating the even squares. So look at this even squares corresponding list. Okay. So 0 square represents 0, 2 square represents 4, 4 square represents 16, 6 square represents 36, 8 square represents 64. Okay. So these are the even squares, and then we are printing even squares. Okay. Now let us find the maximum element and minimum element inside this particular list. Okay. So for this I will consider different variables, like A is a variable which will find the maximum element. Suppose if you want, I can write max L is a variable which will obtain the maximum element inside the list L. So this can be done with the help of a built-in function called max that can be performed on the list L. Okay. Similarly, to identify the minimum element inside the list, you can write min L is equal to min of L. Okay. So minimum element inside the list. So finally, you can display those values, right? Let us suppose here I will print maximum value in list L is. Okay. So here you have to display that particular element called max underscore L. Okay. So similarly, you can display minimum value. So this can be written as minimum value inside the list L as min underscore L. So let's run this code and see the result. You can observe maximum value in the list L is 99, whereas minimum value inside list L is 1. Okay. So like this, you can identify maximum and minimum values with the help of built-in functions. Suppose if I want to perform the same action without using these built-in functions like max and min, you can also perform this in Python, but this time you have to traverse the entire list and identify the maximum element. Okay. So let's do this. I will remove this code. Okay. And here also. So what you can do here is max is equal to initially, and also min L is equal to, I'll consider the very first element inside this list. Okay. So this can be accessed with the help of index, right? L of 0 will be representing this particular element called 23. Now I'll iterate through the entire list and identify if any element is greater than this 23, I'll take it into max L. If any element is less than 23, I'll take it into min L. Okay. So let's iterate using for loop for item in list L. Okay. If this item is greater than max underscore L, in that case, I'm going to update this max L value as the item. Okay. Now we are writing another condition here. If suppose this item is less than the min L, then it represents there is one more item which is smaller than this. So you have to capture that inside this min L variable is equal to item. Okay. So this is how you can capture the maximum values into max L and minimum values into min L. So which gets updated frequently based on the values, right? Okay. So finally, you can display here using print statement saying that maximum value in list L is, so you can display this element which is max underscore L. Okay. So in the same way, you can display minimum value inside the list as min L. Okay. So let's run this code and see the result. You can see maximum value inside the list L is 99 and the minimum value inside the list L is 1. So this is how you can display here without using any max function or min function, isn't it? In this video, we will discuss about concept of tuples in Python. Generally, these tuples are ordered collection of data items. They usually store multiple items inside a single variable. So let me give you an example for a tuple. So like tuple 1 is equal to, okay, and you have to use round brackets, and within this round brackets all the items of the tuple are enclosed and they are separated by commas. So let us suppose 1 comma 2 comma 3 comma 4 comma 5, and always remember these tuples are unchangeable. Okay, it means we can't change them once you create them. So let's see here, I'm trying to print tuple 1 content. Okay, so let's run and see the result. Clear? Now let us suppose you can also write another tuple with all strings, for example. Okay, I'll take multiple strings here: USA, Mexico, Canada, India. Now I want to print this content of tuple 2. Okay, so let's run this code now and see the result. So you can observe here, this is tuple 1 content and this is tuple 2 content, which is clearly displayed. Okay, and we can also take a combination of numbers and strings inside the tuple. So I'll take another example completely. Let us suppose I want to hold address. Okay, so name of the person is John. Okay, 18, and then so this is Mexico, and you can print this particular address. Okay, just like this. So if you want to give some more details like okay, Yellow Street, you can add directly into this tuple. Okay, just like this. Okay.
Hi, in this lecture we will talk about optical flow, which is one of the most important techniques that we should know before moving to learn how to convert our video into animation. Firstly, what is optical flow? Optical flow shows the movements of the pixels between two frames. For example, let's say that we have these two frames. This is the first one and the second one. The optical flow for these two frames is this one. This optical flow will tell us which pixel in the first frame moved in the next frame, and the direction of movement and the amount of movement. So as you can see here, all the pixels that represent this card, they moved in a specific direction in the next frame. So each one of them has its own vector that represents the direction of movement and the amount of movement. We will call all these vectors that represent the movement of each pixel by optical flow. In 2015, they started using deep learning to solve optical flow tasks. They tried to train a U network to find the optical flow from two images or two frames. The structure of the U network that they used, it is this one here. We will pass the first frame of our video through this branch here. There are many convolutional layers in this branch. We will pass this image through them, through all these layers, all these convolution layers. And we will do the same thing for the next frame of our video. We will pass it through this branch, all these convolution layers. And here we will do special thing. We will find the correlation between these feature maps. So how can we do that? To understand the idea behind this correlation layer, we should understand this formula here. Firstly, here we want to find the correlation between two patches. One of these patches is available in F1 feature map, and the other patch is available in F2 feature map. The center of the first patch, it is x1, which in this case it is this location here. The index of this location is 1, 1, and the center of the other batch is x2, which is this location here. The index of this location, it is 2, 3. Because as you know, in Python we start with index 0. So the row of this center, it is equal to 2, and the column of this center, it is equal to 3. Now what we will do actually, we will do dot product. This symbol here for dot product. Okay. This formula here will multiply this patch with this patch, element wise, and after that it will add the results to get just one single value, which is something similar to the convolution operation that we talked about previously. Here, this patch in F1 feature map, it is like a kernel that we will multiply with this patch in F2 feature map. So this operation is something similar to convolution operation. Now after applying this formula, we will get just one single value. This value will represent the relationship between this batch and this batch. So now we are doing matching process, which is something very important in optical flow. When the correlation between these two patches is very high, it means these patches, they are very similar to each other. And by doing this, we will be able to know that x1 batch, it is just moved and created x2 batch in feature map 2. Our neural network will try to learn these correlations. And by using these correlations, we will be able to match between batches. Here we took just one single example about how to compute the correlation. But actually, we will find the correlation of this batch with all possible batches in this feature map 2. And we will go to another batch here, and we will find the correlation between this batch and all possible batches in F2. And when we want to find the correlation between, for example, the first batch in F1 feature map and all batches in F2 feature map, we will get new feature map. And when we want to find the correlation between the second batch in F1 feature map and all batches in F2 feature map, we will get another feature map in the output. Okay, so we will get very large number of feature maps. So now the depth dimension of the output will be large. which is equal to the possible patches inside of one feature map or possible patches inside F2 feature map. As you can see here, these two feature maps, F1 and F2, they have the same size. So now we have very large number of feature maps in the output. Our output is very large, and that's not good. We did a lot of computations to get this output. This thing will take time, and if our output is very large, so it will take a lot of our memory also. All these things, they are not good. So what we will do here, we will reduce the spatial dimensions of the output. How can we do that? The idea is super easy. Here we will not compare this patch with all possible patches in F2, but with the nearest batches in F2. So here what we will do, we will restrict the search space. For example, here we have our batch, which is x1 in this case, this one here. Here we will not find the correlation between x1 and all x2 patches, but we will find the correlation between x1 with the nearest x2 patches to our x1 batch. In other words, here is our x1 batch, and here is the center of this batch. Let's say that the displacement, the maximum displacement, equal to 1. By doing this, we will restrict the search space. Now we will find the correlation between this x1 with this batch here that has the same center of x1 batch, okay, and this batch here, which moved just one step from the center of x1. So now we have two batches, and this batch here also we have 3 batches, and this batch here, so we have 4 batches. So in other words, we will just find the correlation between this batch with the patches that are near to the center of our x1 patch, but in F2 feature map. So here we didn't take all patches in F2 feature map, but just a few of them. So here we reduced the computations, because here we will not use this formula a lot. And we will take another patch in F1 feature map, and we will find the nearest patches in F2 feature map for this patch in F1 feature map, and we will do computations to find the correlation, and we will do this process again and again until reaching the last patch in F1 feature map. By doing this, we will reduce the size of the output from our correlation layer, and we will speed up our network because we will reduce the computations. But the problem here, you will not be able to match any patch in F1 feature map with very far patch in F2 feature map. So for example, if you have very fast object in your video, if you use this correlation layer, you will not be able to match the batches that are related with this object in the first frame and the next frame. So you will not be able to get the correct optical flow for this object. And we will pass the output from this correlation layer through many layers, and we will pass the output through this refinement part of our network. This refinement part will increase the spatial dimensions of our optical flow by using up convolution layers. And here's the output optical flow feature map, you can see the resolution of this optical flow. It is not similar to the resolution of the input frames. And they found that adding another convolution layers will not be helpful. It will increase the spatial dimensions of the optical flow, but it will be something similar to any other simple resizing methods. So for this reason, they used the variational refinement to make the resolution of the optical flow similar to the resolution of the input frames. In the next lecture, we will talk about GM flow method to find optical flow. Thanks for watching.
Next one is tuple indexing. So in case of tuple indexing, first you have to identify how the elements inside the tuple are stored in different indices. So let us consider this concept of finding the indexes of the tuple. Okay. So let me consider a sample example for considering this tuple corresponding indices. Okay. So I'll take name of the tuple as country. Okay. And I'll denote different countries here like USA, Mexico, Canada, India. Okay. And then UK. So these are the different countries I have indicated as part of the tuple. Okay. Now if you understand here how these elements or items inside the tuple are stored. So this first item will be stored in index 0 and the second item will be stored at index 1. Third item is stored at index number 2. Fourth item is stored at index number 3. And the fifth item is stored at index number 4. Okay. Like this, all items inside this tuple are stored at different indices starting from 0. Okay. So now if I want to print one particular index, okay, so let us suppose I want to display the name of the country that is stored inside index number 1. Okay, so country of 1. And also I want to display index number 3. Okay, corresponding content. So in such case, what will be the output? You can see for this example, if I start writing the output, country of 1, what is the country that is located at index number 1? Mexico is the name of the country which is located at index 1. And what is the country located at index number 3? You can see India is the country that is located at index number 3. Okay. So this is how the positive indexing will work. Now let us consider concept of negative indexing. Okay. So this time I'll take another example like cars. So I want to store different cars company names here like BMW, Tesla, Toyota, Mercedes, like this. Now, as you know, according to positive indexing, the elements are stored like this. This is at 0th index, first index, second index, and third index. Now we apply negative indexing here. So if you look at negative indexing, the last element will be stored at -1 index. The previous element will be stored at -2 index. Okay, and this element is stored at -3 index, and this element will be stored at -4 index. Okay, so when I want to display like this, print of cars of -1. Okay, so this will display output as the last element inside this tuple. Okay, so the corresponding output will be Mercedes. Okay, suppose if you want to display one more item like print of cars of -3. Okay, so in this case this will display the item that is stored at index -3, and this is Tesla here. So this will display Tesla. Okay, and this is how this negative indexing is going to work. Now let us consider how to check one particular item is available inside the tuple or not. Okay, so in this example this is mainly checking an item. Okay, check for an item whether that particular item is available inside the tuple or not. Okay, so let us consider country. Okay, I'm considering various countries like USA, UK, Canada, Germany, India. Okay, now this is the tuple I have considered. In this case, I want to check whether one particular country is available inside this tuple or not. Okay, I want to just check whether an item is existing inside the tuple or not. So for this, we can write if condition like this. If, so let us suppose name of the country that I am checking here is Germany. So Germany is the name of the country we are checking whether it is available inside this tuple or not. So in is the membership operator which is used to perform this task. Okay, and we are searching inside the tuple called country. And finally, you can display if this condition is true, you can print Germany is present. Okay. Suppose if this condition is evaluated to false, then it will go to the else block and you have to print Germany is not present inside this tuple like this. So what will be the output in this case? Tell me. You can observe first you are checking Germany in country corresponding tuple. So that is already available inside a country tuple exactly at an index called 3. Yes or no? So this is index 0, index 1, index 2, index 3 and index 4. Since it is available inside this, the corresponding statement will be evaluated. So this will return true basically, and it will print Germany is present as the output. Okay. Next, whenever you want to basically print a range of items that are belonging to a tuple, okay, then you can start with starting index and also ending index, and you also specify jump index if it is needed. Okay, so in this case we are mainly discussing on a range of index. Okay, so the general syntax in order to find or display the elements which are located in one particular range of index is tuple. You have to consider the tuple. So inside this tuple, you start with the starting index and then move up to less than ending index, and then also specify this jump index. Okay, and remember this jump index is optional. By default, if you are not specifying this jump index, it will consider 1. Okay, so let me take an example to consider this concept. Okay, so I'm taking t1. T1 is my tuple, is equal to, and the elements of the tuple are pen, okay, pencil, eraser, slate, marker, like this. There are some items I have considered. Now we want to obtain some part of this tuple. Okay, so let us suppose I want to print like this. Print of t1 of, I'm giving the range as 1 colon 4. Okay, so what will be the corresponding output? First identify the corresponding indices. This is stored at index 0, this is stored at index 1, this is stored at index 2, index 3, and this is at index 4. So when I write like this, it will generate a list of indices starting from 1 and up to less than end. So the indices will be 1, 2, 3. It means the output displayed is the items which are located at index 1, index 2 and index 3. So those items are clearly pencil, eraser, slate. Okay, these are the items which are stored at these indices. Okay, now what happens when you also include the jump index? Okay, so let's see an example for this. I'm considering this time different elements. Okay, inside this tuple called values, so all numbers, consider 10, 20, okay, 30, then 40, 50, 60, 70, 80, 90. So these are the elements that are available. Okay, now what happens when you write like this, values of, okay, when you want to print this particular content, let us suppose I am writing entire thing inside the print statement. So values of, okay, so this time since it is tuple, we have to access like this, values of, okay, 4 colon, okay, 8 colon 2. Okay, so I'll take starting from, let us suppose 2 here, 2 colon 8 colon 2. So what does this actually indicate? So 2 is representing the starting position, okay, 8 is representing the ending position, and this 2 will be denoting jump index. Okay, isn't it? Now if you look at the underlying representation of the existing tuple, okay, so let's see along with the indices how this tuple is stored here. Okay, so 10, 20, 30, 40, 50, 60, 70, 80 and 90. These are the items inside the tuple, right? So if you look at their corresponding indices, this is at index number 0, this is at index number 1, index number 2, index number 3, this is at index number 4, index number 5, this is index 6, index 7, and this is index number 8. Okay. So when I write starting index is 2, so which means we are trying to extract from this point 2, index number 2, up to end. So but the problem is jump index is not 1, it is 2. Okay, it means it has to access starting from index 2 and jump by 2. Okay, so it will come here, and also the next jump will be here, and the next jump will be here, but again the end is less than 8. Okay, it should be less than 8. So only the items which are located at index 2 gets displayed, and also item located at index 4 and item located at index 6. So overall this has to produce the output of 30, 50, and then 70. Okay, so this is how you can display. Clear? Now consider another example where we skip writing either the starting index or ending index. Okay, so in that case how this is going to extract or slice the entire tuple. Okay, so let me basically consider a small example here. Okay, so I'm considering an example of animals. Okay, so different animals I'm considering, like cat, dog, bat, mouse, pig, horse, donkey, goat, cow, like this. These are the different items inside the tuple. Now let us suppose I want to print like this. Print of from this animals tuple, I'm trying to print starting from index 4 colon. Okay, I'm skipping writing the ending index as well as jump index. So when I skip jump index, by default it will consider 1, and then when I skip the ending index it will consider till the end. So it will start from, clearly it is going to start from index number 4. So if I start writing the indices for this, you can see this is located at index 0, index number 1, index number 2, index number 3, and index number 4. Here is index number 4. So this should actually display the output as starting from index 4. So the corresponding item will be pig, and then next index. So till the end all the items will be displayed. Okay, horse, and the next item is donkey, and the next item is goat, and the next item is cow. Okay, so this will be the result in this case. Now in this video we'll discuss about how to manipulate tuples. So the problem with the tuples is they are immutable, which means you can't add or remove or change any item in the tuple. So the best way to perform modifications on the tuple is to convert this tuple into a list. Okay. So let us suppose I'm considering an example here. So country is the name of the tuple. So here I am considering different country names like Spain, Italy, India, England, and Germany. Just like this, I have considered different country names. Okay. Now we can convert this particular tuple into a list. So consider temp is equal to, okay. So to convert any tuple into list, simply you can write list of name of the tuple you can mention here. Immediately this will be converted into a list and it will be stored inside temp. Okay. Now if you want, I can display this temp content. Okay. So let's run this and see the result. You can observe initially this is a tuple. Okay. Now I have converted this tuple into a list and stored inside temp. I'm printing this temp. Okay. Now let us suppose if you want to add an item into this particular list, so you can make use of append function. Okay. So temp dot append of. So I'm appending a country name called Russia. Okay. And after appending, you can also display the content of this list temp. So before appending, this is the content of the list. Now after appending, you can observe Russia is appended into the list. Okay. Now let us pop one particular item from this list. So I'm using temp dot pop of. I'm specifying index as 3. So 0, 1, 2, 3. So index 3 is denoted England here. Okay. So let's run and see the result. You can see England is removed from this list. Okay. This is the final list. Okay. Now, when I want to modify the existing country name, okay. So you can do this by writing a temp of, okay. 1 is equal to, I'm modifying Italy to Finland. Okay. And again, you can display the updated list. So you can observe this is the previous item located at index number 1 inside the list. Now Italy is modified to Finland. So once you modify or perform any changes on the list, you can convert this list back into the tuple by just writing a tuple function. So you can write country is equal to this updated tuple. You can print tuple of. So the name of the list is temp, and finally I'm printing this updated tuple which is country. Okay. So let's run this code and see the result. All the updations are performed and this is the final list, and later I'm converting this list into a tuple and you can see the content of the tuple. Okay. So this is how you can perform any changes that you want by converting the existing tuple into a list, and convert after performing all the enhancements on the existing list. You can convert this list back into the tuple. Okay, just like this. Now in this video we'll discuss about how to unpack the tuples. So the unpacking is nothing but the process of assigning all the tuple items to variables. Okay. So you can observe this is the tuple called info. It contains a total of 3 items inside the tuple. Now I want to assign these items one by one to different variables. So this is nothing but concept of unpacking the tuples. So once you do this, then what happens? This info is nothing but this one, right? Okay. So John will be copied into name, and then 21 will be copied into age, and then Stanford will be copied into university. And later we are displaying its corresponding content. So let's run this code and see the result. So clearly the unpacking is done, right? So the tuple contains total of three items are placed into the variables. Yes or no? Like this. Now we'll discuss about dictionaries in Python. So always remember, dictionary is nothing but representation of data in the form of key value pair notation. Okay. So if you look at dictionary, it is clearly unordered and also mutable, and then it doesn't allow any duplicates. So we can't store any duplicate data inside a dictionary, and all the data will be stored in the form of a key value pair notation. Okay. So for example, if I start writing an example for a dictionary, so how you can represent is, let us suppose dictionary 1 is equal to, you have to specify the syntax as key value pair notation. For example, this is key 1 and what is its corresponding value. Okay. Similarly, I'll write key 2 and its corresponding value 2. So like this, you can specify key value pair notation when you are writing any dictionary. Okay. So let me consider a simple example here. I'll write a sample dictionary. Courses is equal to. So the first one is course, and here the corresponding value for the key is, let us suppose, Python. Okay. And here I'll write version, and the corresponding version is 3, and now duration is 45 days. Okay. And in fact you can write this 45 days as a string. Okay. It represents clearly this is a dictionary, and the dictionary has got various key value pair notations. First key value pair is course and Python. Okay. And the second key value pair is version 3, and third key value pair is duration 45 days. Okay. So let us suppose I want to print this particular dictionary. I can write print of courses. Okay. So when I execute this code, you will see the corresponding result here. The entire data which is represented in the form of a dictionary here, you can observe. So all the key value pairs, totally there are three keys and value pair notations available here. So for example, if I'm going to make this as an empty dictionary, then also you can run this code and see an empty dictionary available in the output. Okay. Now let us see quickly how many ways we can actually create a dictionary in Python. So first I'll consider courses is equal to, let us suppose I'll write different courses including Java, Python, Pandas, like this. Okay. So first one is Java, and second key value pair is Python. Okay. And corresponding, for example, 3, I'll write Pandas. Okay. Now let us print here the corresponding courses dictionary, and you will see the result immediately. The entire dictionary containing three key value pairs are getting displayed. Okay. Now this is one way of creating a dictionary with integer key values, and you can also create a dictionary by writing explicitly dict function. Okay. So you can start writing a dict function here, and you can create a dictionary just like this. So let's run this code and see the result. Okay, and you can also create a dictionary in which each item has a pair. Okay, so I'll take here, instead of dictionary corresponding brackets, so I'm going to write like this. I'll recreate entire dictionary in the form of list of elements inside it, and each the entire list containing a pair. Okay, all the elements or items are in the form of a pair. So very first element I'll give it as 1 comma Java, and the second element is 2 comma Python, and the third element is 3 comma pandas. Okay, now let's run this code and see the result. Here also we are getting a form of dictionary. Completely data is stored in the form of a dictionary. Okay, so this is another way of performing or displaying the dictionary by storing like this. Okay, now you just need to understand here, whenever you want to access the elements, you can access with the help of a key or with the help of a value. Okay, so let us suppose in this example I'm considering printing one particular course. Okay, so you can see here, this time if I just simply write courses of 0. Okay, so let's see what will be displayed. Simply courses of 0, and it is going to produce a key error. Why? Because you can see the entire dictionary content. Okay, so we have stored in a different fashion here. So let's suppose I'll store like this. Okay, so completely I'll store in the form of a key value pair notation. Okay, so just like how we have done earlier. So consider this one, course, and the name of the course is Python. Okay, and the second one is fee, and the corresponding fees, for example 50,000, and then duration is 45 days. Okay, suppose if I'm trying to store like this, and if you are trying to access like this, again you will get a key error. Okay, because the way we access dictionary is different from how we access generally lists or tuples. So in this case, how you can access is with the help of key value pair. You have to specify clearly for which key you want corresponding value. So this is the first key, right? I'll use the same key and I denote here. Now when I run this code, I'll get result as Python. Okay, similarly if you want another key value, okay, another key is fee, you'll get result as corresponding value. Okay, and similarly if I give you another key representation, okay, third key, the duration, it will print 45. So completely you can access with the help of key value pair notation. Okay, and there is another way of accessing the content also without writing these brackets. You can write or use get function, get of key. This is a format, right? So where you will specify the key here, like get of course, it will immediately display Python, because key corresponding value is Python. So here the key is course and value is Python, so it is going to get key corresponding value. So similarly if you apply here fee, okay, you'll get result as 50,000. And similarly, if you write duration for this, you will get 45 days. Even if you write a small spelling mistake, immediately, okay, it will not show any result because duration is there, but there is a spelling mistake in this. So this particular key is not available inside the dictionary. Okay, that's why you are not getting result here. But when you write duration, you will get result as 45 days. Okay, because this particular key is exactly matching here and its corresponding value gets extracted and getting displayed. And let us see how you can actually update and add new elements to the dictionary, existing dictionary. Okay, so for example, I would like to add a new key value pair. Okay, so for example, I'll take courses of, okay, so this time I'll consider another key value which is student. Okay, so student is Tanish. Okay, now I'll display courses dictionary. Then you should be able to see this entire dictionary containing student also getting added to the existing dictionary. So previously the dictionary has got only three key value pairs. So those keys are course, fee and duration. Now additionally I have added another key called student and it contains a value Tanish. Okay. So finally I'm displaying this particular courses, which is nothing but entire dictionary gets displayed. So let us suppose the duration is 45 days right now. I want to modify the duration of 45 days to 60 days. So in such case, how can I access this content, dictionary content? Where exactly I have to perform the updation operation? I have to perform the updation operation exactly here. Key value pair notation. So I have to access the corresponding key here, which is you can see duration is the corresponding key, right? You access that duration key. Since dictionary is mutable, you can easily update it. So instead of writing 45 days, this time I'm modifying to 60 days. So finally, if you display here entire courses, okay, dictionary, then you will get the result. You can observe the result here. So course is Python, fee is 50,000, duration is 60 days, and student is Thanish. Okay. So this is how the entire dictionary can be updated, or you can start adding new elements to the dictionary. Okay. Now let us see, for example, I want to delete one particular element from this particular dictionary. Okay. So let us suppose I felt duration is not necessary in this dictionary. Now in that case, how can I remove the duration part? So after removing duration, okay. So after removing, I'll try to remove this duration from the dictionary. This can be done with the help of pop operation. Okay. So you just need to specify the corresponding key and it will get popped out. So let us do this. From the courses dictionary, I'm trying to perform pop operation, pop of key value. Okay. So that is, you have to specify the key exactly. Duration is the key that I'm trying to remove. So once if you are popping out the key, it means associated value, key value pair gets popped out from the dictionary. And finally you can display the updated one. Okay, there is updated courses corresponding dictionary. So let's execute this and see the result. So you can observe here this duration is key value pair. You should keep this inside single quotes because the entire data, you can see this is kept in with the single quotes, right? So exactly you have to represent that while popping also, and you can see the result. In the initial dictionary you got duration, student, okay, fee, course, all these details. But after removing duration, you can see this time duration is not available inside this dictionary. Yes or no? So similarly you can start popping other elements also. Okay, so I'll show you here one by one the pop operations. Okay, so let us see here. I'll remove this print statement. Okay, and also I'll remove this statement. After one pop operation, after one pop operation, I'm displaying the content here. Similarly, let us suppose I'll perform another pop operation. Okay, I'll copy this and paste here. But this time instead of duration, I'll pop fee. So let's run this. After one pop operation, okay, you got totally, you can see three key value pairs are there. And after performing one more pop operation, you can observe this, you got only two. Okay, now let us suppose I'll go for another pop operation here. Okay, so another pop operation, this time fee is not there, so it must be course. Okay, so let's run this, and you can see course is also popped out. It contains only student information. Now let us do one more pop operation, okay, and see the result. So this time you have to pop student, okay, and run this code. You can see finally it is an empty. Okay, so let's do, okay, similarly for any other dictionary you can do it. So this is how the basic pop operation is going to work. Okay, or the other way of removing is, for example, I'll show you another way of removing the item from this dictionary is with the help of pop item. Okay, so the pop item will always remove the last pair. Okay, that is the last key value pair will be removed. So for example, I'll show you here by printing courses dictionary. Okay, so this is the current result of the courses dictionary. Okay, isn't it? Now what is the last key value pair? It is a student Tanish. For example, if I perform a pop item, okay, so I can do like this: print courses dot pop item. Okay, and after performing pop operation, if I display the content again, okay, if I try to display this dictionary again, then you can see here this is clearly popped out item is what? The last item. So the last key value pair notation will be removed, and this is the remaining dictionary. Okay, suppose if you don't want to display that popped item, then you can remove this operation inside the print statement, so that you can easily see the remaining dictionary content after performing the pop operation. Okay, so now let's run this code and see the result. You can see the earlier dictionary has got total of 4 pairs, and now the latest dictionary after performing one pop item operation has got only 3 key value pairs. So if I keep on repeat this operation for multiple times, you will see the entire result. So initially it has got 4 pairs. Now later after one pop operation, this has got 3 pairs. and after another pop operation it has got two pairs, and later a single pair, and finally it becomes empty. So now at this point of time, if you perform another pop operation, then this is going to raise an error, because you can't perform pop item on the dictionary when the dictionary is already empty. Okay, when the dictionary is already empty, you can't perform pop operation. Okay, like this. Now we'll iterate and access the content of the dictionary with the help of for loop. So I'll show you how to access the content of the dictionary with the help of for loop here. So this is the entire dictionary which we have already created. Okay, and this dictionary has got total of three key value pairs. Okay, now let us access this particular dictionary content with the help of for loop. I can write just like any other access to data structure, like list can be accessed with the help of for loop. Okay, tuple can be accessed with the help of for loop. In the same way, you can access here for x in courses. Okay, now you start printing this particular x. Okay, so let's run this code and see the result. So the problem here is you will get only key data. You are not getting values. If you are using just like how you access tuples or lists in, okay, the same concept if you apply here in the dictionary, then how you are getting data? Only keys you are getting, okay, but not their corresponding values. So you can't go for this approach for dictionaries. Okay, for dictionaries you should be accessing in a different fashion, right? So I'll show you that. For example, I'll take two variables here. One is key, the other one is value, because we are storing key value pairs inside the dictionary. So you can access from this courses dictionary corresponding items. Okay, you have to make use of a method called items. Okay, so you can start printing them in the form of a key value pair. Here I'll write key comma value. Okay, so let's run this code and see the result. It will exactly print key value pairs. So course Python, fee 50,000, duration 45 days. So this is the exact key value pair that will be displayed when you try to access through key and value. Okay, so now let us use concept of key in order to get the value. Okay, so this is another approach where you can access the content, where I'm purely using key to iterate through this particular dictionary, which is courses dictionary, and here I will print key and its corresponding value by accessing the dictionary content. So dictionary is courses, and inside this dictionary exactly what key corresponding value is there, that will be fetched. So let us run this code, and you can see key value pair is clearly getting displayed, because courses of key, if suppose in the first iteration key is course, okay, now that is going to display course comma courses of course. So it will fetch the courses dictionary and checks the key corresponding value. The key is course and its corresponding value is Python. It will be displayed. Similarly, in the next iteration, key will become fee and its corresponding value 50,000 can be fetched by writing courses of fee. Okay, like this. And there are other methods also, like dictionary.keys and dictionary.values. Okay, so let us consider those methods instead of this. So first I'll consider key here for key in courses dot, you can apply this keys function here. So you are accessing the courses dictionary through keys. Okay, and if you start printing those keys directly, okay, so you can write like this key. I'll try to print key here, and then like this. So let's run this code and see the result. So in this iteration, okay, in the first iteration I'm getting the key, first key. In the second iteration I'm getting the second key. In the third iteration I'm getting the third key. So that's why the result is like this. Now similarly you have to write another for loop to fetch the values one by one from the courses dictionary. So you can actually write for value in this courses dot, so this time values, you are accessing values, right? So go for values function, okay, and start printing those values. So print value, so this particular value you can print. Now when you run this code you will see here, so this is like this, okay. So it can only concatenate string, not integer, okay. So which means yeah, here this is a integer, right? So that's why it is saying that can only concatenate string here. So you just write comma here instead of concatenation, it will work, okay, because here we are writing concatenation. If you write here also concatenation, the values are, one of the values are integer, you can't concatenate integer with a string, that's why it is showing. So here also in fact you can write comma, no, okay, so you will still get the result, yes or no. So this is how you can actually access the entire dictionary corresponding content in multiple ways, okay. Now we'll see how to find the length of the dictionary, okay. So just like in any other data structure, we are using len function to find out the length of the dictionary, right? So in the similar fashion, you can also find length of the dictionary with the help of len function here. So consider here n is equal to, I'm trying to find out the length of the dictionary here, len of courses is the name of the dictionary. So this will actually return the length of the courses dictionary and store it into a variable called n, okay. And now I'll display this length of the dictionary, length of dictionary is, okay. So I'll display n value here, length of the dictionary. So see here, length of dictionary is 3 because the dictionary contains a total of 3 key value pairs, yes or no. So that's why it is going to return length of the dictionary as 3, okay. So for example, if you want to basically display the entire dictionary as a string, okay, you can typecast it into str, okay, that is string. So let us do this converting or uses of str while working with dictionaries. So I'll show you here the entire courses dictionary. I wanted to convert into str and then display, okay. So I'll print here clearly saying the components of the dictionary, components of the dictionary are, So I'm going to just convert this dictionary into str. Okay, so let's run this code and see the result. You can observe earlier length of the dictionary is 3 and then the components of the dictionary are. Okay, so the entire dictionary is converted into string. Okay, and it is getting displayed. Okay, so this is how you can work with str. And next one is type. Okay, whenever you want to find out the type of the passed variable, you can go for type function. Okay, so here also just like the corresponding dictionary, this is the entire dictionary that we are considering. So if I write type in order to display the dictionary corresponding type, then see here. Okay, so if you try to display here type of passed object. Okay, type of dictionary is courses. Now let's run this code and see the result. You can see here it is clearly showing type of the passed object is class dictionary. Okay, class dictionary. So since this is clearly dictionary type object, so it is showing type of courses as class dictionary. Okay, like this. So next one is sets in Python. Okay, so first coming to what is a set. Okay, so set is nothing but a container, just like in mathematics how we write set representation. In the same way we can write and use this sets concept here, and this is represented in the form of you know braces. Okay, like this. Clear? Now, one more thing is in order to generate a set, we have to separate all the elements with the help of comma. Okay, like if you have multiple elements to write 1 comma 2 comma 3, you can write like this. And next coming to duplicates. Okay, duplicates are automatically removed from the sets. Okay, so if you try to give duplicate values, it will automatically remove. And sets are immutable. Okay, you cannot change those values. Okay, so let's see this example. My set is equal to 1 comma 2 comma 3. Okay, so this is my set and I'm trying to print this particular set. We'll get the result exactly like this. Okay, and these are the corresponding braces that are used to create a set, curly braces. And next, you can also have a list of elements, but then you can convert this list of elements into a set. Okay, so 1, 2, 3, 2 are the list of elements. Now I want to convert this into set. This is the meaning of converting the list into set. And after conversion, since set data structure, okay, will not allow any duplicate values, so this will remove duplicate values. You can see here in the list, original list 2 is appearing 2 times, so that will be removed and then we are printing this set. Okay, you can observe this set is 1 comma 2 comma 3. Okay, and next one is we are creating an empty set. Okay, how do we print an empty set? Okay, so you can print just like this. This will create an empty set. Okay, whenever you want to create an empty set, you can write like this. Okay, suppose I want to initialize an empty set, and then I can write like this: s1 is equal to an empty set, and if you want one more empty set, you can write s2 is equal to empty set, just like this. Next, we can perform standard mathematical operations on sets. Okay, so like set 1 containing elements 1, 2, 3, and set 2 containing elements 3, 4, 5. Okay, now you can check whether one element is appearing inside the set or not with the help of membership operator called in. So 1 in set 1. So 1 is actually appearing inside set 1. That's why it is going to return true. Okay. Suppose if you are asking like this, 7 in set 2. This must be returning false because inside set 2 there is no element called 7. Okay. Thank you. So in this video, we'll discuss about functions in Python. So let's see how we can write a function in Python. So we know function is nothing but block of statements which are used to perform a particular task, and whenever you want to use that task to be done, we can call the same function again and again. Okay. So this is a general syntax of the function def. Okay, so you can see def and name of the function. I'm trying to define a function. That name should be given here, and then parameters for the function should be given here. Okay, and then coming to this is representing the documentation string for that particular function. Let us suppose in that function, if you are finding the maximum among two given numbers, then you will be specifying in the documentation string that this function is going to perform maximum among two given numbers, and the respective code should be implemented here. Okay, so it takes parameters or arguments, and you can use those parameters or arguments inside the code. Okay, and you can also write functions without parameters. Okay, so let's see this example where we are computing square of the given number. Okay, so you can see print square of 3. We are calling a function called square by passing parameter as 3. So this 3 will be copied into x. Okay, and this function square will be returning a value called x double star 2, which means x double star 2 is nothing but x square. Okay, so what is x value passed here? X value is 3. So 3 square will be representing 9. So this is going to return value of 9 back to the calling function, and it will print that 9 value. So the result obtained will be 9. Okay, and next coming to another function which is multiply function, and it is taking two parameters x and y. So in the function call, we are specifying those two parameters as 3 and 2. So this value of 3 will be copied into x, and value of 2 will be copied into y. Now inside this function, it is going to return x into y. So x value is 3 and y value is 2. Now we are returning x into y, which is nothing but 3 into 2, value will be 6. So value of 6 will be returned back here. Okay, and that gets displayed. So the output will be 6 here. So consider another example. So whenever we want to return multiple values, they will be returned back to the calling function with the help of a tuple. Okay, so let us consider a function name called minmax function, which is giving list as parameter. Okay, list is supplied as parameter to this function. Now this list will be copied into data. So you can see data now becomes a list of elements. List of elements are 1, 3, 7, 2, 10. Okay, now we are going to return min of data and max of data. So what is min of data going to return here? Okay, so the minimum value on this list data will be 1, and max of data, the maximum value on this data will be 10. Okay, so this will return 1 comma 10 in the form of a tuple. 1 comma 10 will be returned. Okay, so that is the corresponding output which is going to be displayed. Okay, thank you. Hello guys, in this video we'll write programs related to functions. Okay, so let's get started. First, I will define a sample function in order to compute square of the given number. Okay, so let's define the function as find square function, and this is going to take parameter as x. Okay, so now what is it going to return? Okay, square of x, that is x into x. So you can compute inside a variable like x into x and return this variable y, or you can directly return x into x because an expression can be returned with the help of return statement. Okay, so this is find square function. Let us take sample input. Okay, so int of input of enter any value. Okay, and call this function find square function. Yes, exactly the same function, but this function is going to return the result, okay, by passing parameter as num to this function. Okay, so consider res is a variable. Okay, so now I'll display the result like this: square of given number is. Okay, so the result is actually stored in variable called res. Okay, so if you look at the function calling, program execution starts from here. So it is going to prompt you enter any value. Once you enter the value, that is taken as inside num variable. So now this num is passed as parameter to the function called find square function. So here x is holding the value of num, and then x into x is computed. The result is stored inside variable y, and now we are returning that result back to the calling function, and res will be holding that result. Later we are displaying a square of the given number is res. Okay, so let's run this code and see the result. So this must be prompting enter any value. Okay, let us suppose I have entered value as 7. Now the result obtained is a square of given number is 49. 7 into 7 is 49. Okay, now similarly you can also implement another function which is used to compute cube of the given number. Let us suppose find cube is the function, and it is taking parameter as x, and here I'll compute z is equal to x into x into x, you can write, and then you can return the result z. Okay, so similarly we can also make use of res variable here in order to find cube of the given number. Okay, so this time I will use this print statement similarly, but the difference is we are printing the cube of the given number. Cube of given number is res. Okay, like this. So now let's run this particular code and see the result. Enter any value. Okay, consider I'm entering 5. So square of the given number is 25 and the cube of the given number is 125, because 5 square will be 25 and 5 cube will be 125. Okay, and you can also implement here, okay, because find cube is x into x into x. Okay, you can also write the same expression as x into x square. So x square is the result that is obtained from the function called find square. Okay, so I'm going to make use of this function here. Okay, find square of x into x, or x into find square of x. Now let's run this code and see we getting correct result or not. So you can see again we got the correct result, that is square of the given number is 25 and cube of the given number is 125. Okay, so if you look at the program flow of execution, first we are calling a function called find square function by passing num as the parameter, and then this function will be executed. Later the result is returned back to the calling function here, and then we are displaying it. Okay, later we are calling find cube function by passing num as the parameter. So inside this find cube function, it is going to call find square function. Okay, so inside this find square function, it is going to return result and it will be stored inside z, and it is returning the z. Okay, so this is the entire program flow. So next one is how do we find the maximum among three given numbers? Okay, so three numbers are taken as input to the function, and we need to find maximum among those three numbers and return that value. So let us define the function called find largest function, and we'll pass parameters as a comma b comma c. Okay, now we'll consider the condition if a is greater than b and a is greater than c. We can consider big value, largest value is a. Okay, suppose this condition is false, then we can check for b. B is greater than a and b is greater than c. In that case, we can consider big is equal to b. And finally, in the else block, we can consider big is equal to c if the above conditions are false. And now I'll return the value inside big back to the calling function. So let us first take input as three numbers here. Okay, so I'll consider those three numbers are x, y, z. Okay, first number is int of input of, will prompt the user to enter first value. Okay, so similarly I'm going to copy this. Okay, here, so this is y and this is z. Okay, so enter second value. Okay, and next this is third value. Now we have to call this function find largest function by passing parameters as x, y, z. Okay, so I'll use a variable called res to get the result. Okay, find largest of, here the parameters are x and this is y and this is z. Okay, and finally you can print maximum value is. Okay, so the maximum value here is stored in inside variable called res. Now let's run this code and see the result. Enter first value. First value is 180, second value is 150, and third value is 175. Now you can see maximum value is 180. Okay, even if I change the order, like first I'll give a small value like 12, and then second value is 67, and third value is 99. We'll get maximum value as 99, like this. Hello everyone. In this video, we'll implement a function called a factorial function in order to compute factorial of the given number. Okay, so let's implement. Let me first define the name of the function as a factorial function, and it is taking parameter as n. Okay, let's implement this function first. Initially, I'll consider f is equal to 1. Now I will iterate the end loop. Okay, with the help of for loop, I'm going to iterate and obtain elements one by one up to n and multiply with f. Because if you consider 5 factorial, it can be obtained as 1 into 2 into 3 into 4 into 5. Okay, so for I in range of, okay, 1 comma n plus 1, because this is going to give you starting range comma less than end. Okay, so here we can write f is equal to f into I, and finally after computing factorial of the given number, you can return this result, return f. Okay, now I'll consider a number which I'm going to take as input. Okay, and here we can prompt the user to enter any value. Okay, so when you call this function by passing num as parameter, then it is going to return the result, which is a factorial result. So you have to store that inside a variable like res and call this function factorial function, and we'll pass num as parameter, and you can display the result. Okay, factorial result is, here we can display result res. Okay, now run this code and see the result. Enter any value. I am entering value as 5, so factorial result is 120. Okay, just like this. So this is clearly an iterative implementation of the function. Okay, now here I will also implement a recursive implementation of the same function. Okay, so let us suppose rfact is name of the function, recursive factorial. Okay, and whenever n value is equal to 0 or n double equal to 1, in that case we can return 1. This is the base case, because 0 factorial is 1 and 1 factorial is also 1. In the else block, we can write rfact of n. Okay, so basically in order to compute n factorial, it can be obtained as n into n minus 1 factorial. Okay, so we can write like this: return n into rfact of n minus 1. Okay, so let us take another variable here. Okay, r is equal to, I'm calling the function rfact function by passing num as parameter. Now let's display recursive fact result is equal to, okay, and that result is r. Okay, now let's run this code and see the result. Enter any value, input is 5, and you can see the result. Factorial result is 120 and recursive fact result is 120. So we got same answer but implementation is different in each of this function. This is iterative implementation and this is a recursive implementation. Okay. Now we'll discuss about the concept of recursion. What is meant by recursion? Recursion represents function calling itself. Either you can call it direct recursion or indirect recursion. So what is meant by direct recursion? So direct recursion means you are writing one particular function and inside the same function you're basically calling that again. Okay, this is a direct recursive calling. And the other one is indirect recursive calling. In case of indirect recursive calling, what happens is you are writing totally two functions, f1 and f2 for example. Inside f1 function, you are calling function f2, and inside f2 function, you are calling function f1. Okay, just like this. Now there are two very important components of writing a recursion. One is base case, the other one is recursive call or recursive case. So in case of base case, we are going to terminate the recursive calls. That is why we write the base condition to terminate the entire recursive calls. Whereas in case of recursive calling, it's basically used to solve the bigger problem by subdividing into smaller, simpler subproblems. Okay. So let's see this example of recursion. In this example, we are solving factorial of a given number. So let us suppose you're trying to calculate factorial of a number called n. In such case, you can compute factorial of n by first checking if n equal to 0 or n equal to 1. Either when n equal to 0 or n equal to 1, you can return 1 immediately. And this is considered as the base condition of recursion. This is the base condition. Okay. And now similarly, this is else block. Inside the else block, we are trying to return n into factorial of n minus 1. Okay. So this is purely recursive calling. We are recursively calling the same function factorial. Okay. Like this. Now let's see with an example how this factorial function is going to work recursively. So let us suppose I am trying to compute factorial of 3. So what is factorial of 3 here? Factorial of 3 will be 3 into 2 into 1 is equal to 6. Okay. So when I am calling factorial of 3 on this function, n value will become 3. Okay. Now we are checking the condition here, 3 double equal to 0 or 3 double equal to 1. So this will be computed like this, 3 double equal to 0 or 3 double equal to 1. Both these conditions will be false. Since it is false, it will go to the else block. Inside the else block, we are going to call n into factorial of n minus 1. This will be 3 into factorial of 3 minus 1, which is 2. Now we are trying to compute factorial of 2 here. So to compute factorial of 2, again you can observe what is value of n here. N value is currently 2. So for this recursive call, what is its corresponding execution sequence? First it will check whether the 2 is equal to 0 or not. Also 2 is equal to 1. Since both these conditions are evaluated to false, it will go to the else block. Again, inside the else block, the statement is n into factorial of n minus 1. So this will return 2 into factorial of 2 minus 1. This will give you factorial of 1. Okay. Now for this factorial of 1, since value of n is right now 1, since n value is 1, and this recursive call will actually make if condition true. So inside this if condition, 1 double equal to 0 or 1 double equal to 1 is written. Okay. Since 1 double equal to 1 conditional expression is evaluated to true, false or true will be evaluated to true. Once it is evaluated to true, this is going to return value of 1. So once it returns value of 1 back to the calling function, just like this gets evaluated. This is going to be 2 into 1. Value 2 will be returned back to the calling function. And now this is 3 into 2. Okay. 3 into 2. Its corresponding value will be 6. And it is going to be returned back to the calling function, which is factorial of 3 is finally computed as 6. 6 is the result. So this is how recursion is implemented, and this is the working of recursion. And in this recursive calling, we have used the base condition here, and this is the recursive calling sequence. Okay. In this video, we'll discuss about basics of linked lists. First, what is meant by linked list? It is considered as a collection of nodes or data elements which are linearly arranged one after another. Okay. So let us consider an example for the linked list. This is how a sample linked list will look like. This is the head of the entire linked list, and it will be pointing to the first node of the linked list. Let us suppose the first node of the linked list contains data as 10, and its next will be pointing to the next node. And so this is 20. And now its next is pointing to a new node, contains data as 30, and this is pointing to none, end of the linked list. Okay. So each of this node, you can see this is considered as a node, and each of this node contains two parts. One is a data part, the other one is next part. Okay. So let us clearly understand with an example. You can see this is an example of a start of the linked list, or you can also consider it as a head of the linked list. And these are all different nodes that are placed one after the other linearly in the linked list. And the last node will be pointing to none. Okay. Now, how can we define a node here? As we have already discussed, the node contains basically two parts. What are those two parts? One is data part, the other one is next part. Okay. And you can see this is the node. Now initially we have to assign to none. This is none. And you can observe even the data is assigned to none initially. So self dot data equal to data and self dot next node is equal to next node. So both are basically none initially. Okay. Now how do you define a linked list? So linked list contains head of the linked list, where this is also pointing to none initially. Okay. Now when you want to print the linked list, let us suppose there is already an existing linked list and we are trying to display that particular linked list. So for this purpose, you can make use of this display function in order to display the entire linked list. Consider this is representing head of the linked list, and the data part of the first node is 10, and the data part inside the second node is 20, and the data part inside the third node is 30, and this next is pointing to none. Okay. Now when you try to print the entire linked list, so let's see how you can display it with the help of temp. Initially assign temp to self.head. So you can observe temp, I am pointing this temp to the very first node where exactly head is pointing to. Now you have to check whether this temp is none or not. Currently temp is not pointing to none. So immediately display the temp dot data. So which means in the output you will display temp dot data, which is 10, and also you're displaying arrow like this, and then temp is equal to temp dot next node. So from now onwards, temp will be pointing to this next node. Okay. In the next iteration, again you are checking temp. So currently temp is not none. Temp is not pointing to none. So it will display temp dot data. So which is going to be 20. 20 is representing the temp dot data. And later arrow. So this will display arrow. Now temp equal to temp dot next node. So this temp must be pointing to the next node here. Okay. Now since this temp is pointing to this node, again you check temp is none or not. Currently temp is not none. You have to display temp dot data. So which is 30, and then again arrow will be displayed. And finally you can observe temp equal to temp dot next. In the subsequent iteration, temp will be pointing to none. So when temp is pointing to none, this conditional expression will be evaluated to false. So the block of statements will not be executed and the control will be transferred outside the loop. Okay. So this is how you will display the linked list. It contains 10, 20, 30. And if you are writing none here, then you will display none in this place. At the end you can display none. Okay. Now let's see how you can find out the size of the linked list or length of the linked list. So let us consider a sample linked list where the head is pointing to very first node and the first node contains the data as 10, and similarly the second node contains the data as 20, and the third node contains data as 30, and finally this is pointing to none. Okay. Now, whenever you want to find the length of the linked list, you have to start counting each of this node in the entire linked list. So, for this purpose, we can take a temporary node which can point to the first node of the linked list, and we are calling it as current node. So, this is current node, and this current node will be pointing to this node. Now let us start counting the number of nodes here. Initially count equal to 0 while current. Since current is not pointing to none, condition becomes true. So count equal to count plus 1. Initially count is 0. Right now when we are adding this 1, it will become 1. Yes or no? So count value will become currently 1. And later current is equal to current dot next node. Now this current will be moved to the next node. So again it will check the conditional expression current. Since this current is not pointing to none, conditional expression is evaluated to true. So this count will be incremented by 1. So count value will become 2 here. And later current equal to current dot next. So from now onwards this current will be pointing to this node, and again the conditional expression will be evaluated to true because current is not pointing to none. So the block of statements will be executed where count should be incremented by 1. So when the count is incremented by 1, you can see current count will be updated to 3. Okay. Now again current equal to current dot next node. Now this current pointer will be pointing to none here. Okay. Since current is none, this conditional expression will be evaluated to false this time, and control comes out of this while loop and it will return count. So what is the latest count? Latest count is 3. That is exactly representing the size of the linked list or length of the linked list, as there are 3 nodes inside the linked list. Okay. Now let us see how do we insert a new node at the head of the linked list. So for example, let us suppose the head of the linked list is pointing to a node like this. There are only two nodes in the entire linked list. Consider 10, the other one is 20, and later this is pointing to none. Now, in order to insert a new node at the head of the linked list, first you have to create a new node. So how this can be done is new node will be created and it will be pointing to this newly created node, and it contains a data part, and this is next. Initially next is none, and now whatever data that you supply for creating a new node, that is taken here. Let us suppose you have supplied 5, okay, then 5 becomes the data part for this. Now new node dot next node is equal to self dot head. So currently this is the new node, new node dot next node. So which is basically this is representing the next node, and now we are pointing this to the head, where exactly head is pointing to. Now you bring this head to point to this new node. So head must be pointing to this new node. This is how you can implement this linked list, where head is pointing to the first node and its data is 5, later it is 10, and the next node containing data as 20. Okay, so before insertion, you can observe the linked list contains content like 10, 20, and then none. After inserting a node, the linked list contains content as 5 followed by 10 followed by 20 and then none. Okay, this is after inserting a new node at the head of the linked list. Now let us get the next node in a linked list. How to get the next node in the linked list is simply obtain node dot next node dot data. Okay, so I'll show you with an example here. Let us suppose we are considering head of the linked list, and it is pointing to the first node containing data as 10, and its next is pointing to another node containing data as 20, and this is pointing to none. So currently we want next node corresponding data. Okay, so for this purpose what you can do is node dot next node dot data. So I'll consider this is the node, okay, and node containing two parts. You can see data and the other one is next underscore node. So when I want next node corresponding data, which is this one, I'll extract this with the help of node dot, okay, starting from node, take the next node dot data. So with this you can access 20 from here. Okay, now in order to create a linked list, it is simple. You can just create an object for this linked list class and then start initializing the head of the linked list to one particular node. In this case, head of the linked list is initialized to a node or pointing to a node containing data as 2. Because the data is passed as 2 here, it will create a node containing data as 2. Okay, and this will be pointing to none initially. And also they have created s is equal to node of 3, which means here we are considering s is pointing to a new node, and this new node contains data as 3. Okay, and similarly t is another node which is pointing to a new node containing data as 4. T is a node pointing to data containing 4, right? And next, list dot head dot next node is equal to s. So this actually represents linked list containing head dot next node is now pointing to s. Okay, and later s dot next node is equal to t. S is pointing to this node. Now its next node should be pointing to T. So overall we have created a linked list containing data as 2, 3, 4, and later it will be none, because initially every next node is initialized to none here. Okay, like this. Now, when you want to display all the nodes of the linked list which we have just created, you can call display function. This will display data as 2, 3, 4 like this. Now, list.size. This will count how many nodes are there in the linked list. There are currently 3 nodes in the linked list, so output must be 3. And later insert at head. So we are trying to insert a node at the head of the linked list. So which means it should be 6 followed by 2, then followed by 3, then followed by 4. Okay. And now when you want to get the next node of S, okay, if you are starting from here, if you try to get the next node corresponding data, you will get 2. Okay, just like this. Now consider inserting a node in a linked list. So you can actually insert a node inside the linked list at different positions. For example, you can insert at the front of the linked list, or you can insert after a given node, or you can also insert at the end of the linked list. Okay. So whenever you want to insert a new node at the beginning position, in such case, you can do like this. First, you have to create a new node with the data that is passed to create a node. So let us suppose I'll consider an existing linked list just like this. This is representing the head of the linked list, and it is pointing to very first node of the linked list. Let us suppose it contains the data as 10, and the next node contains data as 20, and later this is pointing to none. Okay. Now let us consider node creation. So first I'll create a node where I'll consider this new node will be pointing to newly created node, and this node will have two parts. One is a data part. Whatever data that you pass will be stored here. For example, 5 is the data, and this will be pointing to none initially whenever you're creating like this. Okay. Now to insert this node at the start of the linked list, you just need to assign its corresponding new node next to point where the head is pointing to. Okay. So make this to point where head is pointing to. Okay. Once you insert this, from now onwards head should be pointing to this node. So self.head is equal to new node, which means this head is now pointing to the node where new node is pointing to. Okay, just like this. Clear? Now let's go to inserting a new node after a given node. Okay, let us suppose you are asked to insert a new node after a specific node or data. Okay, so for this purpose I'll consider a sample linked list where head is currently pointing to nodes like this. So this is the first node containing data as 10, and now the second node data is 20, and we have third node also which is 30. Okay, and later this is pointing to none. Okay, now in this context you are asked to insert a node after a given node. Okay, so the idea is to basically consider previous node. Let us suppose the previous node data is 20 and you are asked to insert a new data which is 25. Okay. So first you have to search for the previous node. This node containing data as 20 is available in the linked list or not. Suppose if this is not available or previous node is none, in that case you have to display that the previous node must be in the linked list, because the idea is to insert a new node after the given previous node. Okay. Now, if previous node is not none, in that case, you have to create a new node and specify this new data. Okay. So let me create a new node, and this is pointing to the node, newly created node, and this contains two parts. So one is a data part, the other one is next part, and now this data part is 25. Okay. So to place exactly here, so we have already moved this previous node. Currently you can see this is representing a previous node position. Now the idea is to insert this new node after the previous node, right? So for this purpose, you have to do this action, which is new node dot next is equal to previous node dot next, which means new node next must be pointing to previous node next. Also, previous node dot next is equal to new node. So previous node dot next should be pointing to the new node. Okay, just like this. So this is how you can insert a new node after the given node called 20. Okay. Now consider inserting a new node at the end of the linked list. Okay. So to insert node at the end of the linked list, first consider an existing linked list where head is currently pointing to the very first node, which is 10, and the next node is 20. Okay, and later this is pointing to none. Now the idea is to insert a new node here. So for this purpose you have to create a new node and insert the data, whatever new data that you have given here. So let us consider new node pointing to newly created node, and it contains data as 30. Now the idea is to insert this 30 at the end of the linked list. So for this purpose you have to check whether the self.head is none or not. Currently head is not pointing to none, so this condition will be false. Now you have to make last to point exactly where self.head is pointing to. So which means initially I'll consider last to point where head is pointing to. Now you check last dot next. So currently last dot next is not none. So you can start moving last to the next position. So in this case, this last pointer will be moved to the next position. Okay. And again in the next iteration, last dot next is checked whether it is none or not. Currently last is pointing to this node and last dot next is none. Okay. So this condition will be evaluated to true. So corresponding action is last equal to last dot next will not be executed because the conditional expression itself is evaluated to false. So it will come out of this while loop and it will execute last dot next is equal to new node, which means last dot next. So this will be pointing to the new node, and this is how the updated linked list contains 3 nodes. And obviously when you create a new node, it will be pointing to none, isn't it? Okay. So previous linked list has got only 2 elements. So one is 10, the other one is 20. Now the updated linked list has got totally 3 elements, 10, 20 and then 30. Okay. This is how you can perform insertion of a new node at the ending position. Now consider how to search an element in a linked list. First, you have to consider an existing linked list, or you can start creating a new linked list where the key element X is searched inside the linked list. So let us suppose if the X is available inside the given linked list, then you can print yes. If it is not available, then you can print no. Okay. So consider this example where the linked list contains 14, 21, 11, 30, 10. Okay. Now you are asked to search an element called X equal to 14 inside the linked list. Since this element is available inside the linked list here, so you have to print yes. Okay. Suppose if you are given a linked list like containing elements 6, 21, 17, 30, 10, 8. But if you are trying to search an element called X is equal to 13, 13 is not available inside this linked list, then it has to print output as no. Okay. So let us go through the solution for this searching of an element inside the linked list. So you can see this is the function which will help you to search an element inside the linked list. Okay. So consider a sample linked list here where head is pointing to the very first node of the linked list. So consider the linked list containing first node as 10, and the second node is 20, and then the third node is 30, and then it is pointing to none. Let us suppose there are only 3 nodes. Okay. Now, in order to search an element called X is equal to 30, okay, you're asked to search an element called X is equal to 30, and you can see this 30 is clearly available inside the linked list. Now the same operation will be done by this search function, just like this. First you have to consider current which points to self dot head. So this is a current, and this is pointing to the very first node of the linked list. Now look at this while conditional expression, current not equal to none. Is currently this is not pointing to none. So first you have to check whether this current dot data is equal to X or not, which means current dot data, this is the data part inside this node. Current dot data is clearly 10. 10 double equal to X, X value is 30. 10 double equal to 30, condition will become false. Now associated statement will not be executed, and control comes here, and it will execute current equal to current dot next. From now onwards, current will be pointing to the next node, just like this. Current will be pointing to the next node. Now again check this conditional expression here, current not equal to none. Yes, current is not pointing to none. Now this conditional expression will be evaluated, current dot data double equal to X. What is current dot data here? Current dot data is 20. So 20 double equal to 30, condition will become false. So the associated statement will not be executed, and control comes here, current equal to current dot next. Now this current will be pointing to the next node, just like this. Okay. Now again, while conditional expression, current not equal to none. Yes, current is not pointing to none currently. And look at the conditional expression, current dot data double equal to X. So right now current dot data is clearly 30. Now we are checking 30 double equal to 30, condition will become true this time. So it will return true. Okay. So returning true represents we are able to search and find the element inside the linked list. Okay. So for example, if the element is not there, in that case, after searching the entire linked list, then control comes here and it will return false if the element is not available inside the linked list. Okay. So this is how search operation works in a linked list.
Hi, in this lecture we will talk about optical flow, which is one of the most important techniques that we should know before moving to learn how to convert our video into animation. Firstly, what is optical flow? Optical flow shows the movements of the pixels between two frames. For example, let's say that we have these two frames. This is the first one and the second one. The optical flow for these two frames is this one. This optical flow will tell us which pixel in the first frame moved in the next frame and the direction of movement and the amount of movement. So as you can see here, all the pixels that represent this card, they moved in a specific direction in the next frame. So each one of them has its own vector that represents the direction of movement and the amount of movement. We will call all these vectors that represent the movement of each pixel by optical flow. In 2015, they started using deep learning to solve optical flow tasks. They tried to train a U network to find the optical flow from two images or two frames. The structure of the U network that they used, it is this one here. We will pass the first frame of our video through this branch here. There are many convolutional layers in this branch. We will pass this image through them, through all these layers, all these convolution layers. And we will do the same thing for the next frame of our video. We will pass it through this branch, all these convolution layers. And here we will do special thing. We will find the correlation between these feature maps. So how can we do that? To understand the idea behind this correlation layer, we should understand this formula here. Firstly, here we want to find the correlation between two patches. One of these patches is available in F1 feature map and the other patch is available in F2 feature map. The center of the first patch, it is X1, which in this case it is this location here. The index of this location is 1, 1, and the center of the other patch is X2, which is this location here. The index of this location, it is 2, 3. Because as you know, in Python we start with index 0. So the row of this center, it is equal to 2, and the column of this center, it is equal to 3. Now what we will do actually, we will do dot product. This symbol here for dot products. Okay. This formula here will multiply this patch with this patch element wise, and after that it will add the results to get just one single value, which is something similar to the convolution operation that we talked about previously. Here, this patch in F1 feature map, it is like a kernel that we will multiply with this patch in F2 feature map. So this operation, it is something similar to convolution operation. Now after applying this formula, we will get just one single value. This value will represent the relationship between this batch and this batch. So now we are doing matching a process, which is something very important in optical flow. When the correlation between these two patches is very high, it means these patches, they are very similar to each other. And by doing this, we will be able to know that X1 batch, it is just moved and created X2 batch in feature map 2. Our neural network will try to learn these correlations, and by using these correlations we will be able to match between batches. Here we took just one single example about how to compute the correlation, but actually we will find the correlation of this batch with all possible batches in this feature map too. And we will go to another batch here and we will find the correlation between this batch and all possible batches in F2. And when we want to find the correlation between, for example, the first batch in F1 feature map and all batches in F2 feature map, we will get new feature map. And when we want to find the correlation between the second batch in F1 feature map and all batches in F2 feature map, we will get another feature map in the output. Okay, so we will get very large number of feature maps. So now the depth dimension of the output will be large, which is equal to the possible patches inside F1 feature map or possible patches inside F2 feature map. As you can see here, these two feature maps, F1 and F2, they have the same size. So now we have very large number of feature maps in the output. Our output is very large, and that's not good. We did a lot of computations to get this output. This thing will take time, and if our output is very large, so it will take a lot of our memory also. All these things, they are not good. So what we will do here, we will reduce the spatial dimensions of the output. How can we do that? The idea is super easy. Here we will not compare this batch with all possible patches in F2, but with the nearest batches in F2. So here what we will do, we will restrict the search space. For example, here we have our batch, which is X1 in this case, this one here. Here we will not find the correlation between X1 and all X2 patches, but we will find the correlation between X1 with the nearest X2 patches to our X1 batch. In other words, here is our X1 batch, and here is the center of this batch. Let's say that the displacement, the maximum displacement, equal to 1. By doing this, we will restrict the search space. Now we will find the correlation between this X1 with this batch here that has the same center of X1 batch. Okay? And this batch here, which moved just one step from the center of X1. So now we have two batches, and this batch here also we have 3 batches, and this batch here. So we have 4 batches. So in other words, we will just find the correlation between this batch with the patches that are near to the center of our X1 patch, but in F2 feature map. So here we didn't take all patches in F2 feature map, but just a few of them. So here we reduced the computations, because here we will not use this formula a lot. And we will take another patch in F1 feature map, and we will find the nearest patches in F2 feature map for this patch in F1 feature map, and we will do computations to find the correlation, and we will do this process again and again until reaching the last patch in of one feature map. By doing this, we will reduce the size of the output from our correlation layer, and we will speed up our network because we will reduce the computations. But the problem here, you will not be able to match any patch in F1 feature map with very far patch in F2 feature map. So for example, if you have very fast object in your video, if you use this correlation layer, you will not be able to match the batches that are related with this object in the first frame and the next frame. So you will not be able to get the correct optical flow for this object. And we will pass the output from this correlation layer through many layers, and we will pass the output through this refinement part of our network. This refinement part will increase the spatial dimensions of our optical flow by using up convolution layers. And here's the output optical flow feature map. You can see the resolution of this optical flow. It is not similar to the resolution of the input frames. And they found that adding another convolution layers will not be helpful. It will increase the spatial dimensions of the optical flow, but it will be something similar to any other simple resizing methods. So for this reason, they use the variational refinement to make the resolution of the optical flow similar to the resolution of the input frames. In the next lecture, we will talk about GM flow method to find optical flow. Thanks for watching.
Now let us see how to find a middle element in the given linked list. Okay. So for example, if you are given a linked list like this containing elements 1, 2, 3, 4, 5, what is the middle element of this linked list? It contains the middle element as 3. 3 is the middle of the linked list, so the output should be 3. Okay. Now consider a linked list containing even number of nodes. The previous example contains an odd number of nodes here. Now let us consider even number of nodes like 1, 2, 3, 4, 5, 6. These are the different nodes of the given linked list. Then you can print the second middle element. So for an even number of nodes, you can observe these two nodes are considered as middle elements or middle nodes. So you have to print the second element. This is going to be the second element. So the output must be 4 here. Okay. Now this problem can be solved with the help of two pointers approach. So what is two pointers approach? Where we consider two pointers to solve this particular problem. One pointer is considered as a slow pointer and it will be moved by only one position, whereas the other pointer is a fast pointer which is moved by two positions. Okay. The moment the fast pointer reaches the ending position, slow pointer will be still pointing to the middle element in the linked list. So this is a method. Now let us consider the solution and go step by step. So for this, I'll consider a sample linked list. So let us suppose this is head of the linked list pointing to the very first node containing data as 1 and the second node containing data as 2 and then the third node containing data as 3 and then the fourth node containing data as 4 and then the fifth node containing data as 5 and finally this is pointing to none. Okay. Now let us consider two pointers here. One is slow pointer and the other one is fast pointer. Okay. So here initially slow pointer and fast pointer both will be pointing to the very first node where exactly head is pointing to. Even here also we are considering a fast pointer pointing to the first node. You can observe slow is equal to self dot head and fast is equal to self dot head, which means the node which is pointed by head. Okay. Now we need to check whether the fast or fast dot next has reached none or not. Okay. So let us see here. The moment fast is reaching none or fast dot next is reaching none, then it will come out of the loop. Okay. So currently fast is not pointing to none, as well as fast dot next is also not pointing to none. So you have to perform move operation from the current node to the next node, which is with the help of slow pointer. So you can see this slow must be moved to the next node. Okay. So this slow must be pointing to this node right now. And then how about the fast pointer? Fast pointer must be moved by 2 positions. So which means this particular fast pointer will now be pointing to the third node, just like this. Okay. In the next iteration, again you have to check whether the fast is none or fast dot next is none. Currently fast is not none, as well as fast dot next is also not none. So you have to move this slow by 1 position again and fast by 2 positions. So when you move this slow pointer by 1 position, it will reach to this particular node. Okay. Now we will move fast pointer by 2 positions, just like this. Fast pointer is moved by 2 positions and fast pointer will reach this position. Okay. In the next iteration, again check whether the fast is pointing to none or fast dot next is pointing to none. Currently fast is not pointing to none, but fast dot next will be pointing to none. So this conditional expression will be evaluated to false, because true and false will be evaluated to false. So the block of statements will not be executed, and later it will print the middle element as a slow dot data. Currently slow is pointing to this node and slow dot data will be 3. Okay. So in the output this is going to display result as 3. Okay. Next one is checking whether two given linked lists are identical or not. So when can you say two given linked lists are identical? If and only if they have same data and even the arrangement of the data should be same. Then only you can say two linked lists are same. For example, here A is the first linked list. It contains elements as 1, 2, 3, 4 in this order. And B is another linked list containing elements as 1, 2, 3, 4. So you have to print output as identical. Okay. Now consider another example. A is a linked list this time containing elements 1, 3, 5, 2. B is another linked list containing elements 1, 3, 4, 6. So both these linked lists have different elements like 5 here and 4 here and 2 here, 6 here. So they are said to be not identical. Okay. Now let's go through this solution here. First, I'll consider two linked lists. Okay. So A is a linked list and this is pointing to the first linked list corresponding. So let us suppose this is head of the first linked list and it is pointing to the very first node 1 and the second node is 2 and the third node is 3 and later this is pointing to none. Okay. Now consider similarly another linked list. So B will be pointing to this linked list. Okay. I'll consider head of the linked list. Okay. And this is also similar to the first linked list containing elements as 1, 2, 3. So 1, 2 and this is 3 and it is now pointing to none. Okay. So if this is a scenario, initially you can see A is equal to self dot head. So consider A currently pointing where head is pointing to in the first linked list, and similarly B is equal to list B dot head. So this is my list B. Okay. So where B is pointing to this list B, very first node in the linked list. Okay. Now look at this while loop. A is not none and even the B is not none. Currently A is not pointing to none. Also B is not pointing to none. Since both these conditions are evaluated to true, first we have to check A dot data is not equal to B dot data or not. So A dot data is 1. You can see A dot data is 1 and 1 is not equal to B dot data. B dot data is also 1. 1 not equal to 1. Condition will become false. So associated statement will not be executed. Now you have to move this A by one position and B by another position. So which means A will be pointing to the second node and even B is also pointing to the second node. You can see A is pointing to this node and even B is pointing to this node. Okay. So again, if you look at this conditional expression in the second iteration, A not equal to none and B not equal to none. So currently A is not pointing to none. Also B is not pointing to none. Now you have to check A dot data not equal to B dot data. So A dot data is 2, 2 not equal to B dot data which is 2, 2 not equal to 2 condition will become true or false. So clearly condition will become false. And now again move this A dot next, okay, and B to the B dot next. So which means currently A will be pointing to the third node in the first linked list and B will be pointing to the third node in the second linked list. Again, if you look at this while conditional expression, again this conditional expression A not equal to none and B not equal to none, which means clearly A is not equal to none. Okay, so and even B is not equal to none, both the conditions are evaluated to true. Again you check A dot data not equal to B dot data, which means 3 not equal to 3, condition will become true or false. Condition will become false, so the associated statement will not be executed. And again A equal to A dot next and B is equal to B dot next. So which means A will be now pointing to none. Okay. And then B will be pointing to none after moving to the next node. Okay. Now if you look at this conditional expression, A not equal to none, condition will become false, and also B not equal to none, condition will become false, which means false and false will be evaluated to false. So it will come out of this while loop and it will return A double equal to none and B double equal to none. So currently A is pointing to none and also B is pointing to none. Both these conditions are evaluated to true. True and true will be evaluated to true. So true will be returned back to the calling function. Clearly both these linked lists are identical. That is why true is returned back. If any one is different from the other, which means not identical, in that case one linked list will reach the none, the other linked list will not be reaching none. Okay. So this is how you can check here. Okay. And sometimes what happens is the data is not matching in linked list. So in that case, clearly A dot data not equal to B dot data. This conditional expression will be evaluated to true and it will return false immediately. So this is how you can check whether two given linked lists are identical or not. In this video, we'll implement a Python code in order to find out the maximum value in the given linked list. So let us consider a sample linked list. For example, 24 and the next element is 56 and the next element is 33 and the next element is 21. So out of all these elements, which is the maximum value in the linked list? 56 is the maximum value. So the output should be printed as 56 here in this case. Okay. So let us implement this particular program. To start with, in a linked list, it contains nodes, isn't it? So you have to create a class called node, and each node contains data part and next part. So let us define a constructor for this purpose, which is init. Okay, and initially data is equal to none. Okay, now let us initialize the data part, and whatever data that you are passing is taken here. Okay, so by default, if the data is not passed, it is taken as none. Okay, this is a default parameter. Okay, now you can initialize the next part of the node as none directly, just like this. So this is a class for creating a node inside the linked list. Now let us create a linked list class. So class linked list. Now inside this class, let us define again constructor part, which is init constructor, to initialize the head of the linked list. Initially, head of the linked list will be pointing to none, right? So self dot head is equal to none initially. Okay, so this is a constructor inside the linked list. Now let us write a function which is used to add nodes to the linked list. Okay, so I'll call this function as add node function. Okay, and here in this function, where are we going to add the node? Is it at the starting of the linked list or at the end of the linked list? Let us choose adding the node at the end of the linked list. So in order to add the node at the end of the linked list, so mainly the idea is to create a new node here. Okay, so let us create a new node and pass the data to be stored inside the new node. Okay, first check whether this head is none or not. First you need to check whether the head is none or not. So if self dot head is none, in that case whatever new node that you are inserting will be pointed by the head, because the head of the linked list will be pointing to only one node in that case. Okay, so because currently the head is pointing to none, whenever you are inserting a new node, after insertion head will be pointing to that new node, isn't it? So let's make this as self dot head is equal to new node. Okay, just like this. Now when this condition is evaluated to false, you have to traverse through the linked list, because it represents linked list is not empty right now. Okay, so whatever insertion that you are making will be done at the end of the linked list, isn't it? It should be done at the end of the linked list, isn't it? So let us do this insertion operation. In order to place the node at the end of the linked list, you need to consider a temporary node, okay, which is I'll call it as current node, and this current node will be pointing to head of the linked list. Okay, now currently head and current both are pointing to the first node of the linked list. Okay, now you have to traverse the current to the last node. to point to the last node. So this can be done by the help of a while loop, where I'll test current dot next is not none. Till that time I'm going to iterate this loop. The moment current dot next is reaching none, it will come out of the loop. Okay. So inside the loop, I'll move this current to the next node. So this can be done as current equal to current dot next. Okay. And now finally, you have to assign the new node to current dot next. Assign the new node to the current dot next. So this is current dot next is equal to new node. Okay. So this is how you can implement the add node function, which will help you to insert a new node at the end of the linked list. Okay. So now let us implement the actual function, which is finding the maximum element in the entire linked list. So for this purpose, we'll consider name of the function as find max function, and this find max function, first we will consider whether the linked list is empty or not. For this purpose, you can just check self dot head is none or not. Suppose the self dot head is none, you can directly return none in this case. Okay. Now to find out the maximum value, okay, so I'll take a variable like max val is equal to initially very first node corresponding data. I'll take it into maximum value. So this can be done by writing self dot head dot data. Okay. And I'll also consider a current node, so which will be holding the second node. Okay. So this can be done as self dot head dot next. Okay. Now we will check using the while loop. Okay. While current is not none. Okay. While the current is not none, first we'll check the condition whether the current dot data, okay, current dot data is greater than the max value. In that case, we'll update max value, because as of now we are considering max val will be holding the maximum value. But the moment you identify a new node, okay, that is current corresponding data is greater than the maximum value, you are going to take that current dot data inside the max value. So that is current dot data. Okay. Now let us, after doing this action, now we have to move to the next node. To move to the next node, make this current to move to the next node. This can be done by writing current equal to current dot next. Okay. And finally, after finding the maximum value, so we just need to return the maximum value. Okay. So this is how you can identify the maximum value with the help of find max function. Okay. And this is implemented inside the linked list class, and the linked list class also contains other method like add node. Okay. Now let us create an object for this class, which is a linked list class, and start adding nodes into the linked list. So this can be done by considering a sample object name like my underscore list, and this object is created for a class called linked list class. Okay. So is equal to linked list class. Okay. Now let us add a new node here. Okay. My underscore list dot add node function. So I am adding a node corresponding data as 5, and similarly Okay, let us suppose I'm trying to add new nodes with the same statement. Okay, so this time I'm adding a new node as 10, and similarly I'll add a new node as 8 here. Okay, also I'll add a new node as 3 here. Clear? So now once you add all these nodes to the linked list, okay, so you just need to find out the maximum value by calling the respective function which is implemented to find out the max value. So that is the find max function. So use the same object name, that is my list dot, and this is the find max function that will identify the maximum value in the entire linked list, and it will return the value to a variable called maximum. Now you got the maximum value. Okay, you just need to print this maximum value. So that is maximum value is, okay, just display this maximum variable, okay, corresponding value. Got it? So let's run this code and see the result. And somewhere I've written a spelling mistake, that is SELF, okay, and it is showing line number 5. Yeah, here SELF. Now let's run this code and see the result. You can see the maximum value is 10. So this is the linked list, and you can observe after adding these nodes, the linked list will look like this: 5 followed by 10, and then the third node is 3, and then the fourth node is 8. Okay, so out of all these nodes, what is the maximum value? 10 is the maximum value. That's why it will return the maximum value as 10, isn't it? Just like this. Okay, now consider this program. We need to write a Python code in order to delete the linked list. Okay, so to delete a linked list, first creation of the node class, creation of the linked list class and their corresponding constructors for both the node class and linked list class is common, and also adding a node to the linked list, so which is basically we are trying to add a new node at the end of the linked list, that is also common. And later we are creating a linked list with the help of add node function. Okay, just like this. Now we'll try to implement a new function which is used to delete the entire linked list. So in order to delete the entire linked list, you just need to define, okay, delete list. Okay, and this delete list function, so directly you can simply make self dot head is equal to none. So right now the head of the linked list will be pointing to the very first node. Okay, and after this there will be second node, and then third node and fourth node, just like this. But the moment you place self dot head is equal to none, okay, then you are no longer will be able to access that particular linked list. So this is how simply you can delete the entire linked list. Okay, now we just need to show that the entire linked list is already deleted. Okay, this can be done by printing the linked list, isn't it? So in order to print the linked list, we have to define the function which is print list function. Okay, and to print the entire linked list, I'll take a current node which is referring to the first node of the linked list. Okay, where exactly head is referring to. Now I'll traverse this particular current until it reaches none. So that's why we can write while current is not none. So we can just print the data which is pointed by this current. Okay. So this is print of current dot data. Okay. And after that I'll create some space while displaying these elements. Okay. Now we can move this current to the next position, because the moment you have printed the first node corresponding data, now you just need to move to the second node and again print the data of the second node. Okay, and so on like this, isn't it? So finally I'll print something like none here. Okay, at the end the linked list contains none. Okay, so this is how you can implement print list. The moment you created the entire linked list by adding nodes into the linked list, so this is the general linked list for this data, right? Now let us print the entire linked list before performing the deletion operation on the linked list. So that can be done by first printing the statement, that is linked list before deletion. Okay, I'm trying to print the linked list before deletion. So this is my list dot print list. Okay, and this will display the linked list before performing deletion. Now let us perform the deletion operation on the linked list. So this is the name of the function that is used to perform this deletion operation here. So now my underscore list, okay, dot, so delete list function is called. Later we are again calling print list, because after deletion, so what are the contents of the linked list? So I'm trying to print or access the linked list before deletion and after deletion. Okay, so let's run this code and see the result. You can see here clearly linked list before deletion. You can observe 5, 10, 3, 8, none. Suppose if you want me to represent that exactly in the form of a linked list, where I'll show you arrow mark between the nodes data. Okay, so let's create and run this linked list corresponding operation, which is deletion operation. So linked list before deletion, it contains 5, 10, 3, 8, none. And the linked list after deletion, it is having only none, because we are trying to delete the entire linked list. This is done very simply by making head to point to none, so that you won't be able to access the entire linked list after modifying head to none. Okay, so this is how you can delete the entire linked list. Okay.
Hi, in this lecture we will learn how to do style transfer with Python. Firstly, we will import CV2 and we will import transforms package from Torch Vision, and we will download the out of domain image that we will use as a style image. So firstly we will type x0 equal to image.open, and here we should pass the path of our style image, our out of domain image. But actually here we should import this image class. How can we do that? From pil import image class, like this. Okay, now we have our out of domain image, our style image, which is our clear image. We will resize our image and we will make the height of this image equal to 256 and the width of this image equal to 256. Here we will specify the device that we will use in forward diffusion and reverse diffusion, which is our GPU. Now we will convert this x0 to numpy array like this. Here we should import numpy as np, and here we will type np.array and we will pass x0. So now we converted this x0 into numpy array. After that, we will use transforms.toTensor to convert this numpy array into PyTorch tensor. After that, we will add a new axis, and the length of this new axis is equal to 1, which is the batch dimension. Now we will send this image, this clear image, this style image to our device. So we will type x0.toDevice. Now we will make xt equal to x0. Now we are at time step 0. This is our clear image. So we will make xt at time step 0 equal to x0, which is our style image. Now we will import DDIM pipeline from diffusers. Here we will specify the ID of the model that we want to use. Here we will use this model, DDPM Church 256. This model will generate church images, and you can use other model here like this model, DDPM EMA Celebrity AHQ 256. Okay, but now we will use this model, DDPM Church model. We will specify the device that we want to use. Here we will type image pipe equal to DDIM pipeline.from pre-trained. Here we will pass the model ID, the ID of the model that we want to use, the ID of the diffusion model that we want to use, and here we will send this pipeline to our device. Now we have our image pipeline. This pipeline will make it easy to use our diffusion model to generate images. Here we will generate one image. We will call it image 1, which is equal to image pipe, and here we will specify the number of entrance steps, and we will make it equal to 50. Okay, here we are using DDIM pipeline. In other words, we are using DDIM scheduler, so we can use very small number of time steps to generate the images. Dot images, and here we will open these brackets and put 0 between them. Now we have our image 1. So now we generated one image using our church DDPM diffusion model. We talked previously about this function, getXCapital using DDIM function. This function will do forward diffusion, and as we said previously, we will use this function to generate XTCapital for the out-of-domain images or in-domain images. Okay. Now, we said previously that we downloaded our style image, and now our style image, it is available in this variable xt variable. Now what we will do, we will call this getXCapital using DDIM function. We will pass xt, our style image, the pipeline that we want to use, our image pipeline, and the device that we want to use, which is Coda, our GPU. Now we will get this XTCapital. It is the noise that related with our style image. Here we will make XTCapital style equal to XTCapital. Our style image, it is this one here, okay, which is available here in this place. This is our style image. And xt capital for this style image, it is this noise here. This is xt capital for this x0, this style image. Now, as we said previously in the previous lecture, we can do reverse diffusion using DDIM sampling algorithm to generate our style image again from this xt capital. And now we have our style image. Okay, this is our style image. Now we know that we have xt capital for our style image, for our out of domain style image. Now we will import these packages: cv2, transforms, torch, numpy, and tqdm package. Now we will create our content image, which is in domain image. We will use our diffusion model, our DDPM church model, to generate this image. How can we do that? Firstly, we will take the time steps from image pipe.scheduler.timesteps. Now we have this PyTorch tensor. The first element in this tensor represents the first time step in reverse diffusion, and the last element in this tensor represents the last time step in reverse diffusion, which is time step 0. Now we will create a noise. We will take this noise from the Gaussian distribution, the standard Gaussian distribution. Here we will make xt capital content equal to this noise, because this noise we will use it to generate our content image. So it is xt capital for this content image. Now we have xt capital content, which is equal to this noise, and we will make xt content equal to noise, because as you know, t small here will be equal to t capital when we are at the first time step in reverse diffusion, which is time step t capital. So now xt small content equal to noise, which is this one here, or in other words, xt content equal to xt capital content. Now we will pass it through these time steps. Okay, we will get the number of the current iteration for this loop and the current time step. What we will do, we will take alpha bar t from image pipe.scheduler.alpha as cumulative, and here we will pass the current time step. Now we will check if the current time step it is not equal to 0, it is greater than 0. In this case, we will find alpha bar t minus delta t from image pipe.scheduler.alpha as cumulative. And here we should get the next time step, or time step t minus delta t in reverse diffusion. How can we find this t minus delta t time step? We will use this time steps tensor, image pipe.scheduler.timesteps, and here we will pass the index of time step t minus delta t, which is I plus 1. Now we have our alpha bar t minus delta t. But if t is equal to 0, we are at time step 0. At this case, we will make alpha bar t minus delta t equal to image pipe.scheduler.final alpha cumulative product, which is equal to 1. Now what we will do, we will use our model. Firstly, we don't want to update the weights of our model, so we will put this context manager with torch.noGradient. So we will not compute the gradients for anything inside this context manager. We will prepare the input to our model. So a model input equal to image pipe.scheduler.scale model input. Here we will pass xt content and the current timestamp. Okay, here we will compute the predicted epsilon. So predicted epsilon at time step t, it is equal to image pipe.unit. Here we will use our diffusion model. Here we will pass our model input, the current time step, and we will get the predicted epsilon. Now we will compute predicted x0, which is equal to xt content minus the square root of 1 minus alpha bar t times the predicted epsilon divided by the square root of alpha bar t. Here we will use a clamp method to make the lowest possible value inside this predicted x0 tensor equal to -1, and the highest possible value in predicted x0 equal to 1. This image pipe.scheduler.configuration.clip sample range, it is equal to 1. Okay. Here we will compute xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times predicted epsilon. Here we will make xt minus delta t equal to xt content, because now t it is equal to t minus delta t. The current time step it is t minus delta t. And we will do this thing again and again until reaching time step 0. Now we created our content image. This is our content image. We used pil.image.fromArray method to display this image. When we reach time step 0, so now xt content it is x0 content. We will take this image from xt content tensor. As you know, it is a batch of samples. We will take just the first sample. As you know, this batch has just one sample. We will take this sample. We will rearrange the dimensions of this sample. We will put the height dimension firstly, after that the width dimension, and finally the channel dimension. Now we will type pil.image.fromArray. Here we will firstly take this x0, we will send it to our CPU because we can't display this image without sending this tensor into our CPU. After that, we will make the lowest possible value in our tensor equal to -1 and the highest possible value in our tensor equal to 1. We will multiply this tensor by 0.5 and we will add 0.5 to the resulted tensor. Finally, we will multiply this tensor with 255 to make the lowest possible value in our tensor equal to 0 and the highest possible value in our tensor equal to 255. We will convert the elements of this tensor to integers. We will convert this tensor into numpy array, and we will convert the type of this array into unsigned integer 8. And now we have our content image, which is this image here. Now let's do style transfer. We will take the style of this style image and we will put it in this content image. How can we do that? Firstly, we will get timesteps tensor from image pipe.scheduler.timesteps. Here we will make xt style equal to xt capital style, and we will make xt content equal to xt capital content. As you know, here we will do reverse diffusion. The first timestep in this reverse diffusion it is t capital, so t small here at the first time step it is equal to t capital, so xt style it is equal to xt capital style that we created previously, and xt content it is equal to xt T capital content. This xt capital style, it is the noise that related with this style image. This xt capital content, it is the noise that related with this content image. Now we'll create this variable xt new and we will make it equal to none. Firstly, we have this gamma variable, we will make it equal to 0.7. We said previously that the best value for gamma variable equal to 0.6, but when you are working with out of domain images as style images, it's better to try many different values for this gamma variable to get the best image. Here we will make editing steps equal to 400, which means that we will stop the content injection if the current time step it is smaller than or equal to 400. Now we will create this loop. We will pass it through our time steps. We will start with T capital and we will end with 0 time step. Firstly, we will take the value of alpha bar t, which is equal to image pipe.scheduler.alpha's cumulative product, and here we will pass the current time step. And we will make this condition. If the current time step it is not equal to 0, at this case, alpha bar t minus delta t will be equal to image pipe.scheduler.alpha's cumulative product, and here we will pass t minus delta t time step, which is image pipe.scheduler.time steps, and here we will pass I plus 1. But if the current time step is equal to 0, at this case we will make alpha bar t minus delta t equal to 1. Okay, now we will make this condition. We will do content injection if the current time step is greater than edit steps greater than 400. Now what we will do in this content injection, firstly we will find h content. We will create this variable, gate variable, which is equal to content, and here we will prepare the input to our diffusion model. So model input will be equal to image pipe.scheduler.scale model input, and here we will pass xt content and the current time step. Here we will create this hook. This hook we will use it to get the content feature maps from the bottleneck of our diffusion model. So let's create this hook, h content hook. It will be equal to image pipe.unit, and here we will type down blocks, and we will take the final down block, which is down block 5, and inside this down block we have ResNet blocks. We will take ResNet block with index 1, and here we will specify the layer inside this ResNet block that we want to take the feature maps from, which is convolution layer 2. And here we will use register forward hook method to create our hook. We will pass a function. This function it will work on these feature maps that we will get from this conv2 layer. Let's go and see this get h content function. This is get h content function. Firstly, we will make h content equal to none, h style equal to none, gate variable equal to none. Here we will create get h content function. PyTorch package will give us 3 things: the module, the input to the module, and the output from the module. In the other words, the input to this convolution 2D layer and the output from this convolution 2D layer. Here we will take the output from this layer. Firstly, we will make this h content variable global variable, which means when you change this variable in this function, this variable will change in any other place, even outside this function. And when you change this variable in any other place outside this function, so this variable will change inside this function as well. And the same thing for this gate variable. We will make this gate variable global variable. So when we change the value of this variable outside this function, so the value of this variable inside this function will change also. We made the value of gate variable equal to content. Okay, so let's see that. Here we made gate variable equal to content, and as we said previously, gate variable, it is a global variable, so its value in this function will change also. And now the value of this gate variable, it is not none but content. So now this condition, it is true, so we will make each content equal to the output. The output feature maps from this layer, from this bottleneck of our U network. And after that, we should remove the hook. How can we remove the hook? We just need to type the name of the hook that we created, which is this one here, edge content hook. Okay, we should type the name of this hook, edge content hook dot remove. By doing this, we will remove this hook. We need to remove this hook to be able to create another hook. Okay, now let's go back to our loop. PyTorch will call this function automatically when we reach the bottleneck of our diffusion model. Now we created our hook that we will use to get the content feature maps from our unit. Now we will use our diffusion model. We will type this context manager. Inside this context manager, we will use our U network. Predicted epsilon, it will be equal to image pipe.unet. Here we will pass the model input and the current timestamp. So now we used our U network. We will move it through our U network, and when we reach the bottleneck of our U network, when we reach this layer, the convolution layer inside this ResNet block, inside ResNet block with index 1 and down block with index 5, when we reach this layer, PyTorch will call this getEdgeContent function. And here we made gate equal to content, so we will make EdgeContent equal to output. So we will make the output feature maps, the content feature maps in this EdgeContent, and we will remove this hook because we don't need it anymore in this time step, in this current time step. Now what we will do, we will find the predicted x0, which is equal to xt contents minus the square root of 1 minus alpha bar t times the predicted epsilon divided by the square root of alpha bar t. And here you should know that we should not use a clamp method. We should not restrict the predicted x0 when we do content injection to make sure that we will get good result. Here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times predicted epsilon. Now we will make xt minus delta t equal to xt content. So now we have edge content. Now let's take edge style. How can we do that? Here we will create another hook that we will use to get the style feature maps from our U-network. How can we do that? We will type hstyle hook, it is equal to image pipe.unet.downblocks pipe.reasonets1.conf2. We will take hstyle tensor from the same layer that we used to take hcontent tensor. Okay, we should do that. And here we will use register forward hook method to create our hook, and we will pass the function that we will use to get the output and the input and the module. Let's go and see this get hstyle function. This is get hstyle function. We will get the module. PyTorch will give us the module itself, the input to the module and the output from the module. Here we will make hstyle variable global variable, and we will make gate variable global variable. Why? Because we want to use this hstyle tensor in another function. So when we change the value of this hstyle in this function, so we will change this variable in any other place, even outside this function and inside another function. Now when we make gate variable equal to style, so we will make hstyle equal to the output from this layer, and here we will remove this hook. We will activate this function when we reach this layer. Okay, now we have our hook. And here we will check if we are at the first iteration of this loop. In other words, if we are at time step T capital, the first time step. So at this case, we will prepare the input to our model input equal to image pipe.scheduler.scale model input, and here we will use xt capital style, and we will pass the current time step. Okay, if we are at time step T capital, and here we will use our model, and when we reach this layer, so PyTorch will use this hook to get the output from this layer, and we will change hstyle variable based on the outputs from conf2 layer. Let's say that we aren't at time step T capital. At this case, model input will be equal to image pipe.scheduler.scale model input, and here we will use xtnew. Okay, and we will pass the current time step. And here we will use our U-network to extract the style feature maps, hstyle. We can call this tensor now hnew. Here we will combine the style and the contents, or in other words, we will do noise injection. Firstly, we will make gate equal to none. Okay, here we will use our model. If the current time step is time step T capital, or we are at the first iteration for this for loop, at this case, model input will be equal to image pipes.scheduler.scale model input, and here we will pass xt capital style and the current time step. Otherwise, model input will be equal to image pipe.scheduler.scale model input, and here we will pass xtnew and the current time step. And here we will use our model, our U-network, to find the predicted epsilon given ht. We will use this thing here when we want to compute d capital, which is equal to image pipe.unit, and here we will pass our model input and the current time step. Okay, now we have the predicted epsilon given ht. Now we will make gate equal to combine, and here we will create another hook, which is h hat hook, which is equal to image pipe.unit.downBlocks, and here we will pass the index of this down block and the index of the reasonable block and the layer that we want to take the values from it. dot register forward hook, and here we will pass the function combine style and content function that will take the module, the input, and the output. Now let's see this combine style and content function. This is combine style and content function. It will take module, input, and output. And here we have many variables. We have gamma variable, which is global variable, h style variable, which is a global variable, h content variable, which is a global variable, and gate variable, which is a global variable. Here, when we change a gamma variable from outside this function, so the value of this variable will change inside this function. H style also will change based on what we got previously from this getHStyle function, and h content variable will change also based on what we got from getHContent function. Here we will check if gate equal to combine. We changed the value of this gate to combine, so this is right. At this case, we will remove this hook, so we will type h hat hook dot remove, and here this function, in this function we will not use the output. Okay, we will use h content and h style. So we will type return. This function will change the output from this convolution layer to make it this thing here. So we will type return 1 minus gamma times h style plus gamma times h content. Okay, that's it. Now we will check if we are at the first iteration or if we are at time-step T capital. At this case, we will use our diffusion model. We will type model input equal to image pipe.scheduler.scale model input, and here we will pass xt capital style and the current time step. And we will get a predicted epsilon given h hat, which is equal to image pipe.unit. Here we will pass the input, model input, and the current time step. Here we will find predicted x0, which is equal to xt style minus torch the square root of 1 minus alpha bar t times predicted epsilon given h hat divided by the square root of alpha bar t. And here, as we said previously, we will not use a clamp method because it will affect on static transfer during content injection. Here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times the predicted epsilon given ht. Here we will make xt new equal to xt minus delta t. Okay? This xt new, firstly it is equal to none, but now in the next time step it is equal to xt minus delta t. Now let's say that we are not at time step T capital, so at this case model input will be equal to image pipe.scheduler.scale model input, and here we will pass xt new because now we have xt new and the current time step. And here we will get predicted epsilon given h hat, which is equal to image pipe.unit, and here we will pass model input and the current time step. Here we will compute predicted x0, which is equal to xt new. As you can see here, it is xt new, it is not xt capital style, minus the square root of 1 minus alpha bar t times the predicted epsilon given h hat divided by the square root of alpha bar t. We will not do clamp here also, and here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times predicted x0 plus the square root of alpha bar t minus delta t times the predicted epsilon given ht. Now let's say that the current time step is smaller than or equal to 400. So we will not do content injection. We will not do all these things here. Okay? We will just do regular denoising steps using DDIM sampling algorithm. How can we do that? Here we will prepare the input to our model. Model input will be equal to image pipe.scheduler.scale model input. Here we will pass xt new and the current time step. Here we will get predicted epsilon, which is equal to image pipe.unit. Here we will pass the input and the current time step. Now we will compute predicted x0. Okay, we will type xt new minus the square root of alpha bar t times predicted epsilon divided by the square root of alpha bar t. Predicted x0, it will be equal to predicted x0.clamp, and here we use the clamp method because now we are not do content injection, so we can use this clamp method. Here we will find xt minus delta t, which is equal to the square root of alpha bar t minus delta t times the predicted x0 plus the square root of 1 minus alpha bar t minus delta t times predicted epsilon. And here we will make xt new, it is equal to xt minus delta t. We will do this thing again and again until reaching x0. Okay? Now, as we said previously, we have this content image and this style image. Let's see the result. This is the result that we will get after doing style transfer. It is something, it will have the content, which is this church here, and the style of this style image. Okay? And I used the same diff style block and the same procedure, style transfer procedure, and I tried many different style images, and I got these results. As you can see here, this is the second result, and this one here also. These are good results, okay? And you can try to use another diffusion model like celebrity AHQ model to see the results. Let's use this model, celebrity BAHQ 256 model. First, we should install diffusers package, datasets package, transformers package, FTFY package, pyro package. Okay. Now we will, let's say, take another style image. Let's use this style image, okay? And we will use this model. This model will generate face images. Okay, we will combine content image that we will generate from this model with this style image. Okay, firstly, we will take this style image 7. Now we will download this model. Now we will get xt capital for this style image using our get xt capital using DDIM function. We will pass xt image pipe device to our get xt capital DDIM to get xt capital for this style image. Here we should import torch. Okay. Now we have xt capital for this style image. We will make xt capital style equal to this xt capital because this noise, it is the noise for this style image. Now let's see this noise. Okay, this is the noise for this style image. Now let's try to remove the noise inside this style image by doing reverse diffusion using our diffusion model. And let's see if it will return the same image or not. As you can see here, here is our style image again. Now, what we will do, we will run this, we will create our content image. Okay, let's run this cell. Now we have this image, and as you can see here, this face, it is the content of this image. Now, let's do a style transfer. Here, as we said previously, if we are working with out-of-domain images as style images, you should try many different values for gamma to find which one the best. Let's start with gamma 0.3 and edit steps equal to 400. Let's run this, and here's the result as you can see here, and you can try many different values. Let's try another style image and see the results. We will use this style image, okay? So we will take the path of this image and we will put it here in this place. We will run this cell and we will get XT capital for this style image like this. Now we have XT capital for this style image. Let's do reverse diffusion to make sure that we will get the same style image again from this XT capital. Yes, we have this style image. We got this style image from XT capital. Now we will use this style image to do style transfer with this content image. Okay, let's do it. Let's run this cell. Let's start with 0.5 gamma and see the results. As you can see here, here's the result. It will combine between the person itself, this person here, and the style image, which is this one here. Okay, we can change gamma, we can increase it like this. Thanks for watching.
In this video, we'll discuss about stack data structure. In stack, we can access the elements in LIFO order. The element which is inserted last will be taken out first. And there are two basic operations that we can perform on a stack. They are push operation and pop operation. Push operation is to insert element into the stack and pop operation is to delete element from the stack. So if you consider this stack, you can see push operation is indicating insertion and pop operation is indicating deletion. And a top will be pointing a position where you can perform insertion and deletion. Okay. So this is how you can understand push operation. Initially, this is an empty stack. Now we have pushed an element called 1 into the stack. Later, item 2 is inserted into the stack. Later, item 3 is inserted into the stack. So currently, this is indicating the top of the stack. Okay. Now, if you understand the algorithm for the push operation, you cannot perform any push operation if the stack is already full. Suppose if the stack is not full, in that case, you can perform push operation by incrementing the top value by one position and inserting the data which you want to push into the stack exactly at the top index on the stack data structure. Okay. So let us consider this example. initially the stack is empty. In this scenario, top will be representing -1. So when the top is representing -1, now at this point, if you want to insert a data like 20 into the stack, so first you have to increment the top value by 1. This top must be incremented by 1. So this is top equal to top plus 1, which indicates -1 plus 1 value will be 0. It means the item, that is the data, will be inserted at index 0 and the data is 20. 20 is inserted here. And later you can see, due to this statement, the insertion is happening, stack of top is equal to data. So exactly we have inserted at stack of top, current index of the top is 0, stack of top is equal to data. Data is 20. And this is our stack, isn't it? Now this is pop operation, deleting item from the stack data structure. So currently there are 3 elements inside the stack, and top is indicating this particular element. Okay. Now whenever you want to perform pop operation from this instance, the top element will be taken out. So this will be taken out. And if you look at the algorithm for the pop operation here, so initially whenever you want to perform a pop operation, you can perform only when the stack is non-empty. If the stack is already empty, you cannot perform any pop operation. Okay. So for example, if the stack is already empty like this, we cannot perform any pop operation. Okay. So let us suppose stack is already having some elements at different index like 0, 1. The elements are like 10 and 20, and currently top is indicating this particular index. Okay. Now in order to perform pop operation, that is deletion operation, first we are checking whether the stack is empty or not. Since the stack is not empty, you need to collect the data which you are trying to delete. Okay. So that data can be collected in a variable called data, and this is a stack of top. So what is this stack of top here? In the stack, exactly where top is pointing to, in that position we have an element called 20. So this represents data will be 20, okay, which you are trying to delete is 20, and later you are decrementing the top value by 1. So when the top value becomes 0 by performing a decrement operation from 1 to 0, then finally you are returning the data. The data is 20 here. Okay. Now consider the supporting functions which are used in this push and pop operations while working with stack data structure. They are peak operation. So whenever you want to get the top element of the stack, so top of the stack you can say simply, and this can be obtained with the help of a peak function. And there is another function to check whether the stack is full or not. So this isFull function will check whether the stack is full or not. If the stack is full, it will return true, otherwise it will return false. Similarly, isEmpty function is used to check whether the stack is empty or not. If the stack is already empty, it will return true, otherwise it will return false. Now let us see this peak function, as the peak function is associated with returning the top element of the stack. So if you consider this is our stack data structure. So inside this stack we have different locations like this. Suppose this is 10, this is 20, okay, and this is index 0 and this is index 1. Currently top is representing this index. Now when you want to return the top element from the stack, you can get stack of top. So what is this stack of top actually denoting here? So stack is a data structure and top is indicating currently 1. Stack of 1 will be 20. 20 is returned because this is the top of the stack. Next one is full function. It is used to check whether the stack is full or not. For example, we have defined a maximum size of the stack. Whenever the top reaches the maximum size, it represents the stack is already full. If it is not reaching the maximum size, then the stack is not full. In that case, you can return false. The next one is empty function corresponding algorithm. So according to isEmpty function, it will return true when the stack is already empty, otherwise it will return false. So if you consider this scenario where stack is already empty, in this case top is representing -1. When the top is indicating -1, it will return true, otherwise it will return false. Okay, so this is how you can understand each and every function that is used in implementing stacks. In this video, we'll implement a stack data structure in Python. So first I have created a class called stack. Inside this class, we have defined a constructor in order to initialize the stack. So ARR is basically a list, and here we are taking the size of the list initially and creating the list based on the given size. Later, initializing the capacity of the stack equal to size, and initially top is equal to -1. Whenever the stack is initially empty, top will be representing -1. Now let us quickly implement the operations like push operation, pop operation, peek operation, isEmpty, isFull, such kind of operations which are part of stack data structure. So let's get started. Now let us write a function which is a push function, and in order to push we require an element to be added into the stack. Okay, we are going to push an item or a value inside the stack, right? So in order to check whether this stack is full or not, we will be implementing a separate function called isFull function. So here we can write self.isFull function. So this function needs to be implemented, and this function is going to return true if the stack is already full, otherwise it will return false. So the moment it returns true, then we can print immediately saying the stack overflow. Okay, and then you can exit. You can also write a print statement saying that we are inserting an element into the stack. Okay, inserting element into stack, and later to insert, first we have to update the top value. Yes or no? Initially top is already representing -1. You need to increment this top to the next position and place the value inside that particular index. So to increment this, we can do self.top needs to be updated here. Self.top is equal to self.top plus 1, and then self.array of, for this top position, okay, which is now the corresponding index where we are performing this insertion operation into. So self.top is equal to value. So we are placing the value inside the stack exactly where self.top is representing. Okay. Now you can observe this is push operation. Similarly, we can also implement the pop operation as we have already discussed in the algorithm. So this pop operation doesn't need any variable because we are trying to remove the value. Okay, we are not going to take any value to place inside the stack because this is a pop operation. We are deleting the item from the stack. Okay, so again here you need to check whether this stack is empty or not. In order to check stack is empty or not, so we are relying on a function called isEmpty function that needs to be implemented. If suppose the stack is already empty, then you can display the print statement saying that stack is underflow or stack is empty. Okay, and later you can call this exit system call because the stack is already empty and you can't perform any deletion operation from the stack. And later you can also display what element you are trying to delete from the stack. Okay, so deleting element is, so I'll use another function which is peek function that will return the top of the stack because the deletion starts from the top of the stack element, right? So you can display the same thing here. And later, in order to perform this deletion operation, first you have to modify this top. Okay, after taking the value, okay, let us suppose I'm taking value is equal to self dot inside this array where exactly top is representing, so self dot top. Now let us decrement this self dot top value. Self dot top is equal to self dot top minus 1. Okay, and finally you just need to return this value. Okay, because this is the element that you are actually deleting, isn't it? Okay, now after this push operation and pop operation, we need to implement peek operation that actually returns the top element of the stack. So let us define this peek operation. And first, you cannot return the top of the stack if the stack is already empty. So for this purpose, we can write self dot is empty to check whether the stack is empty or not. So we'll be implementing this isEmpty function. If the stack is already empty, you're not going to get the peek element of the stack. If it is non-empty, in that case you can return simply the array corresponding top element, which is self dot top. Okay, just like this. Now let us define another function which will actually return the size of the stack. So for this purpose, we are defining a function called size function which will return the size of the stack. So you can write return self dot top plus 1. This is representing the size of the stack. Okay, and then now let us implement a function to check whether the stack is empty or not. So that is isEmpty function, which we have been using inside the pop function, also inside the peek function. Let us implement this function. Okay, isEmpty. So in this isEmpty function, it is just checking whether the stack is empty or not. First, let us return the size of the stack and check whether the value is equal to 0 or not. If the returned value of the size of the stack is 0, then you can say stack is already empty. Otherwise, you can say stack is non-empty. So for this purpose, I'll write return self dot size double equal to 0. So we are checking size of the stack is 0 or not. And after this, let us define another function, which is full function, to check whether the stack is full or not. So whenever the size of the stack is meeting the capacity of the stack, we can say the stack is full. We have already defined the capacity of this stack is equal to size, right? So that's why here I'll simply return self dot capacity, okay, is meeting the self dot size. Self dot size of the stack. If this is met, we can say stack is completely full. Okay. If this condition is false, then we can say stack is not full. Okay. So let us implement here the stack. So the idea is basically to create an object for this stack class and pass the size of the stack here, isn't it? So let's do here stack is equal to, so this is the name of the class, right? So I'll take the name of the class exactly, and here I'll pass the size of the stack. Okay, for example 3 being the size of the stack, so you can fit only 3 elements inside the stack. Now let us perform the operations like push operation and pop operation. So first I'm pushing a value called 1 into the stack, and also I'm pushing value called 2 into the stack now. So let us perform another push operation, stack dot push of 3. So after this, let us perform pop operation onto the stack. Okay. So similarly, stack dot pop operation and stack dot pop operation. So we have done totally 3 push operations and 2 pop operations. Now, if you want to find the top element of the stack, let us obtain the top element of the stack by printing like this. So I'm printing top element of stack is, so you can obtain the top element of the stack with the help of peek function inside stack. So stack dot peek is the function which is used to obtain the top of the stack. Okay, and also if you want, you can obtain the size of the stack here. So we can write size of stack is, size of stack is, that is stack dot size. Okay, now let us run this code and see the result. So you can observe initially we are inserting an element into the stack because this is the push operation we have performed, and also later another insertion has happened and then another insertion. So the elements are inserted in the order 1, 2, 3, 3 being the top of the stack. When you perform a pop operation, the deleted element will be 3, and later another element is getting deleted, which is 2. Okay, and finally now when you want to display the top element of the stack, it will display top element of the stack is 1, because the elements 1, 2, 3 are inserted into the stack. Already we have performed 2 pop operations, so 3 and 2 are deleted from the stack. Now there is only one element inside the stack, which is 1. That's why when you are calling stack.peek, it is obtaining element 1, and also the currently the size of the stack is 1. There is only one element inside the stack. Okay, so this is how we need to implement stack using Python.
Hi, in this lecture we will talk about optical flow, which is one of the most important techniques that we should know before moving to learn how to convert our video into animation. Firstly, what is optical flow? Optical flow shows the movements of the pixels between two frames. For example, let's say that we have these two frames. This is the first one and the second one. The optical flow for these two frames is this one. This optical flow will tell us which pixel in the first frame moved in the next frame, and the direction of movement and the amount of movement. So as you can see here, all the pixels that represent this card, they moved in a specific direction in the next frame. So each one of them has its own vector that represents the direction of movement and the amount of movement. We will call all these vectors that represent the movement of each pixel by optical flow. In 2015, they started using deep learning to solve optical flow tasks. They tried to train a U network to find the optical flow from two images or two frames. The structure of the U network that they used, it is this one here. We will pass the first frame of our video through this branch here. There are many convolutional layers in this branch. We will pass this image through them, through all these layers, all these convolution layers. And we will do the same thing for the next frame of our video. We will pass it through this branch, all these convolution layers. And here we will do special thing. We will find the correlation between these feature maps. So how can we do that? To understand the idea behind this correlation layer, we should understand this formula here. Firstly, here we want to find the correlation between two patches. One of these patches is available in F1 feature map, and the other patch is available in F2 feature map. The center of the first patch, it is x1, which in this case it is this location here. The index of this location is 1, 1, and the center of the other patch is x2, which is this location here. The index of this location, it is 2, 3. Because as you know, in Python we start with index 0. So the row of this center, it is equal to 2, and the column of this center, it is equal to 3. Now what we will do actually, we will do dot product. This symbol here for dot products. Okay. This formula here will multiply this patch with this patch, element wise, and after that it will add the results to get just one single value, which is something similar to the convolution operation that we talked about previously. Here, this patch in F1 feature map, it is like a kernel that we will multiply with this patch in F2 feature map. So this operation is something similar to convolution operation. Now after applying this formula, we will get just one single value. This value will represent the relationship between this batch and this batch. So now we are doing matching a process, which is something very important in optical flow. When the correlation between these two patches is very high, it means these patches, they are very similar to each other. And by doing this, we will be able to know that x1 batch, it is just moved and created x2 batch in feature map 2. Our neural network will try to learn these correlations. And by using these correlations, we will be able to match between batches. Here we took just one single example about how to compute the correlation. But actually, we will find the correlation of this batch with all possible batches in this feature map too. And we will go to another batch here and we will find the correlation between this batch and all possible batches in F2. And when we want to find the correlation between, for example, the first batch in F1 feature map and all batches in F2 feature map, we will get new feature map. And when we want to find the correlation between the second batch in F1 feature map and all batches in F2 feature map, we will get another feature map in the output. Okay, so we will get very large number of feature maps. So now the depth dimension of the output will be large, which is equal to the possible patches inside F1 feature map or possible patches inside F2 feature map. As you can see here, these two feature maps, F1 and F2, they have the same size. So now we have very large number of feature maps in the output. Our output is very large, and that's not good. We did a lot of computations to get this output. This thing will take time, and if our output is very large, so it will take a lot of our memory also. All these things, they are not good. So what we will do here, we will reduce the spatial dimensions of the output. How can we do that? The idea is super easy. Here we will not compare this batch with all possible patches in F2, but with the nearest batches in F2. So here what we will do, we will restrict the search space. For example, here we have our batch, which is x1, in this case, this one here. Here we will not find the correlation between x1 and all x2 patches, but we will find the correlation between x1 with the nearest x2 patches to our x1 batch. In other words, here is our x1 batch, and here is the center of this batch. Let's say that the displacement, the maximum displacement, equal to 1. By doing this, we will restrict the search space. Now we will find the correlation between this x1 with this batch here that has the same center of x1 batch. Okay? And this batch here, which moved just one step from the center of x1. So now we have two batches, and this batch here also we have 3 batches, and this batch here, so we have 4 batches. So in other words, we will just find the correlation between this batch with the patches that are near to the center of our x1 patch, but in F2 feature map. So here we didn't take all patches in F2 feature map, but just a few of them. So here we reduced the computations, because here we will not use this formula a lot. And we will take another patch in F1 feature map, and we will find the nearest patches in F2 feature map for this patch in F1 feature map, and we will do computations to find the correlation, and we will do this process again and again until reaching the last patch in F1 feature map. By doing this, we will reduce the size of the output from our correlation layer, and we will speed up our network because we will reduce the computations. But the problem here, you will not be able to match any patch in F1 feature map with very far patch in F2 feature map. So for example, if you have very fast object in your video, if you use this correlation layer, you will not be able to match the batches that are related with this object in the first frame and the next frame. So you will not be able to get the correct optical flow for this object. And we will pass the output from this correlation layer through many layers, and we will pass the output through this refinement part of our network. This refinement part will increase the spatial dimensions of our optical flow by using up convolution layers. And here's the output optical flow feature map. You can see the resolution of this optical flow. It is not similar to the resolution of the input frames. And they found that adding another convolution layers will not be helpful. It will increase the spatial dimensions of the optical flow, but it will be something similar to any other simple resizing methods. So for this reason, they used the variational refinement to make the resolution of the optical flow similar to the resolution of the input frames. In the next lecture, we will talk about GM flow method to find optical flow. Thanks for watching.
Yes, sir. So in this lecture, we'll be discussing about how do we implement stacks using list. Okay. So let us consider a sample list. I'll call this as a stack. Now we can insert elements into the stack using a function, that is append function. Let's make use of this append function. Okay. So start appending items into this stack. Stack dot append of. Let us suppose I am trying to append element A. Okay. Similarly, let us append B now, and similarly let us append C also. Okay. Now let me print the contents of the stack. Okay. So I can say this is my initial stack. Okay. And let me display the content of the initial stack. Okay, let's run this code and see. See here, this is the initial stack content ABC. Stack contains ABC. Now, let us remove some elements from the stack. That is popping the elements from the stack. So we can make use of pop method. Okay. So let's print here saying that elements popped from stack. Okay. Now let's print here stack dot pop. Now we can perform one more pop operation here. Okay. Since there are three elements, we can do one more pop operation. Okay. Now we can display the elements of the stack. So just like here, how I have displayed. So, but now this is going to be after popping elements. After popping elements. So I'm going to display the stack content here. So let's run this code here. So the initial elements of the stack is A, B, C, and you started popping items from the stack. So top of the stack will be C. So first C will be removed, and after that B will be removed, and then A will be removed. And finally, when you want to display the contents of the stack, stack will be empty like this, isn't it? So this is how you can implement stack using list. So next one is we can also work with stack data structure with the help of DQ class, which you can actually import from the collections. Okay, so it means this DQ class is available in the collections module. Okay, and generally this DQ is preferred when compared to lists because they are quick. Okay, quick in the sense the operations such as append operation, pop operation. So these things are faster in DQ when compared to list operations, and the time complexity will be less in this DQ. Okay, so let's start implementing with the help of DQ. Okay, so I can call this as implementation using collections. In the collections, I'm going to basically make use of DQ. Okay, so you have to first import this DQ, right? So you can write from collections, you can import DQ. Okay, now I'll consider stack is equal to, using this DQ class, I'm creating a stack. Now you can start appending items into the stack. So just like here, also I'm appending items into the stack one by one. So starting from A, similarly we'll append other elements also like B and C. Okay, so this is element B and this is element C. Now you can print the contents of the stack. So this is going to be my initial stack, so its corresponding content you can print here. Okay, let's run up to here and you will see using DQ class we are able to create a stack containing elements like A, B, C. Okay, now let us start popping the elements from the stack. So that is print. So I'll just display here elements which are popped from stack. I'm going to display now. Okay, so again the method is pop method, that is a stack dot pop. Clear? So you can see we're using stack dot pop method. Okay, now after popping elements from the stack, we can display the content of the stack, isn't it? So that is stack after elements are popped. Okay, so I'll try to display the content of the stack. So again it's going to be printing the stack content. So let's run this code and see the result. So you can observe here initial stack content is A, B, C, which I have created using DQ class from the collections module. And then we are able to display the elements of the stack, okay, which are popped. So you can see first element that is popped here is element C. Okay, and then the second element will be element B and the third element will be element A. Okay, so after popping all these elements from the stack, you can see stack is completely empty. So stack after elements are popped, this is going to be completely an empty stack, isn't it? Like this. In Python, we can also use Q module in order to create a stack data structure. So because in queue module we also have an option of LIFO queue, which is considered as a stack data structure because LIFO represents last inserted first out. Okay. So to work with this queue, we have two primary functions. One is put function, the other one is get function. Put function is used to insert an item into the queue, whereas get function is used to obtain the data from this queue. And also it will operate with different functions in this module. Let us suppose if you are using max size, this is going to return the number of items in the queue. Okay. So that is, you can have maximum of these many items allowed to be placed inside the queue. Okay. And if you consider empty function, this is going to return true if the queue is already empty. Otherwise, it will return false. And next one is full function. This will return true if there are maximum size items in the queue. That is, if the queue is already full, in that case it is going to return true, otherwise it will return false. And next one is get. So this get method is used to remove and return any item from the queue. If the queue is already empty, it will wait until an item is available. And next, coming to put of item, this put function is going to place an item inside the queue. If the queue is already full, then it will wait until a free slot is available before adding any item. Okay. And finally, queue size. This will return the number of items inside the queue. Okay. So these are the primary functions that we work with while operating with queue module. Now let us quickly implement this. Okay. So first you just need to use queue module, and from this queue module you just need to import LIFO queue. So this is from queue import LIFO queue. Okay. So now let us create a stack data structure. Stack is equal to, we are working with LIFO queue, and here you can specify the maximum size of the LIFO queue. Let us suppose maximum size of the LIFO queue is 3. Okay. Now if you want to return how many elements you can basically store, okay, you can display max size. And if you want to show the number of elements that are already inside the stack, so you can write using print statement stack dot queue size. Okay. So this function will return how many elements are already there inside the queue. Okay. Now in order to place or push element into the stack, we make use of put function here. So let's use the same put of item, whatever item that you are placing inside this stack. So I'm placing A, and after that another item B, and then stack dot put of another item C. Okay. Now let us print stack full. Okay. So this is full stack dot full. Okay. And similarly, let us print the size of this particular stack, which is nothing but LIFO queue. That's why you can obtain the size with the help of queue size. Okay. Now you can pop the elements from the stack in the LIFO order. So for this purpose, I'll start writing stack.get function. Before that, I'll just display elements popped from this stack are in this order. Okay, so let's pop the elements with the help of get function. So this is a stack dot get function I'm using here. Okay, similarly print of stack dot another get function. Okay, like this. Now let us run this code up to here, and you can see initially after creating an empty stack with maximum size equal to 3, then you are checking or obtaining the stack corresponding size. How many elements are there? 0 elements are there. And later we are already placing items into the stack A, B, C. Then we are checking whether the stack is full or not. Stack dot full. This is returning true. Okay. Then you are displaying stack dot queue size. How many elements are there inside the stack? Totally 3 elements. So the size is going to be 3. And later when you are popping the items from the stack, the order is the top of the stack is C. That's why we are getting the first element as C. And the next element will be B. So the next element displayed is B. Similarly, when you are trying to perform the same operation again, okay, and later you are checking whether the entire stack is empty or not, okay, you can call the respective function, which is stack dot empty. Okay, so let's run this code and see the result. You can see we have inserted a total of 3 elements into the stack. So they are inserted in the order of ABC, but they are deleted in the order of CBA. That is what LIFO queue or stack represent exactly. And finally we are checking whether the stack is empty or not. So clearly the stack is empty, hence it is returning true. Okay, empty is true. So this is how you need to implement stack data structure with the help of LIFO queue in Python. In this video, we'll implement stack using linked lists in Python. So first, linked lists contain nodes, right? So for this purpose, we are writing a node class, and inside it, this is a constructor which will define the contents of the node. So node contains a data part and also a next pointer, which is initially pointing to none. Okay. And later we have defined a stack class containing a constructor. So where we have defined self.head is equal to none. So that is head of the linked list is pointing to none initially. Now let us implement a function which will check whether the stack is empty or not. So that is empty function. So in order to check whether the stack is empty or not, first we have to see what is head, okay, of the linked list. If the head of the linked list is pointing to none, in such case we can say, or we can simply return true. Okay, if self.head is pointing to none, in that case we can return true. If this condition is false, it can go to the else block and return false. Okay, so this is how we can define isEmpty function. Now after this isEmpty function, let us define a push function which will add the node to the existing linked list, and this insertion must be performed at the front of the linked list. Okay, or you can say adding a node at the beginning of the linked list. Because this is a stack data structure, the elements must be added at the front of the linked list so that you can access them in LIFO order, last inserted first out order. Okay, so let me define the subsequent function, which is push function. What is the data with which you are creating a node so that you can add this node at the front of the linked list? If suppose self.head is pointing to none, it means the linked list is already empty. So in that case, you just need to create a new node and add it to the head of the linked list. Okay, so this is self.head is equal to create a new node with the specified data. Okay, just like this. Suppose if the head of the linked list is not none, in that case it can move to the else block, where you will create a new node. So this is can be done like new node is equal to node of data. Okay, so we are creating a new node with the specified data inside it. Now we need to add this particular node to the front of the linked list. So what we can do is new node corresponding next should be pointing to the head of the linked list, and later bring head near new node. So this is self.head. Now bring this head to the new node. Okay, so this is how you can actually perform insertion operation into the linked list. Subsequently it will reflect in the form of a stack data structure, where this insertion or push operation is performed at the starting of the linked list. Okay, now let us define the subsequent function, which is pop operation. So in order to perform this pop operation, again this deletion operation must be performed at the start of the linked list, isn't it? So if suppose the linked list is already empty, in that case you cannot perform deletion operation, right? If this condition is false, you can move to the else block and pop the node. So I call it as pop node is equal to, I'll represent the pop node to point where exactly the head of the linked list is pointing, and move this head of the linked list slightly to the next node. Because if you have 4 nodes in the linked list, currently the head of the linked list will be pointing to the first node. Now slightly move this head to the second node so that you can easily perform deletion of the first node, right? So self dot head is equal to self dot head dot next. Okay, now indicate this pop node corresponding next to point to none, and finally return this particular pop node corresponding data. So for this you can write return statement, return pop node dot data. Okay, so this is how you can perform the pop operation. Now next one is peek operation. So peek operation is basically used to return the top of the linked list, and here the top node is exactly, okay, the first node in the linked list where head is actually pointing to. Okay, so let us define a function which is peek function, and again to perform or obtain the top of the linked list or top of the stack. Okay, so in this case we have to check whether the linked list is empty or not. If self dot is empty function, is returning true, in that case you can say linked list is already empty, so you can return directly none. Suppose if this condition is evaluated to false, it can move to the else block and you can return self dot head dot data. Okay, you can return self dot head dot data because this is head pointing to the very first node, which is nothing but the top of the stack. Okay, its corresponding data must be returned because the idea of peek function is to extract or obtain the top element of the stack. Okay, now next one is display operation. Whenever you want to perform display operation on the stack, since it is a linked list representation, you just need to start from the top of the stack or head of the linked list and iterate and obtain node by node corresponding data. Okay, so let us start by considering a node, iterative node, which is pointing exactly where head is pointing to. Now let us check whether this is empty or not. If this is empty, you can print stack underflow. If suppose this condition is false, you can move to the else block, and inside this else block we can iterate and display element by element. So let us write a while loop and check whether you are reaching the last none position or not. If it is not equal to none, in that case you are going to display the node corresponding data, that is iter node corresponding data must be displayed. Okay, and after that create space while displaying. Now move this iter node to the next position. So this must be iter node is equal to iter node dot next. Okay, and the moment you can see here, if suppose iter node is not none, in that case I'm going to print arrow so that you can exactly represent or display in the form of a linked list representation. So I'll display here arrow representation. Okay, and also some space. Okay, and finally return the control. Okay, so this is how you can perform display operation, okay, for the linked list representation of stack data structure. And these are all different functions. Is empty function, there is no is full function in linked list representation, because in linked list representation this is a dynamic implementation, okay, where you can create more and more nodes and basically enlarge this entire linked list. So there is no upper limit on how many nodes that you are going to create. But the moment entire linked list becomes empty, in that case you just need to check whether the linked list is currently empty or not. Okay, so you have is empty function but not is full function here. Now let me create an object for the class called stack. So let us create an object here. So I'll name of the object is my stack. Okay, my stack is the name of the object for the class called stack. Okay, now let us perform push operation here. So push operation of the data 11 for example, and similarly I'll push some more elements like for example 22, and the next element is 33, next element is 44, next element is 55, like this. I have pushed or inserted 5 elements into this stack. Now when I want to display this, you can call my stack dot display operation. Okay. And also whenever you want to find the top element of the stack, you can still call this peek function. Okay. So I'll call the same function inside the print statement saying that top element is my stack dot peek. Okay, this is the top element of the stack. Now when you want to delete the top elements of the stack, you can perform this pop operation. So similar to push operation, you can call pop operation here, whereas push operation to insert and pop operation to delete. Let us suppose I want to perform total of 3 pop operations. So in that case you can use like this. And after performing this pop operations, now let us see what is the content of this stack by calling display operation or display function. Okay. And again, let us print the top element of the stack after performing this display operation. Okay. So let us run this program and see the result. Okay. So here we are calling an empty function. Okay. Dot is empty function. Okay. With capital letter. We have actually implemented with a small letter is empty function here. Okay. Now you can see the result. So initially this is the entire stack corresponding linked list representation. 55 being the top of the stack, 55, 44, 33, 22, 11. Because the elements were pushed in this order 11, 22, 33, 44, 55. Since the stack operates in last in first out order, the element which is pushed last is now the top of the stack. Okay. So when I print top element of the stack, it is displaying 55. And later we are performing 3 pop operations, which means the top 3 elements of the stack will be removed. Then the remaining elements are 22 and 11. So later we are displaying the top element of the stack, which is 22. Top element is 22, isn't it? Like this. Now let us discuss the very first application of the stack data structure, which is checking whether there exists a matching or balanced parenthesis in the given expression or not. So this can be done with the help of a stack data structure, and you will come across different types of parentheses like this. There are 3 different types of parentheses. And now how can you solve this balanced parenthesis problem? Is first, whenever you encounter a left parenthesis, perform push operation into the stack, and whenever its corresponding matching right parenthesis appears, pop it from the stack. Okay. So let us solve an example to understand the same here. So I'll consider the given expression like this. A plus B, like this. Now for this expression, it contains balanced parentheses. So whenever an expression contains balanced parentheses, after performing this push and pop operations from the stack will become an empty. Okay. So initially consider an empty stack data structure. This is representing a stack which is initially empty. Now first it encounters left flower bracket. So whenever there is a left parenthesis, perform push operation into the stack. So it will perform push operation into the stack. And later the next one is left open parenthesis. This should also be pushed inside the stack data structure. And later A. So there is no operation for this. And again for plus no operation. For B no operation. That is, whenever you encounter an expression containing operands and operators, then perform no operation. But when you encounter left parenthesis, perform push operation. And if you encounter its corresponding right parenthesis, okay, so this is the corresponding right parenthesis, and currently this is top of the stack. Since this is matching right parenthesis for this one, perform pop operation. Okay. So once it is popped out, the resulting stack will look like this. This is the resulting stack, contains only left flower bracket, and the top of the stack will be indicating this. Now the right flower bracket is encountered, and this is a matching right bracket for the left flower bracket on the stack. So perform pop operation from the stack. Finally the stack will become empty. This is how stack becomes empty. So overall you can say this particular expression is properly balanced or matching parenthesis. Okay. Now let's see algorithm to understand this. So we are traversing character by character from the entire string. So where I'll get the next token into A, character A. If this is matching with either of these left parentheses, okay. So there are three types of parentheses which I have already discussed. If it is matching with any of these left parentheses, immediately perform push operation into the stack. So push into stack. Now, if suppose this is a right parenthesis, then you just need to first check whether the stack is empty or not. If the stack is empty, immediately display not well formed, or you can display unbalanced parenthesis and exit. If suppose the stack is currently not empty, in that case perform pop operation from the stack and place it into X. Now you need to check whether A and X are proper match or not. If A and X are not matching, again you have to print not well formed and exit from this particular program. Okay. Suppose after traversing the entire string, if the stack is not empty, in that case you can display not well formed. Okay. So after traversing the entire string and finally stack also becomes empty, in that case you just need to print well formed string or expression. Okay. So this is how you can use stack data structure in order to check whether the given parenthesis is balanced or not. Yes, sir. Consider this problem statement. So we need to check whether the given expression has got balanced parenthesis or not. Okay. So you can observe here clearly, this is the expression and it has got completely balanced parenthesis. That is, for every left parenthesis, its corresponding right parenthesis is there. Yes or no? You can see here. So it is completely balanced. But if you look at this expression, it is not balanced because between the left square bracket and right square bracket there is an open parenthesis. So this is clearly not balanced. Now you're asked to implement like this. It means an input is given. You need to come up with the solution saying that whether this is properly balanced or not balanced. Okay, and the input is the expression containing different parentheses. Okay, so let's implement this by keeping in mind. Okay, So first I'll go for a sample expression. Okay, so let us consider here expr is my expression. Okay, I'll consider this as and within this I'll take another parenthesis, and now I'll take square brackets here. So this is the expression. Now I'll implement a function in order to check whether this expression is balanced or not. Okay, so I'll call a function first of all and then I'll implement later. So the function is balanced. Is balanced is the name of the function, and for this function we are passing expression as the parameter. Okay, so if suppose this is returning true, in that case the associated statement should be executed. The associated statement is it has to print balanced. Okay, suppose if this condition is evaluated to false, then it has to go to the else block, and inside the else block it has to print saying that not balanced. Okay, so the idea is to now to implement this function. So what is the name of the function that we are writing? Is balanced is the name of the function. Okay, where we are passing this expression as the parameter. Okay, now how we can solve the same problem using stack? So the idea is simple. The idea is for every left parenthesis, I'm going to push that left parenthesis into the stack data structure. Whenever we encounter its corresponding right parenthesis, we need to pop the item from the stack. Okay, so it must be the corresponding parenthesis. It means for every left parenthesis you are going to perform push operation. Okay, and its corresponding right parenthesis is encountered. In that case you have to perform pop operation from the stack data structure. So for this I am going to take an empty stack, that is using list data structure in Python. Now I'll iterate through the entire expression. So expr is denoting the expression, right? So I'm iterating through entire expression and checking whether this character is inside any of these left parentheses. So it's basically, you can see different left parentheses. This is one type and this is another type and this is another type. If we encounter any of these left parentheses, immediately perform push operation into the stack. Okay, so I'll perform stack dot append of this character. This character must be appended into the stack. Suppose if this condition is false, then it must be going to the else block. Okay, so in the else block you need to check whether this current character is a right parenthesis, okay, or whether stack is empty or not, like this. Okay, so let's check here whether the stack is empty or not. Suppose if the stack is empty, okay, in that case we can directly return false. Okay, so if this is not the case, then I will collect the character by performing pop operation from the stack. So I'll take that into current character. So the current character is obtained by performing pop operation from the stack. So once you obtain the character from the stack, now you have to check whether this current character is equal to the left parenthesis or not. Okay, so open brace. So if the current character is left parenthesis and the character is its corresponding right parenthesis, okay, then it is fine. If the current character is this open parenthesis left parenthesis, but its corresponding character is not there. It means I'll check like this. If the character is not equal to this right parenthesis, okay, in that case immediately we have to return false. Yes or no? So what it means is you are able to find the first character as the left parenthesis, okay, which you have already pushed inside the stack or appended inside the stack, and then you are popping that same character from the stack, and now you are going to check whether the current character is equal to its corresponding right parenthesis or not. If it is equal to the corresponding right parenthesis, it is fine, but if it is not equal to the corresponding right parenthesis, in that case you have to return false. Okay, so similarly you will come up with two other conditions, the same code. Okay, you can make use of the same code here. So but parenthesis is for square brackets, okay, left square bracket, and if this current character is not equal to the right square bracket, in that case also you need to return false. Okay, and similarly if current character is equal to, okay, left flower brace, if character is not equal to right flower brace, in that case you have to return false. Okay, so these are the conditions that we check inside this else block. Okay, and if suppose the stack is empty, okay, if the stack is empty after performing these operations, okay, so it means for every left parenthesis you are able to find its corresponding right parenthesis. That is how the stack becomes empty. Okay, so let us suppose you can see here directly. Okay, so I'm writing exactly in this line. Okay, so look at the indentation here. Okay, so here the indentation is for loop. Okay, like so I'm writing here. Okay, if stack, okay, if there are some elements inside the stack, it means stack is not empty in this case, so directly you can return false. Okay, so otherwise you can return true here. Okay, so this is the entire implementation. Now let us run this code and see the result. Okay, you're able to see balanced, because for this expression you will see all the parentheses are properly balanced. Suppose if I remove the right parenthesis here, then it is not balanced, right? So let's run this code and see whether it is not balanced or not. Yes, it is not balanced. Okay, so there are two possibilities. One is balanced, the other one is not balanced, and we have covered both the cases here. Okay, in this video we'll discuss about queue data structure. The order in which the elements are placed and accessed are in FIFO order in case of queue data structure. That is first in, first out. Whatever element that is placed first will be taken out first. And to access this queue data structure, we consider front end and rear end. So rear end is used to perform insertion. Insertion operation is performed at rear end, whereas deletion operation is carried out at front end. Okay, so you can observe this example of a queue data structure. If you want to insert another item into this particular queue, you can insert with the help of rear. You can increment rear and insert an element here. For example, if you want to delete the element, it should be done from the front end. That is, front is currently pointing to this particular location. So you can remove this element and move to the next location. Okay. And this implementation of queue can be done in two ways. One is arrays or list representation. The other one is linked list implementation of queue data structure. So if you consider a queue using arrays, then you can actually just declare an integer queue. Okay, if you are considering programming language like C, you can declare like this: int a of 7. This will become an array which can hold up to 7 elements starting from index 0 to index 6. Suppose if you are using language like Python, you can simply write a is equal to some list of elements like 1 comma 11 15 3 6 10. Okay, and then you can assign front equal to 0. Front will be pointing to the first location, where the rear is pointing to the last location where the element is placed. Now if you want to insert one more element, you can just increment the rear and place the element here. Suppose if you want to delete, you just need to remove this element by moving front to the next position. So let us consider inserting a new element into queue data structure. So I'll take a sample scenario. For example, the entire array contains a total of 5 locations. Okay, and consider the elements are placed like this: 10, 20, 30. And here front will be pointing to this one, whereas rear will be pointing to this one. Now what is the max value? Max will be denoting the number of elements which can be placed inside this queue, maximum number of elements. So the index are 0 1 2 3 4. It means maximum you can keep 5 elements inside this queue. Okay, so the moment rear reaches max minus 1, it represents all the elements are filled, because rear will be incremented only for insertion. If you are inserting an element, you will increment rear and place the item. So the moment rear reaches this particular position, you can say already the entire queue is full. Okay, in that case you can display overflow error or simply displaying queue is full. Okay, suppose initially, what are the conditions of front and what are the conditions of rear? Okay, if you observe, initial values of front and rear will be -1. So the moment you see front is -1 and also rear is -1, it indicates the entire queue is empty. So when the queue is empty, if you want to place front and rear to point to some location inside the queue, that is very starting location, you have to set front equal to 0 and rear equal to 0. Okay, suppose if this condition is false, it represents currently queue is not empty, then you can just increment rear by one position. Let us suppose I want to insert a new element called 40. Okay, suppose the item I am trying to insert is 40. To place this item here, so how can we place this item 40 inside this particular queue is simply increment rear by one position. So when you increment rear by one position, from now onwards rear will be pointing to this position, rear equal to rear plus 1. And later you have to place item inside this rear corresponding location. So that is queue of rear is equal to item. You have to place 40 here. Okay. So this is how the insertion operation works inside the queue. Now let us consider deleting an element from the queue. So let us suppose if the entire queue is empty, for example, when the entire queue is empty, you can consider front equal to -1 and rear equal to -1, and you can look at these indices 0, 1, 2, 3, 4. Okay. So initially, when the front is -1, it actually represents entire queue is empty. So you can't perform any deletion operation here, where you can simply display underflow error or queue is empty. Okay. So there is another case where front can actually greater than rear. So this happens when you perform some insertions and also deletions. Okay, let us suppose you have inserted two elements, 10 and 20. Okay, then in this case front will be pointing to this location and rear will be pointing to this location. So now again you have performed two deletion operations. When you perform two deletion operations, then in that case front will be moved by one position, and then again for the second deletion another position. In that case front will be greater than rear. So front will be moving to this position, which means front is crossing the rear. This happens when you perform equal number of insertion operations followed by equal number of deletion operations. At that case, you can see front is greater than rear. So overall, you can say this is a case where front is greater than rear appears when Q becomes empty. So we can write two conditions here. One is front greater than rear to indicate Q is empty, or the other one is initial condition where Q is originally empty and front is representing -1 in that case. Okay. Suppose if this is the current scenario and now you want to perform a deletion operation. Since there are elements inside the queue, you can perform this deletion operation successfully. You can just write item is equal to whatever item that you are trying to delete from the queue. So this is simply queue. Okay, and from this queue you need to take item which is located at the front index. So this is queue of front, which means item 10. Okay, after removing this element, front should be incremented by one position. Just set front to point to the next position. Front equal to front plus 1. So from now onwards, front will be pointing to this location after removal. Okay. So this is how it will work. Now let's go through implementation of queues using linked list. So in case of linked list implementation, very first node is pointed by front pointer and the last node is pointed by rear pointer. And each of this node contains two parts. One is a data part, the other one is next pointer pointing to the next node. Okay. So let's see here how this insertion is going to happen in this linked queue representation. Suppose this is the current scenario. The linked list contains a total of 5 elements. They are 4, 23, 6, 13, 65. And this is representing null. Okay. Now when you want to insert a new node, how you can take is, for example, I'll take a new node in temp, and this temp is pointing to the newly created node and its corresponding data is 40, and this can be null. Okay. Now you have to consider rear pointer, and this rear is actually pointing to the last node. Now rear corresponding next should be given to this temp and move this rear to this position. Okay, just simply rear equal to temp. Okay, so in this case you can perform insertion operation easily because the last node is pointed by the rear pointer and you just need to insert an element after that node. Okay, so simply writing rear next is equal to temp will be sufficient, and later just move this rear to the temp. Okay, so let us consider the insertion operation into this linked queue representation. So first you have to create a new node and place the value that you are trying to insert. So I'll take a sample linked list and consider there are 3 nodes inside this linked list. So this is 10 and the next node contains data as 20 and the next node contains data as 30. Okay, and you can observe here this is a front pointer and this is pointing to the first node, and here this is the rear pointer pointing to the last node, and this is pointing to null. Okay, now we want to insert a new node into this linked queue representation. So for that purpose you have to take a new node. Okay, so whatever value that you want to insert, for example value you want to insert is 40, then take a new node. Okay, and this new node should be pointing to newly created node. Okay, which contains two parts. One is data or information part and the other one is next part. Now first you have to assign new node dot info equal to val. So you have to assign this value of 40 here, and later if front is null, currently front is not pointing to null or none, so in that case you can move to the else block and move this rear next is equal to new node. So assign this rear corresponding next to the new node, and new node dot next is equal to none or null. Okay, so new node next should be pointing to null, and then rear is equal to new node. So make this rear from now onwards to point to the new node. So you can see rear should be pointing to the new node. From now onwards this is not pointing to this node. Okay, so this is how the insertion is going to happen when there are already some nodes inside the queue. And the first case, this if condition is valid if the entire linked list or queue is empty basically. Okay, now consider deletion of an element from the linked queue representation, and the deletion in queue data structure is carried out at the front end. Okay, front is already pointing to the first element of the queue or linked list, and here if you are performing a deletion operation you just need to move this front to the next position. Okay, and free this particular node. So let's see the corresponding algorithm for performing deletion operation here. First you have to check whether the queue is empty or not. For example, if the queue is already empty, then front will be pointing to null. So the case where queue is null or queue is empty is represented with the help of front pointing to null, and also the rear is pointing to null. In this case you can say the entire queue is empty. So in that case when there are no elements inside the queue you cannot perform any deletion operation. It should lead to queue underflow. Okay, so what happens when there are elements inside the queue? We'll consider that particular case where this front is pointing to the very first element of the queue, which is 10, and then next element is 20, and the next element is 30, and this is pointing to null. And consider rear is pointing to the last element. Okay, now we have to set temp equal to front in order to remove the very first element of the queue. First set temp is equal to front. So consider temp and take this temp to point to the front. Now move this front to the next position. So this can be done by writing front equal to front dot next. So front must be pointing to the next node. Now we need to free temp. Whatever node that is pointed by temp should be deallocated or removed. Okay, and finally exit, and you can see the current queue representation will have only two elements inside it. One is 20, the other one is 30, So its corresponding linked list representation should look like this. Front should be pointing to this node, which is 20, and later another node is 30, and this is followed by null or none, and the rear should be pointing to this node. So overall there are only two nodes inside the linked list, or two elements of the queue, after deleting one element like this. Okay. In this video, we'll implement queue data structure using lists in Python. So first consider name of the list as queue, which is empty currently. Now in order to append some elements into this particular list, so you can go for built-in method, which is append method. So append of, for example, I'm appending A into the queue. Similarly, let us start appending other elements like B and C. B, C. So now we will print this initial queue content. This is the initial queue. Let's print the content of the queue here. Okay. Let us run up to here. You can see this is the initial queue content. We have appended element by element. A, B, C are appended into the queue. So this is the content of the queue as of now. Okay. Now we can perform deletion operation from the queue with the help of pop operation. So for this I'll write elements which are dequeued from the queue, or elements which are deleted from queue. Okay. Now let's print those elements one by one with the help of pop operation. So if you directly write pop operation like this, it will remove element C from this queue. If you write pop of 0, then it will remove A. Since queue data structure operates in FIFO order, so you have to remove the elements which are accessed in FIFO manner, right? So whatever element that is inserted first should be deleted first. Okay. So I'll repeat the same statement for another 2 times, because totally there are 3 elements. So once the entire queue becomes empty, I will display the current queue content. Okay. So by writing queue after removing elements, so let us print this queue content. Okay. Let's run this code and see the result. You can see initially the content of the queue is A, B, C. Now the elements which are deleted from the queue are A, B, C, and finally the queue is becoming empty after removing all these elements one by one. So this is how you can implement queue data structure using lists in Python. In Python, we can also implement queue data structure with the help of dequeue class inside collections module. So here the respective operations for insertion and deletion are, for insertion we go for append, and for deletion we have to use pop left function. Okay. So these are all built-in functions inside the dequeue class under collections module. So for this purpose, I will first import dequeue class from the collections module. I can write like this, from collections import DQ class. Okay. So after importing, we can create a queue using DQ class. So now let us append or insert some elements inside this queue. So the respective function is append function. So q dot append of A, and then q dot append of B. Similarly, q dot append of C. So this is the order we are inserting elements into the queue data structure. Now, for example, if you want to see the content of the queue after performing appending operations like this, so I'll display here initial queue is, and you are displaying this after performing 3 append operations inside the queue. So writing print of queue. Let's run this code and see the result. Initial queue content is A, B, C. This is the initial content of the queue. Okay. Now we can start deleting elements from the queue, which is basically with the help of pop left. So print elements deletion or elements deleted from queue are. So let us delete one by one, element by element. You can see print of q dot pop left function. Okay. So this will remove the elements from the left end of the queue. So you can see this is the entire queue, right? Containing elements A, B, C. When I mean pop left, it will start removing elements from the left end. Okay. So similarly, I'll apply the same function, okay, for 3 times because there are 3 elements available inside the queue. Once the entire queue becomes empty, I'll display the content of the queue. So let's see here, queue after removing elements. I just wanted to display the empty queue to make sure whether the deletion operations are successful or not. So let's run this code, and you can observe here initially the queue content is A, B, C. These are the elements inside the queue. Later we have deleted the elements from the queue one by one by popping left elements. Okay, A, B, C are removed, and finally queue after removing all the elements, you can observe this is completely empty, isn't it? Okay, so this is how it will work. We can also implement queue data structure with the help of a built-in module in Python, which is again queue. And this module provides various functions like max size, empty function, full function, which we have already discussed. Okay, so let us consider this one here. I'm trying to create a queue with maximum size is equal to 3. It means the queue can accommodate a maximum of 3 elements inside it. Now if I run this code, you will see what are the current size of the queue. Currently there is no element inside the queue, so it has to display the result as 0. Okay, so now let us insert some elements into the queue. For example, in order to insert an element inside the queue, so put is a method which is used here. Okay, so you can write q dot put of. So let us insert A into the queue. So similarly, you can insert 2 more elements here. Let us suppose the second element is B and the third element is C. Okay, now we can check whether this queue is full or not, because the maximum size of the queue is 3 and we have already inserted 3 elements inside the queue, right? So for this you can check queue dot full. So print, we are checking whether the queue is full or not. So this can be done with the help of full function, queue dot full function available. Now let's run this code and see the result. You can see initially there are no elements inside the queue. Okay. Later we have inserted 3 elements inside the queue, and now we are displaying entire queue is full. Okay. For example, if I remove this line here and place here, so let's run this code and see the result. You can see queue size is returning a value called 3. Okay. Or here if you want, I can display number of elements in queue are. So how many elements are there inside the queue? There are totally 3 elements inside the queue, and then we are checking whether the queue is full or not. So full, true. Let us suppose if I modify this to 5, in that case is full condition is going to return false, because currently the queue size is 5, but we have inserted only 3 items inside the queue. So you can see number of elements inside the queue are 3 and the queue is not full, hence full colon false. Okay, like this. Now if you want to remove elements from the queue, you can make use of get method here. So this is get method. Okay, now let us print here elements removed from queue are. So whatever elements that you want to remove from the queue are. So you can start printing those elements with the help of get method, that is queue dot get method you can use. And similarly, let us use the same here, queue dot get method. Now run this code and see the result. You can see number of elements inside the queue are 3. Okay, so currently entire queue is not full because the maximum size of the queue we have considered as 5 in this case, and later we have removed the elements in the order A, B, C, isn't it? In this video we'll implement queue data structure using linked lists. First we have to create a node containing 2 parts. One is data part, the other one is next part, and later implement a queue class where you initialize this front pointer and rear pointer to none initially. And next one is isEmpty function, which actually checks whether the queue is empty or not. It will return true if the queue is already empty, otherwise it will return false. So the moment front is pointing to none, we can say the entire queue is empty. So otherwise queue is not empty. Okay. So this is how we can implement isEmpty function. Now let's implement enqueue function. So enqueue function is used to insert an item into the queue data structure. So first you have to take the item which you want to insert inside the queue. We have to create a node with this particular data. So I'll take temp is equal to start creating a node by passing this item as the data. Now while performing insertion operation, remember when the rear is already none, okay, it actually represents the entire queue is empty, which means rear is pointing to none. Okay, in that case whatever node that you are trying to insert will be only node after performing insertion. in such case both front and rear will be pointing to this particular node, which is the only node in the entire queue. Okay, so let's implement this condition. Self dot rear, if this is pointing to none, it represents there is no items inside the queue as of now. So in this case, directly make front and rear to point to temp. Okay, so this is self dot front and also self dot rear, both pointing to temp. Now return. Okay, so suppose if this is not the case, if there are already some elements inside the queue, in such case rear will be pointing to the last element or last node. Now you have to insert a new node after this and move the rear to this newly inserted node. Okay, so for this we can write self dot rear dot next. I am inserting this temp node after the rear corresponding pointing node. Okay, now I'll move this rear to this temp node. This can be done by writing self dot rear is equal to temp. Okay, because the temp is newly inserted node, after insertion rear must be pointing to the last node inside the queue, right? So which means rear should be pointing to this temp node. Okay, so this is how you can actually perform the insertion operation inside the queue. Now let us implement DQ operation here. So next one must be DQ operation, which is deletion of an element from the queue. So in this case, deleting a node from the linked list, because this is linked list implementation of the queue. Now we just need to check whether the queue is empty or not, because on an empty queue you cannot perform the deletion operation, isn't it? So for this purpose we have already implemented isEmpty function, which will check whether the queue is empty or not. So let us use this condition. If is empty, self dot is empty, in that case we can return. Okay, suppose if the queue is not empty, okay, in that case we have to delete the first node from the linked list. Okay, so to remove the first node, make temp to point where the front is pointing to, because the first node will be pointed by the front pointer. Okay, now we can slightly adjust this front pointer by moving to the next node, and this can be done like this. Self dot front must be pointing to the next node, so temp dot next you can write. Okay, so the moment front reaches none, you have to also modify rear to point to none. This case is encountered whenever queue contains only one element and you are trying to perform DQ operation, that is deletion operation on the queue containing a single element. So in such case front will be pointing to none after deletion, isn't it? So you have to ensure that rear is also pointing to none in that case. So this can be implemented as self dot front is pointing to none. In that case we can make rear also to point none. Okay, like this. So this is how you can implement DQ operation, that is deletion operation from the queue. Now let us first create a queue, okay, which is basically an empty queue, and later we'll start performing some NQ operations and DQ operations on that queue. So for this purpose I'll create a queue here. Okay, so queue is the name of the class, and we're creating object for the particular class called queue. Now let us perform enqueue operation. So q dot enqueue operation, I'll insert an element called 10 inside the queue. Okay. Similarly, perform another enqueue operation of element 20, and also another enqueue operation of element 30. Okay. Now let us do dequeue operation here. Q dot dequeue. Okay. So let's run this code, and also one more thing is when you perform this operation, okay, it will give you the result, but it will not be displayed because the moment you are calling enqueue, dequeue, all these operations are performed, but the result is not getting displayed. For this purpose, we have to implement a separate function in order to display the content of the queue. So let us do that. I'll define a function called a display function. Okay, and initially, to display the content of the queue, I'll take temp to point exactly where the front of the queue is pointing. So I'll take self dot front. Okay, now while this temp is not equal to none, I'll iterate this temp pointer to display each and every node corresponding data. So I'll print temp dot data end equal to, suppose if you want to use arrow like this, you can use. Okay, and now I'll also move temp to the next position, temp equal to temp dot next. Okay, and finally I'll print simply none. Okay, I'll print none in the end. Okay, so let's run this code by calling the display function. Okay, so I'll go here, q dot display function. Okay, so let's run this code and see the result. You can see the result is 20, 30, none, because initially we have inserted 10, 20, 30, and we have performed one dequeue operation. Okay, so which means the very first element will be removed, isn't it? Now let's do one thing. So every time I'll perform an enqueue operation and dequeue operation, I'm going to call this display function after every operation. Okay, then you will see how the entire queue gets progress, right? Initially 10. Okay, initially you can see 10, none, and later when you perform another enqueue operation, now you see 10, 20, none, and another enqueue operation of 30. Now it becomes 10, 20, 30, none, and later dequeue operation, removing the first element from the queue where front is pointing, so that element is removed, and finally you will see 20, 30, none. Okay, so this is how you can implement enqueue operation, dequeue operation, and display operation inside the queue data structure using linked list approach. Okay, in this video we'll discuss about circular queues. First, what is a circular queue? Circular queue is nothing but a linear data structure where you will perform all the operations in FIFO order, that is first in first out order, and you can also consider this as a circular buffer or ring buffer. Okay, because the beginning of the circular queue and also the ending of this circular queue will be beside each other. Okay, so you can observe there are totally two attributes. One is front, the other one is rear. Front is denoting the beginning of the circular queue, whereas rear will be denoting the end of the circular queue. So currently front is pointing to this position where it is representing the beginning of the circular queue, and rear is pointing to this position which represents the end of the circular queue. Okay. Now let's see how an insertion operation can be done on a circular queue. So let us consider initially there are three elements inside the circular queue. Now let us suppose I want to insert an element called 56 into this circular queue. Okay. So for this, first you have to increment the rear by 1, and so that this rear will be pointing to the next location where you can perform this insertion. So previously rear is pointing to this position which is 2. Now when you increment by 1, it will move to 3, index 3. Now you can place the element inside this. The same element 56 you are placing inside this location. Okay. And you can see finally this element or this location will be pointed by the rear. Okay. Where exactly the newly inserted element is available. Okay. Now let us consider this algorithm for performing the insertion operation into the circular queue. First we have to check overflow condition. Here in step 2 you can see we are checking whether the circular queue is overflow or not. And later in the step 3 we are checking whether the circular queue is empty or not. If suppose circular queue is empty, in that case we are bringing front and rear to set to 0. So you can see the moment front is -1, it represents the circular queue is empty. So we are bringing front equal to 0 and rear equal to 0. Okay. Now inside step 4, it has reached the maximum capacity. Whenever the entire circular queue is reaching the maximum capacity, in that case you can check like this: rear equal to max -1. So this represents okay, rear has already reached the last index, so bring this rear to the starting index. You can set rear equal to 0. Otherwise you can simply move rear equal to rear plus 1. Okay, in program we write rear equal to rear plus 1 mod max because this is a circular queue. Okay, after reaching the last index you can move to the first index again. So since you are checking in two different conditions whether the rear is pointing to the last index or not, if it is pointing to the last index then you are making rear equal to 0. Otherwise you are simply incrementing rear equal to rear plus 1. So this is also one logic which will work properly. Okay. And finally, after increasing this rear position, okay, after identifying the correct rear position for insertion, then you are going to bring the item into this rear, okay, rear index of the circular queue. So this is how the insertion is carried out in the circular queue. Now consider deleting an element in the circular queue. Initially, you can observe in this queue there are totally 8 elements. Starting from index 0 to index 7, there are totally 8 elements. Now we want to delete an element from this circular queue. So to delete the circular queue element, then front is used. Yes or no? Front is used for deletion operation and rear is used for insertion operation. So starting from front, you just need to increment this front by 1 position. So front will be pointing to this position now, and you can remove this element. Yes or no? So the idea is to just move the front to the next position. Now let's see the algorithm for deleting an element here. So let us first check whether this circular queue is empty or not. Whenever the circular queue is empty, then the front will be representing -1. So the moment front is -1, you can identify it is underflow or entire circular queue is empty. Suppose if this is not the case, then you have to access the element from the circular queue where exactly front is representing the index. The same element is accessed into item. And in step 4, you can see we are checking front equal to rare. Okay. So the moment front has already reached rare, it means whatever insertion operations are performed are now deleted. You just need to bring back front and rare to -1, -1. So this step 4 represents the entire circular queue is becoming empty after performing a few insertion operations and same number of deletion operations. The circular queue is becoming empty. So that's why you have to bring back front equal to -1 and rare equal to -1. And finally in step 5, the moment you see front equal to max -1, it represents front has reached its maximum capacity. In that case, you bring front equal to 0. If this is not the case, you just need to increment front by 1. Okay. So using this if else, you can do like this. Suppose if you are not going to use if else, then you just need to go for a circular queue concept, which is front equal to front plus 1 mod max. So that particular line will be enough instead of writing these 4 lines. Okay. In this video, we'll discuss about tree corresponding terminology. First, what is meant by a tree? Tree is a recursively defined set of one or more nodes where you consider the root node of the tree and all the remaining nodes are inherently partitioned into non-empty set of sets. Okay, and each of which subtree contains a root node. Okay, so what is a root node? In this example, A is said to be a root node. A root node of the tree is nothing but the topmost node in the tree. Whenever this is null, we can say the tree is completely empty. So in this example, you can see A is the root node. Now what is a leaf node? Any node that does not have any children is said to be a leaf node or terminal node. In this example, there are various leaf nodes like E is a leaf node, F is a leaf node, J is a leaf node, K is a leaf node, H is a leaf node, and I is also a leaf node. Because these nodes doesn't have any children. Now, what is a degree of a node? Degree of a node is denoted as number of children that it contains. Generally, if you are considering degree of a leaf node, it is 0. Okay, because the leaf node doesn't have any children. So obviously, its corresponding degree is denoted as 0. Now, in this example, if you consider degree of node A, it has got total of 3 children. So its corresponding degree will be 3. Okay. Similarly, node G has got 2 children. So degree of node G is equal to 2. Okay. Now, how can we define height of a tree? Height of a tree is nothing but total number of nodes on the path from which the root node to the deepest node in the tree you have to consider. So in this example, if you consider the deepest path is from root node A up to the leaf node J or to the leaf node K. Okay. So these paths are said to be deepest path in the entire tree. So that's why if you start counting the number of nodes in this deepest path A, C, G, J. So these are the 4 nodes that are part of this path. Okay. So we can consider this as the height of the tree. Okay. Now, if you consider any tree containing only a root node, then its corresponding height is considered as 1. Okay. Now let us discuss about binary tree. In every binary tree, the topmost element is considered as a root node and each node will have either 0 or 1 or at most 2 children. Now if you consider this example, One is representing the root node and it has got two subtrees. One is a T1, the other one is T2. Inside subtree T1, again, each and every node will have at most two children. That is either 0 or 1 or 2 children. Okay. This is the property of the binary tree. It cannot have more than two children at each and every node in the entire tree. Okay. Now let's discuss about complete binary tree. So in case of complete binary tree, it must satisfy two properties. One is completely filled. The entire binary tree should be completely filled except possibly at the last level. All the remaining levels should be completed. Now, if you look at this example, this is the first level, then second level, third level, and fourth level. This is representing the last level, right? So, except the last level, each and every level should be filled. So, that is what the meaning of completely filled. And the second property is as left as possible. You should start filling these nodes from left to right. So there can be empty in the last level on the right side but not on the left. Okay. So you can't have nodes here by not filling the previous left nodes. Okay. So this is the meaning of the complete binary tree. There are two ways in which we can represent a binary tree. One is array representation, the other one is linked list representation. Now we'll discuss about array representation of a binary tree. So first you have to represent very first root node at index number 1. Okay. Let us suppose we are leaving index 0 and starting with index number 1. Okay. So I'll call this as array name called tree. And in this array, we are going to consider very first node, that is root node located at index number 1, and the value inside this is 20, right? Okay. Now consider its corresponding left child. So always remember the formula. For example, we have a root node like this and its left child is here and its right child is here. So root node is represented at index number k, for example. Then its left child should be represented at index number 2 into k. Also its corresponding right child must be denoted at 2 into k plus 1. Okay. So for this, you can see here 2 into k, the root node corresponding index is 1, 2 into 1 is 2, which means 15 must be denoted at index number 2. Okay, just like this. 15 is indicated at index number 2. Now 35 must be denoted at index number 2 into k plus 1, where k is equal to 1. So 2 into 1 plus 1, this is going to be index number 3. Okay. So at index 3, we have to denote 35. Okay. Now, similarly, if you move to the next level, here 12 should be denoted at 2 into k. So which means this is going to be 2 into 2. Okay, 2 into 2, which is 4. That is at index number 4, you will see 12. 2 into 2 plus 1. At index number 5. Okay, you have to indicate this 17. Similarly. Okay. Now, if you look at the right subtree, now for the right subtree corresponding left child, this should be indicated at 2 into k. So 2 into 3, which is nothing but 6. At index number 6, you have to indicate 21. Okay. Similarly, this is going to be 2 into 3 plus 1. Okay. So which will give you 7, index number 7, to indicate value 39. Okay. Now if you look at this 16, where this 16 should be placed, 2 into 5, that is index number 10, and 18 must be placed at 2 into 5 plus 1, index number 11. Okay. Now similarly, its left child, so this is currently indicating index number 7, right? Its left child is 2 into k, that is 2 into 7, which is going to be 14, and the right child is located at 2 into 7 plus 1, which is 15. Okay. So which means again at index 10 you will observe element 16 available, and similarly at index number 11 you will see element 18 available. Okay. And afterwards again at index 14 you will see 36 available, index number 14, and then at index number 15 element 45 is available. Okay. So this is how we have to represent using array for a given binary tree. Now let's move to represent this in the linked list format. Okay. So in order to represent in the form of a linked list, you have to consider node. Each node will have total of 3 parts. So first part is left, and the second part is a data part, and third part is right part. Okay. So let us represent the same here. The root node should be denoted using like this. So this is the data part. Now this is representing left and this is representing right. Okay. Now its corresponding left is stored here, and similarly its corresponding right child is denoted like this. Now again there is a subtree for this. So again represent in the form of a node containing 3 parts, and those 3 parts are like this, and the data part contains 4. And similarly right node, it contains 3 parts, so the data is 5 here. Okay. And you can see here subsequently this is 8 and this is 9. Now you can observe these nodes are clearly leaf nodes. So for leaf nodes this should be null, right? So left is null and also right is indicated as null. Similarly this is null and this is also null. Okay. And here also 5 is a leaf node. This is representing null and this is also representing null. Now you can observe for this the node contains again a total of 3 parts. Okay. And this is containing data as 10. Now this is null and this is also null. And if you see here, this node contains data as 11 and this is null, also this is null. Okay. And finally you can see here for this node its corresponding right child contains data as 7 and its left child is null, whereas its corresponding right child again contains a total of 3 parts, data is 12, and both left is null and also right is null. Okay. So this is how you can actually indicate the entire linked list representation for a given binary tree. And how can you define a node? Okay, here you can define the node just like this. You can write in the form of a class. Okay, so I'll write like this. This is going to be a class node, and the node contains a total of 3 parts, right? So I'll go for defining with the help of a default constructor or init method. So I'll read the value, okay, here. And initially for any node, left is going to be null and right is also null, or you can say left is none, right is none. So here you can write self dot left is equal to none, and this is self dot data is equal to value, and similarly self dot right is equal to none. Okay, so this is how you can represent the entire node. Okay, now let us discuss about binary tree traversals. There are basically 3 types of traversals available here. One is in-order traversal, second one is pre-order traversal, third one is post-order traversal. Now explore each of these traversal techniques on a binary tree. First one is in-order traversal. According to in-order traversal, first we have to traverse the left subtree, later visit the root node, then traverse the right subtree. For example, if you are considering this tree, this is considered as the root node, and this is left subtree, and this is representing a right subtree. Okay. Now first you have to traverse the left subtree, which means after traversing this you will get its corresponding in order traversal result as first B will be traversed, and later you need to visit the root node. So this is the root node, A is the root node, and after A now visit the right subtree, that is right node must be visited, which is C. So this is representing in order traversal. Now let us consider this example and traverse using in order. So again, whenever you are asked to find the in order traversal, first traverse the left subtree and later move to the root node and then move to the right node or right subtree. So in this example, left subtree is this part. This is representing left subtree. Again, within this left subtree, you have to traverse using left root right. So the corresponding result will be left root right. Left node is D, then root node is B, and the right node is E. So you can represent this as D comma B comma E. Once the entire left subtree is over, now traverse to the root node. Root node is A, and then right subtree. Inside this right subtree, traverse using left root right. So left node is not there, root node is C, and right node is F. Okay. So this is the result of in order traversal for this particular tree. Now let us explore pre-order traversal. According to pre-order traversal, you have to traverse starting with the root node, followed by the left subtree, and then followed by the right subtree. So in this particular tree, consider this is a root node. First, this is the root node, and later traverse to the left subtree part, then traverse to the right subtree part. Okay. Now let us consider for this what will be the pre-order traversal result. So you can see first starting with the root node A and then moving to the left subtree B and then moving to the right subtree C. This is the pre-order traversal result. Next, consider this particular tree and traverse using pre-order traversal. According to pre-order traversal, first you have to traverse the root node, then you have to consider the left subtree, then followed by the right subtree part. Okay. Now starting with the root node part, first write down this corresponding pre-order traversal result. So starting with root node, A is the root node, and then consider the left subtree. Inside this left subtree, again traverse using root left right. So B being the root node, then followed by the left node, then followed by the right node. So this is going to be B comma D comma E. And once the left subtree is over, now consider the right subtree. Inside this right subtree, you have to traverse using root comma left comma right. So root is C and the left is not there. The left child is not there for this. Now move to the right subtree. So inside right subtree, we will find F. So this is the corresponding result for the pre-order traversal. Okay. Now consider post-order traversal. According to post-order traversal, you have to traverse the left subtree first, then right subtree, then visit the root node. Which means first you have to go to this left subtree part, then move to the right subtree part, and later visit this root node. This is the order. Suppose if we follow the same order, what will be the result for this according to post-order traversal? So this is going to be the left subtree part B, and later right subtree part C, then root node part A. So this is going to be the post-order traversal result. Okay. Now consider this example and traverse using post-order. So according to post-order traversal, first we have to consider the left subtree part, then we have to consider right subtree, and later consider the root node. Okay. Now according to this left subtree part, you can see this is going to be the left subtree. And within this left subtree, you have to traverse using left right root. So which means this post order traversal result should be left comma right comma root. So this is a D comma E comma B. So once the entire left subtree is over, now traverse to the right subtree. Again in this right subtree, consider left right root. So left part is not there, so move to the right and then consider the root node, and later since the left subtree and right subtree both are completed, so you have to visit the root node, which is A. Okay. So this is how you can traverse using post order traversal. In this video, we'll see how to implement in-order traversal. First, you have to consider the structure of the binary tree corresponding node. And this can be denoted with class node, which contains several data attributes. For example, the data attribute is used to store the value. And you can consider left and right attributes which are used to basically point to the left and right children. Okay. Next, we are going to define the in-order traversal function that performs the in-order traversal on the binary tree. The function will take node as input and it follows a recursive approach. Okay. Now inside this in-order traversal function, we need to check whether the node is none or not. If suppose the node is not none, we recursively traverse the left subtree by calling in-order traversal on the left child of the current node. And after that, we traverse the left subtree, we print the data of the current node. And in this implementation, we use print node.data, which is basically used to print the data. Okay. And after that, it will create some space. And then finally, we recursively traverse the right subtree by calling in-order traversal of node.right. So, which is a recursive traversal of the right subtree. Okay. Now, If you look at this, it is representing the binary tree representation. Okay. What is the root node? Root node is 4. And what is the left child of this root node? You can see for this node, the left child is 2. That's why you have to indicate like this: root dot left is equal to node of 2. And similarly for this root node, what is its corresponding right? So this right node is basically 6, right? So root dot right equal to node of 6. And similarly, we are going to build the entire binary tree. And finally, when you call the in-order traversal function, it will produce the output like this. For this particular tree, if you perform in-order traversal, you will see the output is 1, 2, 3, 4, 5, 6, 7. Okay. Like this. Now we will see how to implement pre-order traversal. We first begin by defining the structure of a binary tree node by using a class node. And each of this node will have a data attribute in order to store the value. Also left and right attributes, which will actually point to its left and right children correspondingly. Now, this is the function for pre-order traversal. It performs the pre-order traversal on the binary tree, and this function is taking a node as input, and it follows a recursive implementation. Now, inside this pre-order traversal function, first we have to check if the node is not none. If the node is not none, then we print the data of the current node. In this implementation, we use print of node.data and followed by end equal to space in order to just print the data and separate it with a space. Okay. So after printing the current node's corresponding data, we recursively traverse the left subtree by calling pre-order traversal on the left child of the current node. Next, we recursively traverse the right subtree by calling pre-order traversal on the right child of the current node. And finally, we have to represent this binary tree. And the example of the binary tree, we are considering this one because this is the root node. 4 is the root node. You have to create a node with data as 4 and assign it to root. And its corresponding left, root dot left is 2. So you have to create a node with data as 2. And similarly, root right is 6. So in this way, we build the entire binary tree corresponding code. And finally, you have to call this pre-order traversal function. And while calling this pre-order traversal function, you have to pass the root node as parameter. And once this is passed, the entire pre-order traversal is performed on this binary tree and it will display the output like this. Okay. Now we'll see how to implement post-order traversal on a binary tree. First, we have to begin by defining the structure of the binary tree, that is node structure, because the binary tree contains all nodes. Okay, and each node will have this structure. It contains data attribute which is used to store the value, and then left and right attributes. Usually this left attribute is used to point to the left child and right attribute is used to point to the right child, and initially they are none. Okay. Now in this post order traversal implementation, so this is taking a node as input and the entire implementation is a recursive implementation. Okay. Now inside this post order traversal function, we check whether the node is none or not. If the node is not none, we first recursively traverse the left subtree by calling the post order traversal on the left child of the current node. And after traversing the left subtree, we recursively traverse the right subtree by calling a post order traversal on the right child of the current node. And finally, we print the data of the current node. And in this implementation, to separate data values, we are using n equal to space. Suppose if you are using n equal to comma, then it will separate the data with comma. Okay. And here you can see binary tree representation. This is the binary tree corresponding representation. As the root node corresponding data is 4, so root equal to node of 4. And then root corresponding left is 2, root corresponding right is 6. Okay, like this. And when you call the post order traversal on this particular tree, you will see the output as 1, 3, 2, 5, 7, 6, 4, which is the corresponding post order traversal obtained by traversing the left subtree first, then right subtree, and followed by the root node. Okay, you can see inside this particular subtree, again if you apply left right root, you will get 1, 3, 2. Once the left subtree is over, then you move to the right subtree. Again, the right subtree is traversed in the order of left, right root, which is 5, 7, 6. Since the left subtree and right subtree both are completed, finally you have to indicate the root node. So, which is nothing but the given output. Okay. Now we'll see how to find the height of the binary tree in Python. First, what is meant by height of the binary tree? It is nothing but the maximum number of edges that are in the longest path from the root node to the leaf node. Now this height can be computed using a recursive approach where you will start with the root node, and first you are going to check whether the root node is none or not. If it is already none, you have to return 0. Otherwise, you can recursively calculate the height of the left subtree as well as the height of the right subtree, and finally return the maximum height between the left and right subtrees plus 1, because we are starting from the root node. Now, initially we have to consider the node structure. A node containing total of 3 attributes. One is a data part, the other one is left and right attributes, where left is pointing to the left children and right attribute is pointing to the right children. Okay, and initially left and right both are none. Okay. Now to compute height of the binary tree, we are taking a recursive approach to compute this height, where the function takes node as the parameter, and first we are checking whether this node is none or not. As we are starting from the root node, we have to check whether this root node is none or not. The moment it is none, it has to return 0, because the height of an empty tree is 0. Okay, and also this if condition serves as the base condition for this recursive implementation. And if the node is not none, it will move to the else block, and here recursively we are calculating the left height, which is the height of the left subtree, and similarly recursively we are computing the height of the right subtree, and then return the maximum height obtained among left height and right height plus 1, where plus 1 is for, as we are starting from the root node, you have to count that particular height also. So that is how you have to call max of left height comma right height plus 1 recursively. Okay, so this is how you can compute, and all you need to do is call this particular function after creating the tree. Okay, you just need to call this a tree height function after implementing binary tree corresponding implementation in Python, and then call this particular function to obtain the height of the binary tree. Okay. Yes, we're asked to write a program in order to print sum of all elements of a binary tree. So let us consider a sample binary tree here and perform summation of all elements of a binary tree. So let us consider this is the binary tree I'm considering here. So this is 1, 2, 3, 4 and 5. Okay. So consider this is the binary tree. Now sum of all elements of a binary tree means so look at the values of each node. So from this node you will get 1 plus, and from this node you will get 2 plus, this node data is 3 plus, and this node corresponding data is 4 plus, and this node corresponding data is 5. So this is going to be 1 plus 2 plus 3 plus 4 plus 5, and this will give you the result as 15. Okay, which is nothing but the sum of all elements of a binary tree. Okay, so let's see how this can be implemented. Okay, so here you can observe I'm taking initially the root node corresponding data is 1, and it has got a left child which is 2 corresponding data, and right child corresponding data is 3, and so on like this. Okay, so if I start constructing the entire tree for these lines, okay, so you can observe 1 is the root node, and then what is its left child, 2 is the left child, and then 3 is the right child, and here you can see left dot left is 4, so this is 4, and left dot right is 5. Next, right dot left is considered as 6, and then right dot right is considered as 7. Okay, now root dot right dot left dot right, and this is considered as 8. Okay, now for this binary tree you can observe this is the root node, this is representing root node, and for this root node we are passing this root node as parameter to add bt function. So where this add bt function must be performing summation of all these nodes corresponding data and storing the result inside the sum, and later we are displaying the sum of all nodes as sum. Okay, now let's work on sum equal to add bt of root. Okay, so this is the function, right? So this function is going to give you the result as sum of all elements in the binary tree. Okay, and this part you already know, this is basically a new node. We have taken class name as new node, and this is a constructor in order to create a new node. Okay, so every node will be in this format. It will have total of 3 parts. Okay, the first part will be the left. Okay, the second part is the key part, and the third part is the right part. Clear? So now let us see this add bt function. Okay, so initially we are going to check whether this is a root node or not. Okay, so root is none or not. You can observe whenever root is none we can return immediately 0. Okay, so I'll show you here for a sample tree. Okay, consider a small tree like root node is 1. Okay, left node is 2, and the right node is 3. So for this tree, let's see how this is going to give you the result, whatever code that we have implemented on add bt. Okay, so here this will look like this according to this linked list representation. So this is the root node, right? This is root node, okay, and its corresponding data will be like this. So this is left part and this is right part, and inside this left part you will see again a total of 3 parts, okay, and again in the right you will see this node containing 3 parts, and this is clearly none, and this is also none, this is also none, and this is also none for this example, okay. So initially we are checking root is none or not. Currently root is not none. So this is going to perform or return root dot key. Okay. So you can see what is the root dot key. Root dot key is plus. So plus, that is 1. Root dot key is 1 here. So 1 plus add bt of root dot left. So it is going to call the same function add bt again by passing root dot left as parameter. So when it calls like this, then in the subsequent recursive call, root will be pointing to this node. Okay. So when the root is pointing to this node, again for this recursive call, it will be look like this, right? Okay. So you can observe for this recursive call, it is again 2 plus. Okay. So this is going to be 2 plus add bt of root dot left plus add bt of root dot right. In that case, you can see root dot left is none and right is also none. It will return 0. So 0 plus 0. Okay. So this is this one. Now, similarly, how this add bt of root dot right is done. Okay. So again for this it is going to be root dot key. So in this case root will be pointing to this one, and root dot key value is clearly 3. 3 plus again it will call the same function by passing root dot left, which is this one, and this is already none, and also root dot right. So this is also none. So which will give you 0 plus 0. Okay. So overall, this is going to be 1 plus 2 plus 3. The result is 6. So finally, it will return 6 because for this small binary tree, some of the nodes corresponding data will lead to 6. Okay. So this is how we can solve this problem. Now let us discuss about binary search trees. So binary search trees will follow the properties of the binary tree, as well as binary search tree has its own properties. So the first property is left subtree of the node contains only nodes which are lesser than the node corresponding key value. Okay. So which means you can consider this is the root node corresponding key value, and this is the left child corresponding key value. So this key value must be lesser than this root node key value. Similarly, I am considering a right node key value as Ri. Okay. And this right node key value must be greater than the root node key value. Okay. And always remember, this left and right subtrees are going to follow the same properties recursively. Okay, there is a property of the binary search tree. Okay, now consider these examples. So this is a binary search tree. In this binary search tree, if you are trying to search okay, an element starting from the root node, you have to search. Okay. So before going into the search, first let us check whether this is a binary search tree or not. Okay. And you can observe this is clearly a binary search tree because the root node corresponding key value is greater than the left child and less than the right child key value. And similarly here also the root node key value 3 is greater than the left child key value and smaller than the right child key value. Okay. Similarly, this node corresponding key value is smaller than its root node key value. So the properties of the binary search tree is clearly satisfied at each and every node. Hence, you can say this is a binary search tree. Now, let us consider the other binary search tree given here. And this is not a binary search tree clearly because this is violating the properties of the binary search tree. Okay. So here clearly value of 11, okay, since 11 is greater than 5 and also greater than 10, 11 should be appearing somewhere here, but it is placed here, isn't it? This will violate the property of the binary search tree. So you can say this is not a binary search tree clearly. Okay. So in order to create a new node in a binary search tree, okay, so the node representation is simply a node containing a total of 3 parts. So the first part, second part and third part. So the first part is representing left here. This is left. And the second part is representing key. And the third part is representing right. Okay. Like this. And initially left is none and also right is none. Okay. So the key value is based on whatever value that you are passing while creating the node. So just like you will create a node by passing some value like 15 here. So which means the key value will be stored as 15 and the same key value will be held here. Okay. Like this. Now let us consider searching an element in the existing binary search tree. So for example, if you are trying to search an element called 7, so which means key value that you are searching is 7 here. So first you have to compare with the root node corresponding key value. Since 7 is less than 20, you have to traverse to the left subtree for searching 7. Okay. Now compare 7 with this node key value. Since 7 is clearly greater than 5, start searching in the right subtree. Okay. Now consider this node corresponding key value. As 7 is less than this key value, start searching in the left subtree now. Okay. And now consider this node key value. 7 is clearly less than 9. So start searching in the left subtree from here. And finally you can observe 7 equal to 7. The element is found. Okay. This is how you can perform searching inside the binary search tree. Now this is a function to perform searching of a key element in the binary search tree. And this is done recursively. Okay. So look at this search function. And this search function takes root node and also the key element that you are searching inside the binary search tree. First you have to check whether the root is none or not. So root is none representing an empty binary search tree. Okay. Binary search tree can be empty, or if you consider root dot key double equal to key. For example, directly the search element is matching with the root node corresponding key value. This is also another case. So if this happens, then directly you return the root node. Okay. Now, if the entire BST is neither empty nor the key value is matching to the root node key value, in such case, we have another condition. Let us suppose the root node corresponding key value is less than the key value that you are searching for. In such case, you have to start searching this key node inside the right subtree of this root node. Okay. So you are recursively calling the search function by passing root dot right as the first parameter and the same key value. Suppose if this condition of root node dot key value less than key is false, in such case you can say root node dot key value, that is a root corresponding key value, is greater than the key value that you are searching for. In such case, you have to traverse to the left subtree and identify this key element. Okay. So in that case, you can directly write like this, calling the search function recursively by passing the root corresponding left and also the key value that you are searching for. Okay. So this is how you can search inside a BST or binary search tree for a given key value. Okay. Now let us see inserting a node in the binary search tree. Let us suppose you are trying to insert a new node called 6. Okay. So whatever key value that you are considering here is for insertion. So the key value is 6. You can create a new node with this particular key value and start inserting this node. Okay. For this purpose, you have to start from the root node of the existing binary search tree. So since 6 is greater than 5, the insertion must happen on the right subtree. So again in the right subtree, you have to check 6 with 8. Since 6 is less than 8, the insertion must take place on the left subtree. So in the left subtree, again compare 6 with 7. Since 6 is less than 7, insertion must be taken place on the left subtree. So 6 must be inserted here. Okay. So now let us see how this can be implemented as part of the insertion function in Python. So first we are defining the insert function and the node. Okay. So currently the node will be pointing to the root node of the existing binary search tree and later key value. Okay. In our previous example, key is equal to 6. So in the same way, it will have a value. And now we are trying to check whether the existing binary search tree root node is none or not. Okay. So this represents the existing BST is empty. Okay. So you can observe this is the case where you will observe binary search tree is empty. So when you find out the binary search tree is currently empty, then after insertion you will see only this key value which is becoming a node because you are passing this key value as to the node class, and this will create a new node containing data as key value. Okay. So this is the case when the binary search tree is empty. When BST is empty, inserting a new node will make the binary search tree containing a single node. Okay. So now we have another condition here. Key less than node dot key. Node is representing root node dot key. So whenever the value that you are trying to insert is less than the root node corresponding key value, then you have to traverse to the left subtree and perform this insertion operation. So that's why to traverse towards the left from the root node, you have to access root node dot left is equal to, you are performing recursively the same insertion operation by passing node dot left with the same key value. Okay. And there is another case where the key value is greater than the root node corresponding key value. In such case, the insertion must be carried out on the right subtree part. Okay. So that's why you can write node dot right is equal to, perform the same insertion operation by calling the function recursively, but this time pass node dot right instead of node. Okay. With the same key value. Okay. So this will recursively perform insertion operation on the binary search tree and finally we are returning the root node key value. Okay, that is directly a root node, because after inserting a new node, the updated binary search tree we have to access. That is why we are returning the root node in this case. Okay. Now let us create a binary search tree using these data elements. So the data elements are given as 43, 10, 79, 90, 12 and 54. Okay. So the same elements can be inserted with the help of an insert function by starting from the root node. So initially root will be none. So you will be starting from the root node and start inserting a element. First element as 43 and later insert the second element 10. Next insert the next element 79. Later 90. Then 12. Finally the last element inserted is 54. Okay. Now let's see how this binary search tree getting created step by step while inserting these elements. So the very first element that you have inserted is 43. So which means 43 will become the root node. 43 will become the root node. And the next element is 10. Since 10 is less than 43, it must be inserted towards the left. Okay. So the element 10 gets inserted in this position. And the next element is 79. Since 79 is greater than the root node key value 43, so it must be inserted on the right subtree. So this 79 will be inserted here. Okay. And very next element is 90. So let's see where this 90 will be inserted. So again this 90 is greater than the root node key value, which is 43. Okay. So it must be placed on the right subtree from the root node. And again right child key value is 79. 90 is still greater than 79, condition true. So this node containing data as 90 must be inserted in this position. Okay. And the next element is 12. So first we have to check 12 is less than 43 or not. So you can see clearly 12 is less than 43. 12 must be inserted towards left. Okay. Now if you look at this left child 10, 12 is greater than 10. So 12 must be inserted as the right child of this node. Okay. And finally the last node key value is 54. So 54 is compared with the root node key value. 54 is greater than 43. So the insertion must take place on the right subtree. And again 54 is compared with 79. 54 is less than 79. So 54 will be inserted in this position. Okay. So this is how you can create the entire binary search tree. Now let us discuss about graph data structure. Graph can be defined as simply G is equal to V comma E, where V is representing the vertices inside the graph and E is representing the edges that are connecting these vertices. So you can observe here V of G is actually representing this set of vertices, and E of G, we are writing the notation as E of G, which will represent the edges that are connecting these vertices. Now there are two basic types of graphs. One is directed graph, the other one is undirected graph. Now let us explore about undirected graph. In case of undirected graph, there won't be any directions pointing from one vertex to another vertex. So this is clearly representing like this. Since it is undirected, there is a path from A to B, which also implies there is a path from B to A. Okay. So if there is an edge that is connecting between two vertices A and B, it means you can reach from A to B using this particular edge. In the same way, you can also reach from B to A using the same edge. So if you start counting the number of vertices here, the number of vertices are 1, 2, 3, 4, 5. And now let's see how many edges are there. This is one edge, this is another edge, this is the third edge, then fourth edge, fifth edge, and finally sixth edge. So the same are represented as part of the edges of this undirected graph representation. Now let us explore directed graph representation. In case of directed graph, there is a direction clearly specified from one vertex to another vertex, which means if there is a direction from A to B, it represents you can traverse from A to B but cannot move from B to A back. So let us see this example. A to B, there is a directed edge. It means you can only traverse in this direction but not the other way around. So if you observe the number of vertices here, there are totally 1, 2, 3, 4, 5. 5 vertices are there. And if you start counting the number of edges, that is E of G, it is clearly specified as A comma B. You can traverse from A to B, and then A to D, A comma D. Also from B to D you can traverse. Also you can traverse from C to B, and also from D to E, and finally E to C. There are totally, you can observe clearly 1, 2, 3, 4, 5, 6 edges. 1, 2, 3, 4, 5, 6 edges. Okay. Like this you can represent a directed graph. Now let us discuss how we can store this graph data structure inside memory. And this can be done in two ways. One is sequential representation, that is with the help of adjacency matrix, and the other one is linked representation, which will make use of linked list concept to store, and it is considered as adjacency list representation. Now let us explore about adjacency matrix representation. In case of adjacency matrix representation, if you are considering two vertices, vertex Vi and Vj, vertex Vi, and there is another vertex called Vj. Let us suppose vertex Vi is adjacent to vertex Vj. In that case, you can represent inside the matrix, adjacency matrix. If this is representing vertex Vi and this is representing vertex Vj, here you have to represent as 1, because there is an edge representing from Vi to Vj. As Vi and Vj vertices are adjacent to each other, you have to represent 1. Suppose if it is not adjacent, in that case you have to represent 0. So let us go through an example here. So this is the given graph for which you have to find out the adjacency matrix representation. So first generate what are the different vertices for this graph. There are totally 5 vertices are available. So vertex A, vertex B, vertex C, vertex D and vertex E. Similarly, you can observe vertex A here, vertex B, vertex C, vertex D and vertex E. Now let us see how we can represent adjacency matrix here. A to A there is no edge, so you have to represent it as 0. And if you observe A and B, there is an edge which is connecting from A to B, which means you can say A and B are adjacent to each other. So you can represent 1 here, and also B to A also represents 1 similarly. Now let us see B to C. Okay, or starting from A, let us finish the first row. A to B is done. Now A to D. A to D there is an edge, and there is no other edge that is coming from A. So these two values must be 0. Now let's go through B. B is adjacent to A, B is adjacent to D, and B is also adjacent to C. So exactly at C and D you have to represent 1, 1. In the remaining places you have to represent 0. Now let us see vertex C. From vertex C it is adjacent to vertex B and vertex E. So exactly at vertex B you have to represent 1. Also at vertex E you have to represent 1. And all the remaining places it must be 0. Now consider vertex D. From vertex D it is adjacent to vertex A, vertex B and vertex E. So you have to represent 1 here, vertex A. Since D is adjacent to vertex A, also D is adjacent to vertex B, and D is also adjacent to vertex E. In all other vertices it should be 0. And finally vertex E. You can observe vertex E is adjacent to only vertex C and vertex D. So exactly at vertex C and vertex D you will be representing 1. In the remaining places you have to place 0. So this is how you can represent a adjacency matrix representation. Now let us suppose you are given a directed graph and you have to represent the adjacency matrix for the same. In such case, again write down all the vertices which are part of this graph: vertex A, vertex B, vertex C, vertex D and vertex E. Now similarly you have vertex A, vertex B, vertex C, vertex D and vertex E here. Vertex A and vertex B are adjacent, that is A to B is the corresponding edge here, okay, but not B to A. Because this is directed graph, you can only move from A to B, but not from B to A using this particular edge. So A to B you have to represent it as 1, and A to A will be 0, and A to D will be 1, and remaining will be zeros. Now consider vertex B. What are the outgoing edges from vertex B? From vertex B it is only moving towards D. So B to D you have to represent. In all other cases this is going to be 0 because all other are not there, because there is only one outgoing edge from vertex B. Similarly consider vertex C. What are the outgoing edges from vertex C? So it is only this particular edge. C to B you have to represent it as 1. In all other places this is going to be 0. Now consider vertex D. There is an outgoing edge from vertex D to vertex E. You have to represent this as 1. In all other cases this is going to be 0. Now consider vertex E. There is an outgoing edge from vertex E to vertex C. So represent here as 1, E to C. In all other cases this is going to be 0. Now if you observe adjacency matrix representation of a directed graph, it is not symmetric. Whereas if you consider the adjacency matrix representation of an undirected graph, it is clearly symmetric, because based on the definition of a directed graph and undirected graph, the same thing is applicable here also. Because in undirected graph, A to B also represents B to A. That is why you can see A to B you are representing 1, and also from B to A you are representing 1. But whereas in case of undirected graph to directed graph, okay, so A to B is different from B to A. That's why if there is an edge from A to B, you are representing 1, but from B to A you are not going to represent 1. So that is the reason. Hence, if you say a matrix or adjacency matrix for a graph is symmetric, then that symmetric property is applicable for undirected graphs, and symmetric property is not applicable for directed graphs. Now consider adjacency list representation of the graph data structure. In this case we are considering an undirected graph. For this undirected graph you can observe how many vertices are there. Totally 5 vertices are there: A, B, C, D, E. So all the 5 vertices are represented here, one after the other. Now A is adjacent to vertex B and also vertex D. So you have to represent those two vertices, vertex B and vertex D, and after that there are no other vertices, so you have to make this as none or null. And similarly for vertex B is adjacent to vertex A, vertex C and also vertex D. The same thing you have to represent here, vertex A, vertex C, vertex D and finally none. This is how you have to represent for each vertex what are the vertices that are adjacent to that particular vertex, and these details must be represented in the form of a adjacency list representation for each vertex. Now consider adjacency list representation for a directed graph. In case of a directed graph, you can observe here there are totally 4 vertices available, A, B, C, D. And there is a directed edge from A to B, an outgoing edge from A to B, and also from A to C. It means for vertex A, you will see the vertices B and C are adjacent to each other. Okay. So also consider vertex B. For example, if you are considering for vertex B, what are the vertices that are adjacent to vertex B? So for this you have to identify the outgoing edges for vertex number B. For this vertex B, the outgoing edges will be clearly vertex C and vertex D. So you have to represent them here just like this. Now similarly for vertex C, you can observe the outgoing edge is vertex D. And also for vertex D, the outgoing edges are vertex A and vertex B, isn't it? So this is how you have to represent these vertices as part of the adjacency list representation. And for a vertex, if you want to keep them as part of the adjacency list representation of that vertex, they have to be adjacent to this vertex. Okay.
Imagine a world where education transcends boundaries, where every aspiring tech leader has access to high-quality training tailored to industry needs. We aim to bridge the gap between academia and real-world skills, forging partnerships with educational institutions and tech giants. Our mission is not just to teach, but to inspire innovation, creating a workforce ready to tackle the challenges of tomorrow. This is about revolutionizing learning, making it a lifelong journey that evolves with the digital landscape. Together, we can empower the next generation to not only succeed, but to lead in an ever-changing global market. Ultimately, our vision is to be a catalyst for change in the education sector, making learning a continuous, lifelong journey that adapts to the evolving demands of the digital age. Through this, we aim to contribute to the development of a more knowledgeable, skilled, and empowered global workforce.